Good morning, ladies and gentlemen. The programme will begin in 5 minutes. Please take your seats now and silence all personal electronic devices. Thank you.
Hey everyone, I actually don't know why you're clapping me. I'm the boring one today. So welcome everyone. I'm actually on stage for a couple of minutes. I'm here to talk about some of the logistics for today and tomorrow. It is a 2-day event. There was some confusion about kind of like what day 2 is. We've got a whole bunch more talks on the second day, so just to let everyone know, everyone's tickets are still valid for the second day, which is a good thing. So anyway, hello everyone, welcome. My name is Paul Kinlan. For anyone who doesn't know me, I work on the Chrome and the Web Developer Relations team at Google. And it's actually really exciting to be here, not only because it's a great city and it's great to talk to you, all you guys, is that I get to bring the weather with me, right? Like in Liverpool, it was raining when I left. And I'm sorry about that if it was me. But yeah, I'm only here to do the logistics today, to talk about kind of some of the things that are happening and the overall flow of the event. We've got a whole bunch of great speakers today. And I will say sorry to our captioners and everything because I speak really quickly as well, so that's the other thing. I do want to highlight one other thing as well. It is a free event and we do have security at this venue, but please do make sure that you keep all your belongings with you at all time and you know where they are. That will really help out. So I'd also like to say hello and welcome to our live stream. This was kind of organized really last minute, and then the team behind this has done a whole bunch of really great things. We have about 60. I know the numbers don't add up. But we have about 60 different live stream kind of viewing parties that are happening around the globe as well. So we have some in Kuala Lumpur, we have some in Japan, China. There's a whole host of them happening in Africa. I'm really amazed if anyone, I can't even see the screen, if anyone's up at America this time, but maybe that'll happen, and that's pretty good. But we have like a wider global audience around this, which is really, really good. It's really nice to see. So one of the things I want to say and highlight, and this is a really important thing from our side, is there is a code of conduct for this event. We want everyone to have the best possible experience at this inaugural, maybe even more, Progressive Web App Dev Summit. This is an inclusive community, and no matter your experience or your background, you're welcome here. We encourage you to be excellent to each other. It sounds very Bill and Ted, that. But you say hi to new faces, people that you don't know, build on one another's ideas, and if you have any uncomfortable experiences, please report them to us. We have a number of staff around the venue. They're either in the blue shirts, the speakers, or we have an email address as well that you can kind of contact if you have any issues. We do have a zero policy tolerance policy for harassment of any kind, and our full code of conduct is available on this site. And I would encourage everyone to kind of read it if you haven't already done it. There are a number of other posters and signs around the venue for you to be able to read and kind of see what's happening as well. The other part as well is please do share any constructive or positive feedback that you have as well. And like I said before, the staff can be identified around the venue, and we're here to help you have a great event. So that's one thing. The other bit as well, it's a very tightly packed agenda today. It's talk after talk after talk. And whilst we have breaks, we don't have much time for question and answers. So we have 2 or 3 different ways that you can contact us. If you haven't already, join the Chromium Dev Slack channel. We have our entire team available and ready to answer questions as they come through. So if you have questions in any of the talks, just feel free to drop something in. Either the speaker, when they finish, will answer the questions, or the people from our team will also be able to answer them kind of there and then. Or if you want to use Twitter and maybe even promote the event, you don't have to, but if you want to talk to us around this, get in contact with us on the Chromium Dev team, and our team, again, will be available and happy to help. We do have a codelab session. It's on the 3rd floor, codelab area as well. So you can go in, there's power, and there's a whole bunch of other stuff as well. And we'll have our team members there to help you be able to kind of build your very first progressive web app. So you've learned everything today. You can go and put that into practice, and we'll have our engineering team and developers there to help you. If you don't want to do that here, they're all online, and you can get access to them wherever and whenever you want, which is a great thing. So one other thing I do want to say is that we've got a nice range and a great range of cross-browser industry experts that come in. So we've got representatives from Microsoft, Mozilla, Samsung, obviously Chrome and Opera as well. The second day, we'll have a panel session. So if you have any questions that you want to put to the team, that's your chance to actually say, hey, this is, what's the whole story of progressive web apps, service workers, all these types of things. This is your chance to ask the product managers and lead developers of those teams questions that you have about progressive web apps. So please do submit questions, and Jeremy Keith will be running and moderating the panel session as well tomorrow, which is a great thing. And finally, or nearly finally, all of our content will be available on YouTube on our Chrome developers channel. It's going to be up hopefully today, so pretty much after this event is finished, all the content will be available, and we'll make sure the slides are available as well so that you can kind of go through them and pull them apart and do whatever you need with them. Like I said, we have a tightly packed agenda. We do have a number of breaks, 11 till 11:30, 1 till 2 is the main lunch. You'll be out in the main foyer. Again at 3 till 4, and then finally at 6:30 we have the closing session, or we finish up then, but we also have a dinner and a party in the venue as well, and you're all obviously welcome to come to that. So, with all that boring stuff out of the way, it's important stuff, but unfortunately it's not the most exciting part of the whole day, is I want to get everything started. So, I would like to introduce Alex Russell onto the stage. We also have Tao Tran, who will be doing our keynote session as well, who's our lead from the Global Product Partnership team. But first is Alex Russell to talk about everything future of the web.
Thanks, Paul, and welcome. This place is amazing. This venue is incredible. I'm so excited to be here this morning with you to talk about progressive web apps, but I'm an American, and so I would be excited about something, I guess. But I think it's legitimate to be excited about this, because we've got 2 incredible days of talks. We've got codelabs. We've got experts here, not just Chromies, my fellow engineers from Chrome, but also folks from other browser vendors and engineers who are making progressive web apps in the world. Some of the world's best experts who are engineers just like you making this stuff are going to be here to share their expertise and what they've learned over the past year. It's going to be great. So at Chrome Dev Summit last fall, we promised that there would be a Chrome Dev Summit in Europe and this summer, and we're breaking that promise because we thought better of it. We thought that instead of a Chrome Dev Summit, we should have something that was more inclusive. The web is bigger than Google, it's bigger than Chrome, it's bigger than any single platform or browser vendor. And so that's why we've done the Progressive Web App Summit instead. We renamed it, and we're incredibly glad that, as Paul mentioned, our partners from Mozilla, Opera, Samsung, Microsoft, basically everybody is here, and it's great. And as I mentioned, I'm an engineer on the Chrome team. I lead both the engineering side of the team that's building the progressive web app stuff, but also the standard side. And as someone who's been on the Chrome team for a long time, let me assure you that building and distributing native software is a real pain. I've been on the Chrome team since before there were 1% of people in the world using Chrome. We had to fight really hard to get Chrome into people's hands. You have to convince someone to go download it, and then once they've downloaded it, they have to click on the thing and run the installer. And once they've run the installer, they have to then choose to use your application. The same thing is true in native application platforms of any kind. You still have to convince users to go find your thing, download it, install it, and then choose to run it. It's a massive challenge for any company that's trying to make forward progress, although it used to be a lot harder. This is how, when I was a kid, my family acquired most of its software. We used a Ford Taurus station wagon like this to go to a place like this to buy disks like these that you had to physically put into the computer before you could do any of those other steps. So it used to be a much longer journey to get software. So when I went to college, it was a revolution that we were able to use CDs for almost everything, many fewer disks to swap. And when I got there, at one point, I got, for $5 from the bookstore, the college bookstore, I got a copy of Microsoft MapPoint. Now, if you hadn't used MapPoint, that's okay. Not many people had. But MapPoint was a bit of consumer GIS software. You could have a map on your computer that you could pan and zoom around. It only took 30 minutes to install, but it was an enormously transformative experience. You could just zoom around the entire world if you needed to. Yes, the data got out of date, but it transformed the way I planned trips, especially road trips. Kind of an American thing, but very, very timely for me in college. And at the time, web-based experiences just couldn't compete. If you clicked on the link to go to a bit to the left, you then sort of waited, and then, oh, there it was. Even though the network was pretty fast, you still sort of did this stuttering back and forth. It just couldn't compete. There was this big cliff between what you could do in native and what you could do on the web. Then Google Maps happened. We eventually got pan and zoom on the web. It worked on any computer, not just the ones I'd spent time installing the software on, and the data was never out of date. Maybe it wasn't entirely complete, but it kept continuously getting better, and I didn't have to go get another CD or download a big patch. It just was always fresh. So when the web is capable of delivering a particular experience, it can compete. Our distribution model is actually better. Links are the web's superpower. So, okay, quick, I can see everyone. So a quick, raise your hand if you use the web to get to maps on your desktop or laptop computer, yeah? Okay, now keep your hand up. That's almost everyone. Keep your hand up if you use the web to get to maps on your phone. Okay, so less, okay, yeah, okay, 10%. Sure, that's about what I thought. So we don't really use the web on mobile the way we used it on desktop. But remember that we started with native apps on desktop too. So what we needed to break the logjam between native and the web on desktop was some enabling technology. And Ajax was that enabling technology. It allowed us to move data in as you panned and zoomed around the experience. We did the exact same thing for email. I don't know about you, but I moved almost all of my mail consumption to a web browser on the desktop, but I'm using a native app on my phone. So why haven't we made the same transition on mobile? You know, I think just to reinforce how big the size of this cliff is, today, users are spending almost 90% of their time on mobile devices in native applications. Why is that? Well, one theory is that maybe the re-engagement features that native apps have had keep users in those experiences or draw them back into it. Things like being on the home screen or notifications that can be persistently in your notification tray. But it's a huge amount of time, and it's hugely concentrated. If you haven't won the lottery for native applications, you're probably not going to, because users are spending 80% of their time in the top 3 apps. That's 80% of that 87%. This is a huge winner-take-all dynamic, which we didn't necessarily see on the web. If only native apps can be engaging, and only a few can make it on native, why hasn't the web disrupted this? It often takes more money to distribute a native app to a user on native platforms than you'll get back from that user. Like, native app developers are suffering. Why hasn't the web disrupted this? So I think it's worth thinking back again, a decade or so, to think about how we used to get web experiences. I don't know about you, but this is how I got web pages. You would dial one of these up, you'd go to the bit of your house that had the computer in it, and you'd put the computer into online mode, and you'd eventually wind up yelling up or down the stairs to your friends and family, like, don't pick up the phone, you're going to interrupt my download. This was tough, but we knew we were in online mode, and the web grew up in an online mode. We could always assume that that next navigation, that next transition, no matter how slow it was the first time, was going to be the same speed the next time. But that's not how phones work. Phones, even when they look like they're online, they often aren't. Radios transition wildly underneath us. The network isn't reliable. We can't assume that it is. Ajax got us to good enough because we were always connected. But what about now when we're not always connected? When I'm on a mobile phone and I tap something from my home screen, I never see one of these. Apps always load. Maybe they tell me that they don't have the data that I wanted, or they can't get the new stuff, so they'll show me the old stuff. But they'll never give me this cute little offline dinosaur. They have this UX contract that they'll never fail to load if they're on my home screen. The web hasn't been able to do this. We've also made the keyboard and mouse to tap and swipe transition. But I think that one of the biggest issues here is that we haven't really earned our place in the home screen. Because web technology can't be reliable and can't be reliably fast, it's reasonable for users not to include us in their daily experience. So one way to think about this is there's an axis here of capability. Now, native apps have the ability to start up reliably. They can be fast all the time. They can do offline. They can handle push messages. They can synchronize in the background. They've got access to all the sensors. While the web is safer and more respectful of your privacy, but it doesn't have some of those capabilities. It isn't on your home screen. It isn't in your notification tray. But what if we had another axis? We'll add reach. The web succeeds wildly here, even in the situation where users are spending only 13 to 14% of their time on their phones on the web. They're visiting more than 100 sites a month. Meanwhile, ComScore says that the average user is downloading 0 apps a month in the US. This is the power of URLs. We can absolutely meet those one-off needs, and we do. We are always in the user's experience, even if they don't realize it. So what we want is a way to go from incredible reach to be more engaging, to have those capabilities. So what is that thing? I think we can meet those user expectations today on the web. And that's what progressive web apps represent. They're finally the ability for us to earn our place in the home screen and in the notification tray. First, by providing reliable experiences that are consistently fast. And we don't have to give up the reach to get it. That's the promise of the web, and that's why I'm excited about progressive web apps. So what do these experiences look like? So here's the WashingtonPost.com/PWA. You can go to it on your phone right now, wapo.com/PWA, and it loads in a tab like any other site. And if you go to it enough, if you engage with it, you'll eventually get this add to home screen prompt in Chrome for Android. So if you tap on that link, the browser will confirm to you that you've done it. And if you go back to your home screen, you'll see that there's now a home screen icon. When you tap on that icon, it's beautifully fast, And it'll launch with a splash screen. That splash screen is a full-screen immersive experience, and the whole app runs that way. And if you go into the task switcher, what you'll see is that it's first class there too. There's no URL bar getting in the way. It's exactly like a native app in that sense. So what was missing to be able to deliver this experience? Because we finally earned it. Well, first we need reliability and reliable performance. And next we need to be in the notification tray. And lastly, once we're trustworthy and have reliable performance, we need to be able to have enough metadata about the site to be able to generate that add to home screen prompt to put it on the home screen. OK, so there's talks today and tomorrow covering all of the required technologies to get to that point. TLS, which is imperative, and HTTPS, manifests, service workers, push notifications, smooth UIs, and much, much more. And I'm excited that we've been able to work with other browser vendors over the past 3 years to deliver these technologies to you. They're already shipping in Chrome, Opera, Firefox. It's amazing stuff, and they're going to be in Edge soon. So the web is bigger than any vendor or a single platform. It gives you that incredible reach, and we're bringing this stuff to every browser. But I just want to focus for a second on reliable performance. We all know that faster is better. And if we have to traverse the network, we can almost never be fast, specifically a mobile network, where getting the radio initialized can take 2 seconds. The data from SOASTA that you just saw really confirms that correlation between speed and bounce rate. But we see that a 3-second delay can bounce 40% of users. It's really tough out there if you're trying to deliver great experiences on the mobile web. So what if we weren't necessarily going to have our connection eaten by the offline dinosaur? What if a user goes to the site, it could be reliable after that? That's exactly what service workers are. They provide an in-browser programmable network proxy so that users can always get to something on your site the second, third, and fourth times they visit. If they are willing to re-engage with you, they can always get to your experience. And you can use your own cache to do it. You can always boot up without ever hitting the network. You can provide an experience from local data. This is exactly what native apps do, and this is transformative for the way we deliver reliably performant experiences. So what about that first visit? Well, the search team has been thinking about this because there's an epidemic of obesity on the web. And they came up with AMP. AMP is a format that uses custom elements, HTML custom elements, web components, to keep you from doing most of the things that really hurt the user experience. And it delivers incredibly fast initial loads. They're seeing median less than 1 second load times from the AMP documents on their CDN, which is generally 4 times faster than the same document hosted in a different format, and it's often 10 times less data. That's pretty great. So what if there was a way to go from that fast first load using AMP to that reliable performance, that immersive experience with progressive web apps? So here's an example of the Washington Post. Today, if you go to Google News and you see that AMP carousel, and you go to an article, you'll be reading it inside the CDN-hosted version, so it's not on the Washington Post servers. But while you're reading it, the AMP install service worker element will go and install the progressive web apps bootstrapped service worker from the Washington Post. So now if I click a link from this article out to someplace at the Washington Post, instead of the offline dinosaur, I'll get a reliable service handled by the service worker, and it'll load instantly. This is pretty great. So this is all some leading-edge stuff, and it's been hard to do until recently. Dev tools are evolving very fast, and this is the new application tab in Canary and Chrome Dev, which helps verify some of this stuff. But as good as this is, wouldn't it be great if there was a way to do this at the command line or in your CI? That's what Lighthouse is for. Lighthouse is an exciting new tool that gives you a Chrome extension, if you want it, that can help verify that you've met all the requirements to get to that add to home screen prompt. And it's also available in a command line form so you can run it as part of your continuous integration. So there's a ton of new capabilities that are coming to the web that unlock other sorts of applications once we've earned that right to be on the home screen. There's too many to talk about. I'm incredibly excited about WebAssembly and what WebGL2 are going to do this year for games, and what media capture and streams are going to do for social use cases. But there's 2 specific capabilities I want to talk to you about that you'll hear more about later today from Chris Wilson that I think are going to really, really make it so that the web is a first-class citizen. The first is the Web Payments API, and the Credentials API follows that. So Web Payments, what's that? So Web Payments is a way for you to not have to fill out forms with the worst keyboards in the world when you want to check out on the web. It lets you do one-tap checkout using cache data that the browser already has. So here, for instance, is a Shopify checkout flow. I can tap the checkout button, and then I'll get a pre-populated list without ever having to fill that stuff in. And if it looks good, I can tap it, and then I'll be getting a confirmation screen. It all worked. I didn't have to enter any new data. That's pretty great. In fact, if Android Pay or some other system-provided payment instrument is available and the site supports it, this can go as simple as a single tap or a confirmation. I think this, as a standards-based way to get this capability available pervasively, shipping this year is so exciting. Similarly, the Credentials API is going to also remove a bunch of typing and tapping and autofill corrections and all that stuff that isn't great to do on phones. Like native apps, we'll be able to do one-tap sign-in. If the site knows who the user is, it'll be able to request using existing system credentials that the user log in, and that can be a single tap. In fact, if the user's already been there, this can be automatically done. This is going to accelerate how we deliver first-class experiences on the web, in addition to all the progressive web app technology that browsers are already shipping. Now, you might ask, how is that stuff doing? And I'd say, well, but I think I'm incredibly biased. But don't take my word for it. To tell you more about how it's actually going, I'd like to invite my colleague Tao Tran from the partnerships team to take a look at how progressive web apps are performing in the real world. Thanks.
Thanks, Alex. So as Alex mentioned, I work in global product partnerships for the Chrome and web platform team. So that means I get a chance to talk with lots of different companies and sites and to tell them about all the new web capabilities today, building progressive web apps that are going to be reliable, fast, and engaging experiences. And I often spend a lot of time with partners thinking about helping them think through, how do you develop a mobile-first strategy for the web? So Alex really walked through a ton of kind of new capabilities that are available today, and you'll hear a lot more over the next couple of days. So the whole point of coming to these conferences is that we want you to get excited and motivated to really want to build new things, to start digging into these APIs, tinkering with all this new stuff. And so it's kind of like a kid kind of playing around with a new toy. And so this is my 3-year-old, the first time we introduced Play-Doh to him, and he thought the possibilities were endless in terms of all the things that he could make. So I had to choose between a kitten or my son, so I decided to go with my son. So you know, he's like being extremely creative. He even was trying to convince me that green Play-Doh pizza was going to be so good. And so this is the type of energy and creativity that we want you to bring back to your teams and to your company. But I also realize is that the reality is that when you get back to your companies, you're probably going to have to pitch and talk about how you want to start a web project. I know many of you have probably already started looking at these technologies, and you may be getting questions from different people inside your org, like, how much time is this going to take? How many resources it's going to take? What's the ROI? You know, all those like annoying business and resource type questions. And I hear it a lot from our partners. And so what I want to do is actually give you a framework for how you can think about building the case for investing in the web. And so oftentimes, I think the dreaded question that every developer gets is, okay, build me a business case for why you want to do this project. And as a developer, that's kind of code for, actually, don't try anything new. So you start feeling like this. So for those of you who have kids, I think this is very familiar. This is when he's in a tantrum mode, when I ask him to do something and he doesn't want to do it. But in all seriousness, we want to help you build a case for the web. And the goal is to walk away from the next couple of days where you can actually talk about new capabilities and make the case for why it's critical to invest in the web platform. So I thought about all the learnings I've gotten and all the feedback I've gotten from all the different partners across the world. And when people say, hey, I have to prioritize this, I need to figure out how this fits into my roadmap, it basically boils down to 2 critical questions. Why is this important? And how do we get started? And a lot of times, partners just want to have an understanding of, what are some numbers that you can share, and what are different approaches so that this feels accessible and feels like I can scope this for my team. And so to talk about what's important, or why is this going to be important, I'll just give kind of a brief overview of some key metrics that folks on the business side often like to think about: reach, acquisition, and conversion. So the first one is reach. And here we'll just take a look at the overall mobile web market and see if it's growing. Alex talked about how people are spending so much time in apps. And so what we want to take a look is just to see what the mobile web audience looks like. And so we'll take a look at some of the Chrome numbers that we announced last month. So Chrome announced that we now have 1 billion monthly active users on mobile alone. This is incredible for a couple of reasons. One, for those of you who may not know, Chrome on mobile came out about 4 years ago. And this time last year, this number was only 400 million monthly actives. And so what you're seeing is that there's tremendous rapid growth on the mobile web. And then we look at reach, drilling down to more site-level data. Comscore data taking a look at the top 1,000 apps and websites and comparing monthly traffic for apps, native apps versus the web. And not surprising, it's 2.5 times that, the reach of the mobile web is 2.5 times that of apps. You can probably see it in your own numbers. So it's worth kind of digging in to understand what your overall mobile traffic is, and then break it down between your web and app. And anecdotally, I've heard partners say somewhere between 50 to as high as 90% of their mobile traffic actually is on the mobile web. So now let's just spend another minute on acquisition. So you have this incredible reach, and you still need to bring users to your site. And this often sits with the marketing team or your growth teams. But when you're trying to make a case for investing in the web, you should understand all the different forces at play here. And so with acquisition, oftentimes you're probably paying to get users to your site. So it was really cool when we saw that Celio, which is a platform for buying and selling goods, it's a startup, actually published a stat about user acquisition costs. They started building a progressive web app and then saw that the engagement numbers between progressive web apps and their native app was comparable. And so then the CEO, started digging into, well, if it's comparable from an experience standpoint, how much is it costing me to get a user into my native app versus the mobile website? It turns out it was 10 times cheaper to get a user onto their mobile web experience. So for those of you who are familiar with acquisition costs, this is probably no surprise, but it was really great to see someone dig into the numbers and then share it publicly. And so the next piece after after acquisition is, are my users converting? So it's awesome, I've reached, they're coming in, but am I actually getting them to frequent my site more? Or conversion could also be defined as completing a transaction when the money really comes in. So AliExpress launched a progressive web app last month during I/O, and it was incredible to see within days of them rolling out their progressive web app experience, they saw huge increases in engagement numbers. 2 times more page views, 74% increase in overall time spent across all browsers. And what was telling was, we often get the question about Safari on iOS. And is this going to be a good experience across the board, especially if they don't yet support progressive web app features? So we actually asked AliExpress to dig into their conversion numbers, which they saw increase across the board, but to segment it for iOS specifically, or Safari specifically. And they also saw an 82% more conversions on iOS. And it just shows that AliExpress already had a good mobile experience, but they continue to invest in it to make it more engaging and fast and immersive. And their iOS users also benefit. So it's just good all around to actually invest in your mobile web experience and to make sure that you actually deliver experience to users on all platforms. And so this really cemented. I love this quote that from the head of mobile at AliExpress, where she really just talks about investing in the web experience across all browsers. And not only did they see huge benefits on browsers that support progressive web app features, they saw a bump across the board. And it's just a sign of a really great investment. And they'll know it'll pay off once other browsers continue to evolve and ship these APIs. And so this is a model that I thought was really great. I can't take credit for it. My colleague put this together. So when you think about all your potential reach, bringing people in, hopefully at lower acquisition costs, or likely at lower acquisition costs for the web, and then you're improving conversion, start to take a look at these numbers, and they add up to pretty good math, profitable math, I assume. And so this is just a way for you to think about why it's so important and why it's great to invest on the web. And so then the next question, and this is one of the tougher questions to try to handle, is how do we get started? So a lot of people say to us, these technologies seem really intimidating, especially as I'm talking to my management team. So do I have to convince my team to do a complete overhaul? And the short answer is no. Alex painted a picture of what's possible, giving you a vision of where we want the entire mobile web to go with these amazing experiences. But we also recognize that it's complicated to bring in these new technologies, especially at larger companies where you have sites with legacy code and architecture. And so we want you to think about this as an ongoing journey to invest and build on the web. And so the first step is HTTPS, which Alex already alluded to. And my colleague Emily Schechter will talk about kind of myth busting through HTTPS later today. But it's critical because all these new features will only be available over HTTPS. So if it's not already on your roadmap, it should be. So now I want to walk you through partner examples and how they've actually approached building and experimenting with all these new web technologies. So the first one is starting from the ground up. So this is when you're able to just rethink or reimagine what your mobile web experience should be. I know very few sites actually get the opportunity to do this, but when you do, you really are able to unlock so many of the capabilities of Service Worker and all these amazing features. And so I want to talk about Konga. Konga is actually one of the largest e-commerce players in Nigeria, and they decided to do a rethink of their mobile web experience and just basically build a progressive web app that was going to be very comparable to their native experience. And actually, the director of engineering, Andrew, is going to lead a session talking about how Konga is approaching their progressive web apps building tomorrow. But what was really great to hear yesterday was that this was a cross-platform effort. Even though they were building a progressive web app, their iOS and Android teams really collaborated to make sure it really truly was an app-like experience on the web. And so the Konga experience, not surprisingly, is focused on being fast and performant and reliable. And the most critical thing for their users is making sure it doesn't use a lot of data. And so in early testing, they saw that for initial load, it actually used, comparing to their native app experience, it used 92% less data for their progressive web app. And then that critical moment of converting the user to actually completing a transaction, they saw that it actually used 82% less data as compared to their native app. So again, seeing terrific stats when you're able to kind of invest end-to-end and then start from the ground up. But we also know, as I mentioned, it's really hard to catch a company at a moment when they're actually going to rebuild something or going to change architectures or frameworks. And so I want to offer, why don't you build a simple version and a couple of examples of how that's being done. So Air Berlin did this demo at I/O, which I thought was terrific. They knew they couldn't change the entire site experience, and so they thought about, well, is there a segment of my site that I can change or convert into a progressive web app? And here they looked at the post-booking experience. So imagine, so the pain point I think that we all recognize is that when you're at the airport, you're frenzied, you want to just easily be able to access your boarding pass, your itinerary information, maybe your destination information, but the connectivity is pretty unreliable. And so they wanted to have this customer journey details available offline. And so they leveraged Service Worker caching to enable this. And what they saw was that the initial loading time was less than a second, because they've done a ton of optimizations, but even faster with Service Worker for subsequent loads. And so even if you're offline or you land and you're in another country where you don't have Wi-Fi access, all your destination and itinerary details are available on your device. So Alex talked a lot about the Washington Post earlier, and we've gotten a lot of questions about how did they, why did they build this? When are they going to transition into a bigger or a more productionized site? And so the Post, what they wanted to do was they wanted to do a public live demo to show what's possible. So they took their top stories, news feeds, and said, let's go ahead and just build this really fast, immersive experience. And they wanted to be able to show it off publicly, but also internally, as you know, folks who are in publishing, newsrooms, different people in advertising, their executives. And what they saw was that everyone is obsessed with speed at the Post. And in their progressive web app, they saw article page loads times inside the progressive web app hit 80 milliseconds. So now that's the bar, and that's the user experience they want to deliver. And I'm happy to say they're actively exploring a roadmap of how they're going to evolve this so that it's going to be available to a broader set of their mobile web audience. But even sometimes building a simple version or getting a site or a section of your site to a progressive web app could also be hard. And so we've seen people just focus on a feature. Pick an API or a feature that you believe will have high impact for both users and your business. So the weather company, folks familiar with weather.com, they've been looking at progressive web apps for a while and all these technologies, and what they wanted, but they were asked to prioritize what's the one feature that's really going to be a great ROI. And so they decided to go after web push notifications. And what's really great is that they went big on this one feature. They launched about a month and a half ago, and they actually launched in 30 languages globally with web push notifications. And what you see here is actually how you can decide which type of notifications you want: local, national, or government-issued alerts. By the way, these are all notifications that are available in their app, so they basically made it parity with the web, or make the web on par with what app notifications were. And then Booking.com, as you know, a major travel player, where they had been looking at all these technologies, and ideally, I guess we could try to build a full progressive web app, but that doesn't work for their business. They're extremely data-driven, they test everything, and so they needed to work in small steps so that they're able to tackle different issues, learn things quickly, test and optimize. And so Jesse Yang, who is quoted up here, is going to actually lead a session tomorrow talking about Booking's approach on their journey to building a progressive web app. And so I really want to emphasize that everyone will take their own path, whether it's building from the ground up, doing a simplified version, or using a single feature. There's no one-size-fits-all, and I want to make sure that you do the path that's right for you, and so that it feels accessible. So these are just a sample of partners globally who have started shipping or actively looking at these progressive web app technologies. And again, no one partner has done the same approach. They've, again, modified it and really thought about what's important for their users and their business as they're thinking about investing in the web. And to help you with this journey of building progressive web apps, we're pleased to announce that Udacity now has a nano degree program, and it's an extension of the Senior Web Developer Nano degree, where it's a short series of classes and projects, and then when you complete the course, you'll be able to architect and build app-like experiences on the web. So in closing, I guess I did have to include a cat in here, but in the corner. So it's amazing to see so many people here. I was just commenting to the Chrome team backstage that this time last year, we were just talking about Service Worker and the Web Push API, and progressive web app as a term was still being socialized. And so it's incredible that I'm standing here today, about a year later, where we have a dev summit dedicated to progressive web apps. So we've got an exciting lineup, as Alex walked through, so hopefully you'll stay for all the different sessions. And at the end of it, we want you to leave the Progressive Web App Dev Summit really inspired and confident about building the case for the web. And more importantly, we want you to go build something great. Thank you. And next, I want to introduce to you Jake Archibald, and if you haven't been awake yet, you should wake up, because there's actually code in his presentation.
That music's great, isn't it? I love it. It's like one of those kind of corporate business intros where we're going to... Actually, so play it again. Go on. Can we play it again? Can we press the button that makes the music happen? I assume it's just a big button that is like corporate music. At Google, we are going to change the world. OK. Right. Do I have everything plugged in? Now I've got 2 clickers here. OK. So a lot of times when people do these kind of polls of an audience, like they ask people to raise their hand, it's kind of totally meaningless. It's just to kind of make sure you're all awake. But I'm going to ask you a question, and it's actually going to decide the talk I give. So here goes. Who here has sort of seen a talk about service workers before, or kind of know roughly what they are? OK, right. So I'm not going to do the intro talk then. So if you don't enjoy the talk that I'm about to give, it's actually your fault. You picked it, so you should have picked the other one. So firstly, I'm going to do a little bit of a recap. I built a little web app called Emoji, which you can find at this URL. It started just as a website, but I turned it into a progressive web app. And if you're looking to do the same thing, the first thing you need to do is to integrate the site with the operating system and the UI. And one of the ways of doing that is in the head of the page, you can use a theme color, and Chrome will use that to kind of change the color of the location bar there. So it's a small, quick win for integration. But the main part is this web app manifest. So inside the manifest, it looks like this. It's got details on the name of the app, the icon, all that sort of stuff. And once you have this, users will be able to add the site to their home screen, and they get the icon and the name that you specified. But not only that, when the user taps that icon, they get a splash screen. This is reasonably new in Chrome, and this is while the browser is booting up and while your page is getting to first render. And so the icon, the text there, and the background color, and the sort of the purple strip across the very top there, that's all taken from your manifest, so you can configure all of that. And once that goes away, you get your site, but without the URL bar. Or that's an option you can have. So here, it feels like a native app. However, this whole illusion of native comes crashing down when you're offline. So this is pretty bad, right? Like, the user has launched our app. They've come back to our app. They've added it to the home screen. That's how much they like it. But we have failed them to such an extent that the browser has had to step in and defend us. And they do this by blaming the user, saying, you are offline, this is your fault. If we're going to compete with native, this is like an operating system level error message, like a full crash. So this is not good enough. But things get worse. So offline isn't the worst thing that we face. This is, I call it Li-Fi. This is when your phone says it has connectivity, but it doesn't really. And I think we've all experienced this. The Li-Fi experience is just that. So that the splash screen goes away when the site gets to its first render, but with Li-Fi, that never happens. This is worse than offline. With offline, you get a quick answer. The answer is no, but it is a quick answer. Here, the user is just left waiting. You're forcing the user to stare at this or give up. And with every passing second, they hate the user experience a little bit more. And this is why we should avoid treating online and offline as these kind of binary states. Because if we cater for online and we cater for offline as separate things, this situation goes completely unsolved. And that's why the gold standard here is offline first. Offline first solves these problems. With offline first, we assume offline and do as much as we can with local content, then try and get content from the network. And the more we get to render without a connection, the better. So you should think of the network as a piece of progressive enhancement, an enhancement that might not be there. And here's how we do it. So to begin with, register for a service worker. And this isn't some kind of magic manifest format. It's just JavaScript. Because we thought, why do we invent a whole new thing when we've got like a room full of JavaScript developers, we've got a world full of JavaScript developers, and loads of existing tooling? Of course, we should wrap this register call here in a simple feature detect because, there are older browsers out there that don't support service worker. And this feature detect prevents them from hurting themselves and others around them. Anyway, in that script, I'm just going to register for this event, this fetch event, so I'm going to have a debugger statement there. And when I do that, now if I refresh the page, I hit a breakpoint. And you get this event object, and it has a request property. And this is the request for the page. And you get things like the URL, the headers, the type of request. But you also get one of these events for every request that the page makes, the CSS, the JavaScript, the fonts, the images. I get the event for these avatars, even though they're on another origin, so it's not just your own origin. So by default, requests will go from the page to the network, and there's not a lot you can do about it. But once you introduce a service worker, it controls pages, and requests will go through it. But like other events on the web, you can prevent the default and do your own thing, and that's where things get really interesting. So let's use that to go offline first. So the first thing we need is an application shell, which is just the site, but without the messages in this case. We want to serve this and the CSS it requires and the JavaScript it requires before we even try a network request, before we even think about going to the network. Because even if we have a great network connection, serving this locally is going to be faster. And that's the offline first approach. So we need to cache this ahead of time. And the service worker has an event for doing this. It's the install event. This is fired when the browser sees this version of the service worker for the first time. And it's your opportunity to go and fetch everything you need to work and store it in a cache. So here I'm opening a cache called static v1, and in there I'm adding the HTML for the shell, the CSS, and the JavaScript that it needs. But these won't be used by default. Service Worker doesn't do anything for you. It waits to be told what to do. So over in the fetch event, I'm going to start by parsing the URL so we can look at the component parts of it. And then if the request is to the same origin, and it's just slash, as in it's the home page, we're going to respond with the app shell from the cache. So calling respond with here is my indication saying, look, I'm going to handle this request. I'm going to take over here. And we pass in either a response object or a promise that resolves to a response. Caches.match, that returns a promise which resolves with a response from the cache. So this composes together really well. Otherwise, we're going to try and respond with cached content that matches the current request. So that's how we're going to pick up the CSS and the JavaScript when the shell page requests those. If there's no match, it's going to resolve with undefined. So as a fallback, if response is falsy, we'll make a network request. So this is the offline first approach. We're treating the cache as our priority, as our primary source, and then falling back to the network, whatever connection the user has. So using this pattern, the page goes to the service worker, and the service worker just pulls the shell from the cache and the CSS and the JavaScript it needs. So that gives us our shell render without going to the network. And now we're running JavaScript on the page, so we can display even more content. So with Emoji, in this case, I actually went to IndexedDB and pulled out the past messages, the last messages the user saw, and rendered those on the page as well. So the user's looking at messages without having to go to the network. And then we can go to the network for newer messages, if we can, and we can show updated content and additional content. So if this network request fails, it doesn't matter, because we're displaying content. That's a good offline experience. If the network is slow, then that's maybe OK, because the user might just be looking at past messages, and we've given them that. So to see the benefits of this, let's pit the original online-only site against this new, shiny, offline-first version. We must go to the comparinator. There was going to be sound there. Nah, never mind. So first up, the online experience. Go. So we get instant full content, whereas the original lags behind having to fetch stuff from the network. What about the offline experience? Well, instead of complete failure, we have instant full content. What about Li-Fi? Instant full content rather than the white screen of death. In fact, with our progressive web app, the experience is the same no matter what connection you have. And that's the offline first goal. The network only matters when it comes to fetching new content. And this is how we compete with native. And compete with native we can. I decided to pit the Emoji progressive web app against a native app, Google Photos in this case, because it's a well-built, well-refined native app. And I just wanted to launch them at the same time and see what happened. So press them at the same time. And it's really close. This is native versus web. And in fact, Emoji is about 0.2 seconds slower to show content. That's 200 milliseconds, not a lot. And that's compared to a well-built native app. But that's starting from cold. The browser isn't in memory. If the user has used the browser sometime recently, and let's face it, the browser is a pretty popular app, so it's likely to be in memory, this happens. This is a progressive web app beating a native app to content render by almost half a second. Now, a few people said to me, it's like, well, what about Android instant apps? What about those? Well, my answer to that is progressive web apps are shippable today. And they're not Android only. You can build one app across thousands of devices, operating systems, and browsers, and it can beat a native app to content render. So Service Worker is in the stable versions of Chrome, Firefox, Opera, Samsung browser as well. And it's coming to Microsoft Edge. It's a high-priority implementation for them. It's under consideration by Apple. But progressive enhancement means you can use it today. You just don't get the offline features in Safari. But if you use Service Worker, and suddenly your stuff has more features or becomes faster in Chrome and Firefox than it does in Safari, then that will give Apple more reason to implement Service Worker. As web developers, you are in control of the future of the web here. But not enough about the things that are supported today. I want to talk about the future. This is what I wanted to get onto. Because I built another app. This is fun. Let's try that again. We could have a disco. This is great, isn't it? So if someone from AV can sort that out, I'll start talking around the thing I built. That would be fantastic. So Wiki Offline, it's a kind of psychedelic experience based around drugs. So the idea was to build something like Wikipedia, but a Wikipedia that ran offline first. So something that it was very very less of an app, because the Emoji is very much built like a native app. It looks like a native app. But is this stuff applicable to sites? Like, is it something that you'll be able to use for your blog? And we thought Wikipedia is a really good demo of that. So the idea was, like, when you're online, you're going to get a server render, because that's how Wikipedia works. But with a service worker, that we can start doing different things. OK, so it's great, because I've got the previous slide from the last talk staring at me, so I've just got a dog saying, "Go build." It's like, no, I can't. I've got to give a talk at some point, hopefully. So part of the challenge that we had with Wikipedia is that it's a different model. We've got this server render going on. I've got my notes up. That's great. That's a good start. Will I get slides? So the first thing I did when I built the Wikipedia demo is to create an app shell as well. That's good. We've got it on this screen. Can we get it there? Come on. Give me slides, please. Yes! You're my hero. This is great. Why me? Why is it always me? I'm going to get a new laptop. Right, so hopefully when I press this button, the slide's going to go forward. That's right, so I built an app shell for the article pages that would load this generic shell without the network, and then the page's JavaScript will handle the fetching of the appropriate thing from the network. So without Service Worker, it was kind of just a standard website, but with Service Worker, I'd re-architected it to be more like a single-page app. So I was dead excited about what I built, so I ran straight to the comparinator to see how everything changed. So I'm going to set the normal website here against my shiny Service Worker version. And I'm going to load it over a throttled internet connection, or as most of the world call it, their internet connection. 3, 2, 1, go. And I watched this, and I thought, shit. It got slower, like way slower. Here it is again. First render is actually quite fast, but the content, which some people would say is the important bit, is over 2 seconds slower on 3G. Now, I had a mild panic, not as much as the panic I just had 2 minutes ago, but a mild panic that we'd really messed up this Service Worker thing. But it wasn't Service Worker that was the problem. See, I was using this app shell and letting JavaScript do the rest, which is fine if your design already sort of dictates that you do something like this, but it wasn't the case here. I'd re-architected a site into a single-page app. And single-page apps are incredibly slow, and this is why you'll see me moan about frameworks all the time on Twitter. Here's what a website does to get to first render. HTML starts downloading, CSS downloads, and now we start rendering content, and we render more as more HTML downloads. We might download JavaScript as well, but it should be async, so it's not going to block render. Contrast this to single-page apps, web apps, where HTML downloads, usually instantly, because it's normally really small, CSS downloads, and then we get our first render, assuming the JavaScript isn't render blocking, which it often is, but let's be kind. Anyway, this is just a basic UI render, no content. And then JavaScript downloads, it parses and executes, and then it goes off to fetch the content. And once it has all of the content, it adds it to the page, and we get to render. And this is how slow happens, you know? And in my case, I wasn't losing too much time on the CSS, the HTML, and the JavaScript download, because they were all cached in the Service Worker. But the problem here is at the bottom. The JavaScript has to download all the content before showing any of it. The more I think about load time performance, the more I realize it's not about the size of your CSS, the size of your JavaScript. It all comes down to being progressive. And this is related to progressive enhancement, but not quite the same. I mean, show them what you've got. Like, all the time you're loading, the user is watching and waiting. Don't make them wait until you have everything before showing them anything. Prioritize the first render, the first interaction. Show the user what you've got as you get it. And that's where I was failing. I was hoarding all the content and only showing it once I had all of it. In retrospect, it seems kind of stupid to cram a site into this single page app model. But for me, this was my app cache hangover. You see, app cache nearly lets you use the page shell pattern, but not quite. But it lets you so close, like you can almost smell it, but it just sort of bats you away at the very last moment. So once app cache was out of the way, I was like, really? App cache is gone? Does that mean I can have all of the page shells I want and nothing is going to stop me? But I didn't stop to think that the best answer wasn't the one that App Cache nearly let me have. It was the thing that it didn't let me anywhere near. What I wanted was streaming. And with streaming, you get to finish this is a simulation here, and you can see the sort of final render is somewhat quicker than the non-streaming version. But the important bit is that a render happens ages beforehand than in the non-streaming model. So this is the full HTML spec loading here over a throttled internet connection. It's a 3 megabyte document. It's still downloading, but it gets on screen after only 20K is fetched, which is great. That's streaming. But for a long time, we had no access to streams in JavaScript, but that is all starting to change. So we designed the Fetch API alongside Service Worker, mostly because we needed a lower level representation of requests and responses. But it was also a good opportunity to look at XHR and make something that's a bit easier to use, because XHR is almost 18 years old. I don't want to be using XHR when it's legal to drink. It's bad enough when it's sober. So this is Fetch. It returns a promise for a response. There it is. But that only resolves when we've received headers. We haven't received the body yet. You have to choose how you want to read it, and that gives you a promise as well, and then you get your data, JSON in this case. This compresses really nicely using arrow functions, and even better using async functions. So that the keyword await there, it pauses execution of the function until the promise resolves. And it's paused in an async way, so it's not blocking the thread, it's not blocking interaction. I think, so Edge has this in their preview builds. I think we've got stuff in Canary as well. But Babel lets you use it in other browsers as well. And it produces much easier to read code. I think it's great. So if you haven't encountered it before, you can pretend that async code is sync. It makes it a lot easier to read. Anyway, you don't have to read the responses, JSON. We added a load of different methods for common types that you'd want to read. And we added these for 2 reasons. They're nice convenience methods, but we wanted to ship Fetch before streams were ready, so we needed a way to read the body. But we did reserve response.body for streams when they landed. And they landed in Chrome and Opera around a year ago, and they've been actively developed by Firefox, Edge, and even Safari as well. They're working on them. Here's how you use them. So you fetch something, say the HTML spec, and we're going to fetch it as a stream, and we call getReader. So I'm saying, I want to open the stream. I want to get a lock on the stream. And then we can read some of the data. Read returns a promise. Result is an object. Result.done is true when there's nothing left in the stream. So if result.done isn't true, result.value is a chunk of the data. And that's a uint8 array of bytes that you've received. It's not the whole response, it's just the first part of it. And when we want the next part, we can call read again. So if we wanted to get the length of a whole response, we could do this. We're going to have a variable there to keep a running total, and then we're going to create a loop. I'm just going to keep calling read until result.done is false. And in there, get the value, add the length to the total, and then log it out. And that's it done. We should be able to see that working. I don't know. It feels really risky doing live demos after what happened before, but let's give it a go. Let's see. Here we go. So this is, let's see if I can make this a bit bigger. Oh, wrong window. Maybe I can't make it bigger. Where's my mouse pointer? There we go. So if we refresh the page here, we can see the sort of log at the bottom there, and it's reading the HTML stuff. And we can see that we're inspecting parts of the response here, but we're not having to keep it all in memory. And you can see the chunks are of different sizes, so that's something you have to deal with. They're kind of around about 32K, but not always. So here we're reading the full size. It's 8 megabytes, I think, the uncompressed size right down at the bottom there. But we don't have to have the whole thing in memory. We're just sort of reading bits, and then they can be garbage collected straight away. So a more practical use of something like this would be to search a stream for a given string. So say we wanted to search the HTML spec for the word horse. Here's how we do it. So this is fairly a simple way of doing it. We're kind of fetching it, reading it as all as text, and then searching. But this means we have to load that full 8 megabyte document into memory and then search across it. We can do better with streams. Instead of fetching all the text, I'm going to loop over the stream as before. But the problem here is that result.value is an array of bytes, whereas we need a string to do the matching. In future, this will be really easy. You'll just be able to pipe the stream through like a text decoder, and that will kind of read in the bytes, convert it to text, and pass it out the other end. But transform streams haven't been fully spec'd yet. They're coming soon, but at the moment, you can do things a little bit manually with text decoder. So here we fetch, get a reader, but also create a text decoder. And then we're going to loop through the stream as we did before, but on result.value, I'm going to call decoder.decode, and that'll take the byte and give us a string back. And it decodes it assuming UTF-8. There are other options as well. The stream true there, that's actually really important. That changes how things work. So let's see if I can show you that. So here's a simple demo. So this is the code you saw before. I've got 3 chunks of text there, and for each one, I'm going to decode each part. And if I run that, everything is broken. But if I add that stream option in, and run things again, right, we get the poo emoji, the toilet emoji, and an exclamation mark. So the reason this happens is that emoji are 4 bytes long in UTF-8. So with stream true, it tells it that it might be receiving more bytes later as part of the same message. So with stream true, it receives the first 3 bytes, and it goes, this is part of a character, this is not the whole thing. So it just returns an empty string, and it holds those 3 bytes. The next time we call it, it adds the next 3 bytes on. So it adds the 169, the first byte, and it goes, right, I've got enough now to show the poo emoji. So I'm going to pass that back, and I'm going to hold on to the last 2 bytes. And then we add the next chunk on, the next 3 bytes, and it goes, right, I've now got enough for the toilet emoji, send that back, and also 33 at the end there is the character code for an exclamation mark, so you can send that back as well. So now we can check these chunks as they come along. Now we've got them as text to see if it contains the word horse. And not only that, we can also cancel a download when we find it. And this is really efficient. So if it's an 8 megabyte document, but if we find a match in the first 20K, that's great. We can stop the download and save all that bandwidth. But there is actually a bug with this implementation. It works fine if our chunks are like my lovely and then horse running through the field. Oh, there's the match in the second chunk. Great. But what if the chunks are my lovely huh? No match. Horse running through the field, no match. And we miss it because the match was across 2 chunk boundaries. So when you're doing things like searching or filtering streams, you need to defend against this. And the way we do it is by keeping a buffer that is the size of the thing we're looking for minus 1. So in our case, horse, 5 characters, we need a buffer of 4. So that means that we could see my lovely H, fine, and then we keep those last 4 characters and add them onto the next chunk, and then we see horse. So the code for that, my slides have gone off again. Isn't that great? Whatever you did, it's back. Excellent. So the code for that, same as before, but we create a buffer. My heart rate is going so fast. So we're creating a buffer. We're going to loop through the stream, and we're going to decode it, add it onto the buffer, and if it includes horse, great, and then we cancel. Otherwise, we reduce the buffer down to those last 4 characters. So now we're searching a large document, we're keeping the memory usage down, and we can stop the download early. So I'll show you an example of that as well. So we're actually going to run this on the HTML spec. It's a slightly longer piece of code, because I'm going to keep a larger buffer so I can show the search term. So with horse, which I didn't expect to be in the HTML spec, but if we run it through, there's a match, and it's because Tommy Forson is one of the contributors, and he's got horse in his name. Let's run a different example. Someone give me an example of something that probably won't be in the spec, but might. Poo. Do you know what? That means you are so much more polite than the meetup in London that I gave this same talk to very recently, because when I asked for a suggestion, there was actually a lot of silence, and then someone at the back of the audience just sort of stood up and pointed at me and went, shit. And I was like, okay, I'm going to pretend that's not a heckle, and I'm going to do that. Sort of nervously, okay, this will be fine. Obviously, not expecting anything to happen, but as it searched, I was like, whoa, there's a match! Holy, it's because it's a canvas shit region, a canvas hit region. Okay, fair enough. Where are my slides? So. I was talking to some developers in India and where connectivity is quite poor, and they were sending this blob of JSON down for some search results, and they wanted to detect 2G versus 3G. And the idea was like, if they're on 2G, we're going to send fewer results because it'll get on screen faster. You'll get a faster render. But detecting connectivity is really unreliable, especially in India, where you can have 3G or a 4G package, but it'll be the speed of 2G. So it's much better to do something else, like serve something like this, where it's not JSON, but every line is a JSON object. And this is something you can stream then. You can parse each line separately as JSON. and deal with the data as it arrives. And that means you can deal with the first result before dealing with the rest. And there's a huge performance benefit to this. So here I've got an example of that. I'm going to throttle the network down to 2G. There we go. So a regular fetch of this JSON will take, well, it depends on the connectivity, but it'll take around about, OK, so it's all about 5 seconds. And with regular JSON, it has to download the whole thing before it gives you any of it. So the first bit of JSON arrives after 5 seconds, and so does the second. But with a streaming solution, getting the last bit of data is going to take roughly the same amount of time. Yeah, so sort of 5 seconds. But we get that first bit after 364 milliseconds. So there's a huge benefit here for slower connections. We can start showing results before we've received the entire file. So you might be wondering how I can use this to speed up my Wikipedia demo. Well, I can't, because although you can use fetch to read a response in little chunks, JavaScript has no access to the streaming HTML parser. It might look like here I'm sort of happily adding HTML into an element, but plus equals is the same as getting then setting. So you're asking the browser to serialize the DOM, and then you're asking it to parse some more DOM, like you've added some more to the end. This is a performance disaster. Don't do this, because the elements at the start of your string get created like hundreds of times. I'm hoping we can get like a streaming HTML parser, a document fragment or something in future, but it's not there yet. But in Chrome Beta and Chrome Canary, we can create our own readable streams now. And this is something that's also being developed in other browsers too. It looks like this. You just pass in an object with these methods. And so say we wanted to create a stream of random numbers. So we going to store an interval. I'll show you why in a moment. I'm going to create a stream, and then I'm going to pass in a start method. And this is called straight away. So in here, I'm going to set up an interval that pushes a random number to the stream every second. And the controller has other methods as well, such as like close to signal the end of the stream, but we're not using that here. I'm also going to add a cancel method. This is when the user cancels the stream after they're done reading it. You get this cancel method, so I can use this to abort the interval. So this is just like fetch streams now. I'll show you an example of that running. I think it's this one. So yeah, here we go. So this is just the code you saw before, but I'm going to read the value 3 times, and then cancel, and then try and read it again. But what we'll see, if the page loads, which will be great, we can see this logged down at the bottom here, and it's getting those numbers. It gets 3 of them, but then it's had enough of it. So this is a push-based stream, because we're pushing data into it. So if no one's reading from the stream, those numbers are going to build up and up in memory, and eventually you'll get memory problems. The opposite of this is a pull stream. The pull method is called when a reader is waiting on a value and we don't have anything left in the buffer. So when pull is called, I'm going to return a promise that waits for a second and then pushes the random number on. And this is much better because you're not generating random numbers if nothing's waiting for them. Your streams can be of anything. With fetch, we saw there are a uint8 array of bytes. Here, it's numbers. It could also be objects. It's just one interface for all of those things. The designers of web streams, they talked a lot to the Node folks because they've had like 3 or 4 versions of streams, and they've made mistakes along the way. So it was a really good source of like, well, what did you do wrong, so we can avoid making the same mistakes. So you might be wondering how I can use this to speed up my Wikipedia demo. Well, I can't. Because not just using streams on their own anyway, because things get much more interesting when they're combined with a service worker. So this already streams. Fine, it just does it automatically. The browser connects the dots. Same with this. The browser will stream it from disk, from the cache. But in Chrome Beta and Chrome Canary, you can create responses from streams. You can create your own streams and stream those into the browser. So in my fetch event, I'm going to create an encoder. So this is the opposite of before. It takes a string and turns it into bytes, because response streams must be bytes. We saw that before. Then I'm going to create a stream with a pull method, which waits a second and then pushes a paragraph onto the page. So you can see there I've got encoder.encode to turn it into bytes. And then I create a response, give it the stream, and then say that this is HTML, give it the HTML header. So if we run that, it should be here. We can see random numbers appearing on a 1-second interval. So, but as far as the browser is concerned, it is just receiving text very slowly. And you can see that the spinner at the top there, it's, as far as the browser's aware, it is just loading a page very slowly. So you might be wondering how I can use this to speed up my Wikipedia demo. Well, I can. I actually can this time. Before we were piping content straight into the browser's streaming HTML parser, and that is the key to it all here. This is what App Cache wouldn't let us anywhere near. So instead of turning like a perfectly capable server-rendered site into a JavaScript-driven single-page web app, I can use Service Worker more like my server. So here's what I did for Wiki Offline. I fetched the article header, the body, and the footer. So the header and the footer are coming from the cache. The body is coming from the network, but it will fall back to something in the cache if it fails. And then I combined those streams together into one single stream. And combine is a function I wrote. It's about 10 lines. It's kind of a manual process right now. So that creates a single stream that reads the first stream into it, then the second, then the third, and so on, until it's run out, and then it ends. And then we create a new response using that stream. So one response made of multiple different parts and places. Just like you do on the server, you get some stuff from a database, some stuff from a template, et cetera, et cetera. Treating your Service Worker to a server maps really well to content sites like blogs and Wikipedia, which are server-driven. You see the result of this, for one final time, we go back to the comparinator. Fight. Oh, there's sound this time. Great. You'd normally be bored of that sound by now, but that was the first time. So here's how it compares. So on the left, the app shell render, and on the right, the streaming Service Worker, both over 3G. So launch them at the same time. So the difference is absolutely massive. But the app shell was a performance regression anyway, so let's compare it to the original server render. So we get the benefit of that quick cached first render, which happens without the network, but that allows us to get network stuff on screen quicker because there's less to fetch, because we've already sent the header and stuff down. I'll play it again. So the first render is almost like a second faster, but content render is half a second faster, even though it's just coming from the network, the same network in each example. So needless to say, I'm quite excited about streams, but that doesn't mean the app shell model is bad. You saw it being used with Emoji earlier, and the result was a progressive web app which launched faster than the native app. But a streaming solution will be faster and easier for you if you use server rendering, say. Like switching to an app shell model here could be a lot of work and could land you with a performance regression. If you're already a single-page web app, you have that performance regression already, so knock yourselves out. Carry on doing that. Consider streams if your initial content may come from the network. The benefit of streams is being able to build content from multiple sources. If your initial content comes from the cache or a database entirely, then you don't have so much to gain from streams. And that was the case with Emoji. I was getting all the first render content from caches and databases, so streaming wasn't a whole lot of use there. Consider streams if a partial content render is valuable to you. And that, I think, is in most cases, but especially written content. So if you're looking to build something like an offline-first news site, like The Guardian, or a shop like Amazon, or your blog, streams could be the faster and easier way to do it. And they're landing in Chrome in the next few weeks, and they're being actively developed in Firefox and Edge. If you want to know more, I've written an article about streams, gushing praise on my blog. In this post, I do some sillier stuff as well, like kind of transcode an MPEG to a GIF on the fly, or transform content. I actually did this with I ran a transform stream on the Wikipedia page for cloud computing. This is it, but every time it sees the word cloud, it's replacing it with but, which is great to read. Whereas I've got a favorite bit in here. See if I can find it. There it is. Oracle announced the Oracle but. While aspects of the Oracle but are still in development, this but offering is poised. I love the term but offering. That's great. So Service Worker is, this is Bruce Lawson's logo for Service Worker. I like it. It kind of makes me feel slightly drunk. It's great. You can polyfill new network features with it. You can become a faster network resilient, more network resilient. We've gone through a lot of stuff here at lightning speed, and that monitor's gone off, and I've got one slide left, so let's rush. There's also a free Udacity course where you can take a website from online only to offline first to use it over a series of examples. Covers the app shell model in IndexedDB. And with that, before everything just sets on fire and breaks, thank you very much. Cheers. And now it's time for a break, because I need one. So we're going to be back here at 11:30 for the next talk, which is by Emily, all about HTTPS. Thank you. Cheers.
So, welcome to Total Tooling Tips. This is an episode on DevTools where we're going to talk about our newer progressive web app tooling.
Yeah, so the reason we have to do this is we recorded an entire video episode and then everything changed.
It's Tuesday, so DevTools has changed. Right, so the resources panel has now been replaced by the shiny new application panel. So I'm currently on Progressive Web App. This is smaller pictures, and some of the newer stuff that we let you preview include like your web app manifest.
Yeah, so basically Web App Manifest is kind of, if you've ever built web apps so you've had to do icons for different devices and browsers and you had to put in lots of link tags, Manifest is a JSON file where you can put all of that stuff in one separate resource and the browser will only go and grab it when it needs it.
Yep, so we summarize everything from like your name, your short name, through the different theme colors and background colors that you're using. We show you your orientation chosen in your manifest file, and then just like preview all of the different icon sizes you might have set up. So I've got like all of them because I'm crazy.
You are crazy.
I am crazy. It also lets you emulate as a home screen if you click on this little link here. That's just like the experience where it'll show you, okay, well, what do you want to name this thing?
So the reason this is important is because whenever you click on Add to Home Screen, what it will do is it will go through all of the criteria that Chrome looks for to basically decide whether it's going to show the user the banner or not. So it'll be things like, does the web app have a service worker? Does it have a short name? Does it have a theme color? And if any of those criteria aren't met, it will print out an error to the console just saying, yep, you need to have this, and because it's not there, I can't do Add to Home Screen.
Cool. So the next thing we're going to take a look at is the service worker panel. So debugging service worker has been like historically really, really painful. And I think DevTools has nicely evolved over time to make that experience a little bit sweeter.
Yeah, this is definitely like the best version of it. It's just really hard when you're starting out to understand what is going on when you're doing this stuff for the first time. But I think this is definitely like the nicest version so far. Yeah,
so we're going to quickly walk through all the options here. So the first one is an offline checkbox. And basically, if we go and we refresh, you'll see that the app is working offline. This just emulates offline in the same way that the network throttling dropdown will let you do.
Nice.
Fairly useful when you're testing offline support with Service Worker. The next option is Update on Reload, which forces your Service Worker script to update on refresh.
So the reason this is super handy is before this existed, what you'd have to do is you'd make an edit to your Service Worker, you'd save it, you'd go back into your browser, you'd refresh, and once you've refreshed the page, it will still be using the old Service Worker because your new Service Worker will be grabbed by the browser, it will go through an install step, and the new Service Worker can't take over the page until the old one's gone. So when you check Update on Reload, what it's doing is it will unregister the old Service Worker, register the new one, and once the new one's ready to go, it will refresh the page, so then the page is using the new Service Worker. So it's one checkbox, but there's kind of a lot of stuff going on behind the scenes, and it's super useful.
Next up, we've got Bypass for Network, which will bypass your Service Worker script and load resources from the network.
The reason this is handy is when you're not working on a service worker and you're working on other files, you don't want anything to be pulled from the cache. You just want to be using the files that you've just changed.
Yep. Then we've got Show All, and Show All will basically show you every single service worker that's registered. Because we've got like an increasing number of sites and apps using this, you might find this a little bit noisy.
I'd just say you're very unlikely to ever want this until something like foreign service workers come in, but
yeah, we're just letting you know that it exists today, unless they change it tomorrow. But it's here today, at least. What else does this let you do? Okay, so you can update your service worker. There's a push option as well. What does that do? Let's head over to your demo.
I'm going to guess it's going to do something with push messages.
You're so bright, Matthew. Right, so this is a push demo Matt wrote a while back. We're going to go and we're going to enable push notifications, and your demo worked this time. Yes. Right, so what we're going to do is if we click push, it's going to emulate a push event, and you'll see that we get a push notification.
This is kind of interesting because this is the first time I've actually seen or like tested this myself in Canary, and they basically added a new feature where it's populating a little bit of data in there, which is kind of super interesting. Slightly weird with the fact that you can't determine what the data is, but it's awesome that it's there because it does mean that if you wanted to check what data would look like when it comes in your service worker, it's now something's there. It's awesome.
Sweet. And what happens if we click send a push via XHR? Does anything happen?
It should do.
It should do. Did I actually? Oh, I didn't. There we go.
Oh no, you did it. GCM just took a while to kick in.
Okay.
So there, because there's no data, it's just like a super generic, hey, thanks for sending this message.
Sweet. You can also go and click on the little name. Oh, you've got a minified service worker.
Yeah, man.
What do you do? Okay, let's go to someone who hasn't done that. And if we click on source, you can go and you can check out the source to your service worker.
He just
script.
doesn't care about users' data. That's offensive. So the reason this is actually super cool is the fact that you can now add breakpoints to your service worker like you would any normal JavaScript file. So when that code gets executed in the service worker, it will actually stop the service worker from running, and you can start debugging stuff like you normally would with DevTools, which is nice.
Sweet. You can also, so you can see that we've got like these activity indicators for the status. So green means that something is active and it's running. You can stop your service workers. We can go and do that. They'll say activated and stopped. You can focus your clients. So we're currently focused. You can also hit details, and it'll show you inline any of the exceptions or error messages you've been getting.
So the one thing that used to exist here that's been removed, you used to be able to have like an inspect button that you would click and it would open up an entirely different DevTools just for service worker. I still kind of like having the two DevTools, one for the page, one for service worker, but I think the DevTools team are trying to get everyone to work just out of the one DevTools and change different contexts. So in this case, all the service worker logs would show up in the one console, and you select different frames within that. So it's kind of interesting. It's the only thing that I'm anxious about, I guess. But this is quite a nice way of at least surfacing just the errors.
Because I'm ADD, I'm just going to click clear, and now all of our problems have gone. It's great.
If only life was that simple.
If only life was that simple. Clear storage is basically the best thing ever. If you're developing any non-trivial progressive web app, and you're trying to support offline with service workers, you're maybe using a storage mechanism like IndexedDB or local storage or session storage, you've probably run into the situation where you need to manually go in and clear all of your different storage mechanisms out, and then head to different panels to unregister service workers, and it's this whole super tedious thing.
Yeah, I've ended up writing helper scripts that I just drop into the console to delete everything. It's annoying when you get to that point.
So in an effort to make Matt Gaunt redundant, there's now like a clear site.
Well, that escalated quickly.
There's now a clear site data button. I think the label for this might be changing, but the button is still there. Basically, what this does is it almost resets the world for you, which is kind of really nice.
Yeah.
It does all the things it says above, like it'll unregister your service workers and your storage and clear out your cache API storage.
And yeah, this does seem like an obvious feature, but at the same time, it hasn't existed for the longest time. Yeah. And when you start working with service workers, you realize how quickly you just get into a mess and you just want to reset everything. And the old solution for that was to just develop in incognito windows. Yeah. So this is super welcome.
Yeah, this is so nice. We were talking about cache storage because this was resources panel. You can still go in and debug all of your different storage mechanisms. That includes the cache API. So in the case of my app, I'm using SW precache, so I have all of these entries. For someone like Paul Lutz's voice memos app, we go in here and you'll just see that there's an entry that's got all the different files listed that he's got cached in the cache API.
I wonder why the response is empty.
It's all perfect. It's all perfectly perfect. And you've also got other options in here like frames.
Don't just say that like it is. No one knows what frames is.
I don't know what this does anymore. It's basically got a breakdown of different things.
It looks like a list of assets that are
different
downloaded.
Assets. Let's assume that it does that. Maybe this gives us something to do another episode on.
Next week on Totally Talking Mini Tips. What is frames under Applications tab?
All right, so I feel enlightened. That is the Application tab. Is there anything we're forgetting?
You got device art on the screenshot that is also new.
I've got device art. So Canary DevTools now lets you preview device art for a few different devices. So we got the Nexus 5X in there. I think the 6 might also have device art. It does not. It does in the very, very latest version, I think.
Okay. So it's coming.
I think it's coming. But basically, device art is awesome. Just lets you see what it would maybe look like on an actual device.
And it adds in the navigation bar at the top and
so you can go in. You can go in here and get your little navigation bar in. I have asked for us to take the theme color into account. Maybe.
Oh yeah.
'Cause you could do that.
Yeah, that'd be really nice, and then it'll
Assume that by the time you've seen this, maybe we've convinced them, and this is already out to date.
And if not, raise issues, and then maybe we can get it.
All right, so that is the application tab. hopefully you'll find that a lot of this stuff makes it a lot easier to develop and debug your progressive web apps. That's it from us.
Thanks for listening.
Bye.
Welcome to this supercharged TLDW. I'm Paul. If you didn't catch the live stream with me and Surma last week, well, basically we built a side nav. Let me show you what we built. So you've got your standard app bar here. You can click on this sidebar and you can click on the background, or you can dismiss it with a sort of drag gesture like that. Awesome stuff. So let me show you how we built it. But before we do that, as usual, we're going to head over to, yep, you guessed it, Theory Corner. Join me. Hello, welcome back to Theory Corner. So this is what we've got. We've got our page and we've got a container element. The container element is going to be the home for the side nav and the background. What we're going to do, first of all, is we're going to put overflow hidden on this. We're going to make it take up 100% width and height. So it's got overflow hidden because this is going to transform out to the side and we don't want any scroll bars. So we put that in place. The background, we're just going to transition its opacity from 0 up to 1, and we'll set it to have a transparent black color, or semi-transparent black color in the background. The other thing is this side nav. We want this to slide in from the side, so we need to have will change transform on it so that it gets its own layer, very much like we did with the swipeable cards, and then we can transform it in and out. We're also going to need some buttons for bringing it in and out, and we're going to have some touch events so that we can do the dragging stuff. All cool? Let's go back to reality. Welcome back to reality. Oh yes, yes, reality. That's where you'll find us today. Pragmatic to the end. Code. Okay, so the markup and the CSS is pretty much what we discussed in Theory Corner. We've got an aside, we've got a few JS classes here so that we can pick it up in the JavaScript, but mostly it's pretty much what you'd expect. There's a button for closing, there's a button for opening, we've got a title here for side nav, and then we've got the list of the side nav content. In terms of the CSS, here's what we've got for the background. You can see it's actually done with a before pseudo element, and you can see that it's got a background of black with an opacity of 0.4. We've switched on will change opacity because we know we're going to be changing the opacity, so we're going to say will change opacity. Didn't say will change pasty. That would be a different thing entirely. We'll change opacity, and then we can set a transition of opacity with that curve. That looks quite nice. 0.3 seconds, nice and quick. Then the other thing is when we set the side nav to visible, which we're going to do with some JavaScript, and we can say to that before that we want you to fade up from an opacity of 0 to an opacity of 1. The same is pretty much true of the side nav itself. Here it is. And you see it's got a box shadow, so we got a nice little bit of shadow on the side. The interesting thing is we have to transform it by, in my case, 102%, which sounds really odd, but the reason is there's that shadow, and if you just transform it 100% to the left, you still see a little bit of shadow on the left-hand side. So we just take it a little bit further, solves that problem. The interesting thing about the side nav itself, the one that comes in from the side, is that it has a separate animatable class. The reason is I want to switch that off when they're doing the drag motion and have it on when they're doing the automated transition from the side in and out. So we use this class to basically say this is kind of, it's doing the automatic transition, or when it's off, it's going to be used for the dragging. Cool. The JavaScript is over here. And it's the same trick as last time, a bunch of event handlers that we bind on with this. If you haven't seen why I do that, go back and watch the Swipeable Cards TLDW explain pretty much why I do this approach to my event handlers. You don't have to take this approach, but it works pretty well for what I'm doing. So we bind all those on, and you can see here we've got the show and the hide. Now here's an interesting one. I actually say that if you click on the side nav, the containing element, the container from Theory Corner, I want you to hide the side nav. Well, that will work, kinda, but then if you click on something inside the side nav, well, that's kind of weird because you clicked on something in the side nav and it's going to dismiss. And the way we get around that is we basically say the side nav itself, that's going to hide it, but any clicks inside, we're going to call this block clicks function, which you can find down here. And block clicks, all that does is it stops the propagation. So it's almost like canceling the event. Now, you don't want to do this all the time. You only want to do it when it makes sense for your app, and it makes sense in my case, I think. So that's all good. So I think all that's really left is to just have a quick look at that drag motion. Now, if you remember, the drag motion looks like this. We can click and we can drag, and if we just come away from the side a little bit and let go, it dismisses the side nav. So let's see how we code that in. Well, we have our on-touch start here. And basically, because this is bound to the document, I basically say if the side nav isn't open, bail. Don't hang around. So we're going to call this anytime somebody hits touch start, but we only want to deal with this if the side nav happens to be open. And what we do, very much the same kind of deal as the swipeable cards. We capture the start position and we copy that across to a current position. And then in the touch move, we basically figure out how far we've moved, and then we can apply a transform in a kind of game loop and update function, which you can see here. There's the translate, current minus start, and then we apply it as a transform. If you've seen swipeable cards, this is all sounding very familiar, I'm sure, but it works, and it works really well. The last thing is, on touch end, we basically say if you've translated just a little bit to the left, hide the side nav. That works out really well for us. One other little thing to note is this. In terms of the on-touch move, by default, you'll get that throttled back in Chrome. So you won't get them every frame unless the very first touch move event has an event.prevent default on it. So what we do is we calculate the translate, and we say if it's less than 0, as in you've started to move it, we prevent the default, and that means that we'll get all the updates from then on. So there you have it. That's the side nav. Pretty straightforward in terms of these things, but this works really well. It works at 60 frames a second, even on a mobile device. If you haven't caught the live stream, again, it's about an hour long. It's in the description below, so have a look through there and have a watch of that if you've got a spare hour. Again, it's usual kind of stuff. You see all the bugs, you see all the chat, you see all the discoveries and the kind of discussion that Surma and I had. Don't forget to subscribe. Done. And I'll catch you next time. If you, like me, like clicking on things, you can go, okay, hit the subscribe. And there's the live stream.
Hey folks, welcome to Totally Tooling Tips Season 3.
Come check us out. We're going to be talking about progressive web apps, some of the tooling around them.
On first visit, we've got a relatively fast time to first meaningful paint.
Module bundling, accessibility.
Do you know what the top 4 things to look at when it comes to web accessibility are?
No, I can only think of 2. Like, I only think of audio and then visual.
So there's visual, hearing, mobility, and cognition.
The first episode will be out on April the 27th. So subscribe to the YouTube channel, check out Season 1 and 2 before Season 3 starts, which will be happening soon.
We promise that Season 3 is going to be equally as mediocre as Seasons 1 and 2.
Chrome 51 makes it easy to know when an element enters or exits the viewport with intersection observers. You can make the sign-in process way easier with the new Credential Management API, and you can reduce jank with passive event listeners. I'm Pete LePage. Let's dive in and see what's new for developers in Chrome 51. Intersection observers let you know when an observed element enters or exits the browser's viewport. No more jank-inducing calls to get bounding client rect or listening for scroll events. To use, simply create a new intersection observer, provide a callback and an options object. Then tell the observer which elements to watch. Boom! When the element enters or exits the viewport, the callback is fired. Check the description below for a link to a demo, browser support, and more. Creating, remembering, and typing passwords is a pain in the neck, especially on mobile. Chrome 51 supports the Credential Management API, a new W3C spec that allows your site to interact with the browser's credential manager and federated account services like Google and Facebook, improving the login experience. The API has 3 key methods: navigator.credentials.get to get the user's credentials and initiate a sign-in flow, store to save the user's credentials in the credential manager, and require user mediation to disable automatic.
All right, everyone, welcome back. Thanks for playing my personal theme music. Hi, everyone. My name is Emily Schechter. I'm a product manager on the Chrome security team. And today, I would like to take you on a myth-busting journey about the protocol we use to send and receive data on the web over a secure connection. And that's HTTPS. And I think this is one of the most important topics for a web developer today. So our story begins on a dark, creepy night in 2010. Imagine that in 2010, you're sitting at your computer, you're surfing the web, you're getting sucked into a YouTube hole, you're watching the Twilight Saga trailer, or maybe that Double Rainbow video, or one of the other popular YouTube videos in 2010. And you fall into a deep sleep, so deep that you don't wake up until today, until 2016. And you look around at the web today, and it looks pretty different from the way things were in 2010, right? Today we have things like add to home screen, which lets sites behave more like apps. And we have push notifications, which help you keep engaged with your users, keep them coming back. And we have cool new APIs like device orientation and geolocation. All these cool things around today that let you build progressive web applications, that let sites do all of the cool things today that they really couldn't have done in the past. So these things are very powerful features, but they're also a lot of responsibility, right? Take geolocation as an example. If a site knows where I am, it also knows where I work, where I live, where my friends live, maybe where my children go to school, where my doctor is. And that's a lot of stuff for a site to know about me, right? So if you woke up in 2010 to find this very powerful web, you might be surprised to learn that there are still websites out there where you can make a purchase with your credit card, or send a private message to a friend, or research a sensitive medical condition in such a way that an attacker eavesdropping on the network can see all the data that you're sending back and forth. Or you might be surprised to learn that there are still websites out there that spend tons of money and time and energy crafting the perfect user experience, only to deliver that perfect user experience and have some ISP or Wi-Fi provider or some other intermediary inject really ugly, obnoxious ads like this. And this isn't a hypothetical. We actually see major ISPs doing this, ad injection, all the time. And if this was your site, you'd probably be pretty upset, right? Because this interferes with that perfect user experience. It might be disrupting your revenue streams by blocking your own nice ads. And worse, it might actually trick your users into downloading and installing malware on their computers. So if you woke up in 2016, you might hope to wake up to a web where data is protected from this kind of snooping and tampering from the very beginning. And that's what we get with HTTPS. That's what this green lock signifies. And in 2016, we're hoping to move towards a web where this green lock is so ubiquitous that we might not even need to show it at all, because it's just the bare minimum security that we've come to expect for any site on the web today. So this green lock signifies three main security properties. First, identity. When you type https google.com into your browser receives a cryptographic proof of identity called a certificate from the server. And the browser uses that certificate to prove that it's talking to the real google.com, not some other fake site who's pretending to be google.com. So when you type a URL into your address bar, the browser gets a proof that that's the real domain you're talking to. Next, confidentiality. Once your browser knows that you're talking to the real google.com, both those parties, the browser and the server, have a guarantee that only they can read the data that's being passed between them, and not any other friendly person eavesdropping on the network. And finally, integrity. The browser and the server have a guarantee under HTTPS that when they send data from one to the other, the data they receive is what the other party receives. So an intermediary in the network can't modify or tamper with the data that's being sent. Only the browser and the server can. And that's what we get from HTTPS. But you might also have some other associations in your mind with HTTPS. When you see this green lock, you may think that it represents a financial burden or a performance cost or a lot of maintenance, or it's really difficult to set up. And many of these associations actually were true 10 or 15 years ago, but many of them are no longer true today. And that's because people all over the world and all throughout the web ecosystem have been interested in promoting a safe future for the web where HTTPS is everywhere. So in this talk, what I'm going to do is tell you 4 stories about HTTPS, try to separate fact from fiction, show you what might used to have been true in the past, but is now becoming a bit of an HTTPS myth, and try to convince you that HTTPS is both possible and important for every site on the web today. So my first story is about a web developer named Alice. And Alice runs an online travel guide. You can see it here. It's a very cool, awesome travel guide. But it doesn't have any privacy or security-sensitive content. Like, it doesn't have a login page. You can't make any payment transactions. And so Alice doesn't think of her site as something that would require HTTPS. But one day, Alice is talking to her friend, and her friend says that on her computer, Alice's travel guide is really slow and sluggish. And Alice is like, okay, that's weird, because on my computer, it's really fast and snappy, right? Because that's the way I built it to be. So she goes to her friend's house, and she checks out what's going on. And you can probably guess what's happening. She sees a bunch of terrible, slow ads plastered all over her site. So this is ruining the experience that Alice has built. It covers up her own lightweight, unobtrusive ads. And Alice's friend trusts Alice's site, so she clicked on these ads, and when she did, she didn't expect to get the malware that she downloaded onto her computer. And this is natural, right? A user who sees terrible ads on a site blames the site for that terrible experience. So Alice is pretty sad about this, as you would be, I'm sure. And to console herself, she starts working on a new feature. And let's say this new feature is using the HTML geolocation API to suggest fun travel stuff to do based on this user's location. But as she goes to implement this feature, she goes to try it out in Chrome, and she sees that it doesn't work. And the reason that it doesn't work, as you can see in this error message in the developer console, is that Chrome and other browsers are starting to remove support for powerful features like geolocation when they can't be safely used over non-secure HTTP. So in order to use the geolocation API, your site needs to use HTTPS. And there's a good reason for this, right? If I'm going to trust Alice's site with my location, I need to know that I'm talking to the real Alice's site, not some other site pretending to be Alice's site. So we need that identity property of HTTPS to be sure that when I grant a site access to my location, I'm actually talking to the site that I trust with my location. So Chrome and other browsers, as I said, are not limiting this to geolocation. There's a list of features that have already been removed when accessed over non-secure HTTP, and there are a few more that are coming down the pipeline. I want to call out App Cache specifically, which is coming up next, and longer-term EME. We actually don't have specific public timelines for these yet, but they are coming up next. And we'll be sure to be responsible when announcing timelines. We'll add a notification in Chrome Dev Console. But if you are relying on App Cache or EME over non-secure HTTP, we encourage you to start thinking about HTTPS now before it becomes an emergency. So what about service workers? Service workers are amazing, as you've been hearing today. My love for them is represented here by these sort of bizarre, blobby Android heart eyes emoji. They're the secret superheroes behind progressive web apps that enable performance in the face of sketchy network conditions. Service workers sit between the browser and the network, so they actually manage every request that comes through. And as you can imagine, Alice, as a site owner, needs confidence that she is the one managing those requests. They're not being controlled by some other super friendly person on the network trying to enhance your browsing experience. And this is why service workers require HTTPS. So Alice realizes, after all that in order to build a progressive web app with the features that she wants, and in order to guarantee that the user experience she builds is the one her users receive, she needs to use HTTPS. And this is why we think that it's important for every site on the web today to use HTTPS, even if the site doesn't seem immediately privacy or security sensitive. So this story is fiction. So our next story is about performance and a data-driven guy named Bob who's done some careful testing, some A/B tests, and he has found that reducing latency, reducing the time it takes for a user to load a site, is crucial for optimizing conversions on his site. So the faster his page loads, the more money he makes. And Bob has heard some not so nice things about HTTPS and performance. Yell.com is an online business directory that recently made the switch to HTTPS. And they recently published a blog post describing their move to HTTPS. And what's interesting is that they did experience some negative performance results. And on the other hand, Google moved Gmail to HTTPS way back in 2010 with basically a negligible performance impact. So Bob is wondering, what's going on here? What's sort of the discrepancy between these two stories? So let's dig into some of the reasons for this discrepancy and try to figure out how you can move your site to HTTPS without a performance hit. So first, let's look at a simplified view of what it might take to send an HTTPS request. And here I'm highlighting some of the network latency imposed by the extra round trips between the browser and the server created by using HTTPS on your site. So first, there's an HTTPS redirect. If you follow a link to an HTTP page, the server says, actually, that's moved to the HTTPS version. Next, the browser and the server do what's called a TLS handshake, where the server presents that cryptographic proof of identity, which is called a certificate, and that sets up the HTTPS connection. And finally, the HTTP request is made. So it turns out that if you dig into what it takes to communicate over HTTPS, there are some technical optimizations that you can do to reduce latency. So let's step through this again and see what we can do to optimize at each step. So first, there's that initial HTTP redirect to the HTTPS site. Strict Transport Security, or HSTS, is an HTTP header that helps you avoid redirects from inbound HTTP links to your site by telling the browser, only access my site over HTTPS for some period of time. And you can set this period of time yourself, and you're committing to supporting HTTPS for that period of time. And so HSTS helps improve performance by avoiding that redirect round trip. So the next two round trips are used to set up the secure connection over which the browser will send the HTTPS request. And this is known as a TLS handshake. So let me interject here for a moment to tell you that as a product manager and an all-around friendly person, I shake a lot of people's hands, and there are some really terrible handshakes out there. First, there's kind of that bone crusher handshake, which just cuts off all circulation to your fingers, right? And then there's like the sweaty palm, which is just brutal. There's kind of the dead fish, which honestly just makes me depressed. But the worst kind of handshake is the person who grasps your hand and kind of shakes it and then just looks at you and continues shaking and keeps looking at you and keeps shaking and shaking because it's just incredibly awkward and it just takes such a long time. So the moral of this story is you have to make your handshake as short as possible to get on to the really interesting part of the conversation. So normally, the browser and the server are doing one of these long, terrible handshakes. And the browser is waiting for this TLS handshake to be completed before it sends the HTTP request. But this is actually not necessary. You can actually remove handshake latency by sending the HTTP request in the middle of the TLS handshake. So after the certificate is received from the server, but before the TLS handshake is completed. So it will look like this. And this is called TLS false start. And you can turn it on in your server software, and it removes a round trip from the handshake latency. And if the browser and the server have spoken TLS before, the browser can remember a session ID. And the next time it goes to make a TLS connection, it sends that session ID, which allows the browser to shave off part of the TLS handshake. And this is called TLS session resumption, and it also allows you to shave off a round trip. And if your server supports it, you should turn it on. So now that we've talked about optimizing that first redirect and optimizing some of the round trips in the handshake, let's talk about sending the actual HTTP request. And this is where things really get cool, because this is where HTTPS unlocks some pretty dramatic performance improvements in the form of HTTP2. This is the next version of HTTP, which is now supported in many browsers, including Chrome and Firefox. And using HTTP2, you can do really cool things like multiplexing and server pushing, which majorly optimize performance for HTTP requests. And Surma is actually going to give an awesome talk on HTTP2 that dives into these details right after this talk. So please stick around for it if you're interested in more details. So I mentioned that HTTPS unlocks the massive browser performance wins of HTTP2. And what I mean by that is that browsers have said they are only going to support HTTP2 over HTTPS. So if you want to use HTTP2, you have to use HTTPS. There's a practical reason for this, and it's compatibility. So there are some intermediaries, like proxies, that are likely to get kind of confused, or in some cases actually break things if they see HTTP2 traffic, because it just looks so different from normal HTTP1 traffic. So we need the confidentiality guarantees of HTTPS to be able to support HTTP2 without actually breaking anything. So if we go back to Yale.com, that online business directory that Bob read about, and was unhappy to see that they had negative performance impacts from moving to HTTPS, it turns out that most of their performance impacts were mostly due to outdated load balancers that they couldn't update at the time, and they couldn't actually turn on HTTP2, but they're planning to upgrade to HTTP2 in the future. And we have hope for Yale.com because of stories like Weather.com, who saw a small performance impact from moving to HTTPS, but it was then majorly blown out of the water by the subsequent performance wins of moving to HTTP2. So in the end, since Bob is in a position where he can update his server software and turn on some of these optimizations, he shouldn't see any performance impact from HTTPS, and if he does, he should be able to far outweigh it by moving to HTTP2. So we have to update the way that we talk about HTTPS and performance. HTTPS is now necessary for achieving the best the web can offer, and HTTP is underperforming. So how many of you work at startups? All right, a few? Awesome. So my next story is about a startup that might be something like yours. So Charlie has an idea. It's about messaging with friends on the web. And she raises a bunch of venture capital funding for it. But these days, Charlie's startup is kind of running out of money, and the VC market has gotten a little bit tighter, so she needs to make sure that every dollar she's spending is going to a good cause. And she's heard that HTTPS costs money, maybe money that she can't afford. Now, money is sort of part of all of these stories in some way or another. I talked about performance, which kind of boils down to money. And next, I'll talk about ad networks, which is about money. But in this story, I'm going to focus on two aspects that Charlie is particularly concerned about. Those are certificates and search ranking. So first, these cryptographic proofs of identity certificates. When you need to get a certificate, traditionally, you buy it from an organization called a certificate authority. You prove your identification to the certificate authority, and it gives you a certificate that you use to prove your identity to browsers. You might wonder how much these certificates cost. While it's certainly possible to pay a lot of money for certificates, you certainly don't have to. A project called SSLmate has, for many years now, been offering standard SSL certificates at $16 a pop. And you can also get one of their more advanced options, multi-host SSL, or multiple certificates. And even if you need one of these, it really shouldn't break the bank. And there's a newer project called Let's Encrypt, which actually offers free certificates. And both of these projects, SSLmate and Let's Encrypt, offer automated command line tools that help you buy and manage your certificates automatically. So they don't expire, you can set up configurations, other tasks like that. So certificates are not going to be the reason that Charlie's startup runs out of money. The other thing that Charlie's worried about is search ranking. You can imagine that if you move your site to HTTPS, search engines might get kind of confused, and you might lose search ranking because kind of a traditional nugget of wisdom is that having two different versions of your site can have a negative impact on search ranking. So Google in particular has a few best practices that you should follow when moving your site, and here I'm going to talk about the basics. So the first thing you should do is serve 301 redirects to show search engines that your site is at the HTTPS version. And once the search crawler gets to the HTTPS site, it's important to serve these canonical link elements to reinforce the idea that this is the canonical version of your site. And there are a few other best practices that you should follow. 3 are up here, and I encourage you to go check out these resources after the talk. So if you do your research and follow these best practices, you can expect a minor fluctuation in search ranking, which happens anytime you make large changes to your site. But you'll then recover back to your normal levels that you had before the transition. In fact, Google even does have a search ranking boost for HTTPS sites. So it's actually considered a positive ranking signal. At present, it is pretty small, so you probably won't notice a large boost. But it's possible. We're hoping that might change in the future. And it is a small positive signal now. So in other words, if you follow best practices, take a little time to do research before moving your site over, the financial costs for certificates and search rankings should be negligible. So my final story about HTTPS is the story of Francisco and his adventures with third-party content. I'm sure that many of you have lots of third-party dependencies on your site. So let's say that Francisco runs the website for a major news corporation, and that means he has a large site with a lot of articles, a lot of legacy content, many different types of third-party content to worry about, like old images. And he's heard that if you move to HTTPS, all of your content, including the third-party content, also has to be served over HTTPS. So it's easy to see why this might freak Francisco out a little bit, because it's true that when you move to HTTPS, you're going to also have to start to think about whether all your third-party content is available over HTTPS. First and foremost, Francisco is worried about ads because he runs a publisher site, and ads is how he makes all of his money. So Francisco is wondering whether his ads will be available over HTTPS. Well, something that has changed in the last year or so is that for Google AdSense and ad exchange requests, they're always served over HTTPS for most users. So even before Francisco has served his site over HTTPS, his ad exchange or AdSense ads are already being served over HTTPS for most users, so he shouldn't have to worry about this. And the exception here, why I'm saying most users, is actually only for users located in countries that actually block or degrade HTTPS traffic. And this isn't just a Google thing. It's actually an industry-wide trend. In 2013, the IAB, the Interactive Advertising Bureau, published this blog post saying that nearly 80% of their member advertising systems support HTTPS, and they underscored their commitment to getting all the way there to 100%. So this is one of those things that I talked about where 5 or 10 or 15 years ago, pretty much no ads were being served over HTTPS, so this was a major issue. But now the entire industry is changing, and in this day and age, serving ads over HTTPS really shouldn't be a blocker. And if you're using an ad system that doesn't support HTTPS yet, it's probably on their roadmap, and if it isn't, you should ask them why not, and you should tell them I said why not. So the next type of third-party content that Francisco is worried about is the partnerships that he has with other sites that depend on the HTTP referrer header. And what this means is that other sites can tell that the traffic came from Francisco's site. In other words, Francisco's site has referred the traffic to those other sites, so Francisco might get some money for this. And the problem here is that if a user follows a link from an HTTPS site to an HTTP partner site, browsers will strip the referrer header for privacy reasons. And that makes sense because if you're doing something sensitive on an HTTPS site, the URL that you're on might be sensitive information, and the browser shouldn't just leak that in plain text over the network to an HTTP site. Fortunately, there's a web platform feature called referrer policy that helps with this. And Francisco can set a referrer policy to allow his partners to see that traffic is coming from his site, but they won't see the full URL that the user was visiting, so user privacy is still somewhat protected. Finally, Francisco is losing sleep over a kind of general problem called mixed content. And mixed content is the problem of loading non-secure HTTP content on an HTTPS site. And this is important because non-secure sub-resources can actually compromise the security of a secure HTTPS site. So if you try to load insecure scripts or iframes or other active content like that on an HTTPS site, browsers will actually block it because that content is just too powerful and would completely wipe out all the security of that HTTPS site. So Francisco's site, it's a news publisher, so it has lots of old news articles that link to third-party images that aren't available over HTTPS. And we call these images passive content, and browsers will still allow them to load, so the site won't be completely broken, but that green lock does go away. And Francisco's really not happy with this because he wants his green lock that he worked hard for. Fortunately, Francisco can serve what's called a content security policy to receive reports about mixed content. This header is basically a way for Francisco to assert to the browser that all content should be loaded over HTTPS, and he wants to receive reports about any content that isn't. And that allows him to go find and fix mixed content on all of his millions of pages, which means that he doesn't have to rely on users to report broken behavior. He'll be able to find and fix problems as soon as they arise. So in this case, the CSP says all content should be loaded with the HTTPS scheme, but inline and dynamically generated scripts are OK. And send a report to this URL whenever content violates this policy, but don't block content, only report it. And if you don't want to build infrastructure to collect reports yourself, I suggest this awesome service called reporturi.io, which gives you some cool data visualizations. And for all of these issues, in Chrome, we recently launched the DevTools security panel to make it as easy as possible to find and fix problems with HTTPS configurations, such as these mixed content problems. So Francisco's story is true, in that third-party providers must support HTTPS in order for you to move your site over. But what's new, what's changed in the past few years, is all of these new tools and support in the ecosystem and in the web platform to help you upgrade your third-party content. So when I look back at these 4 stories about HTTPS that I told you today, I think there's one kind of moral that emerges. And that moral is that 5, 10, or 15 years ago, HTTPS used to be kind of slow, kind of expensive, kind of a pain to set up. But these days, in 2016, browser vendors, web developers like yourselves, server software developers, security researchers, the whole wild, wild west of the online advertising ecosystem, all of these people have come together to make HTTPS a lot faster and easier and cheaper and all around better than it was in the past. And HTTPS is necessary for unlocking the best the web has to offer in terms of both capabilities and performance. And that's why we think it's both possible and really important for every site on the powerful web today to use HTTPS. So thank you so much for listening. If you have any questions, come find me after, either in the CodeLab area or in office hours tomorrow. And next up, Surma will be giving an awesome talk about HTTP2, which is unlocked by HTTPS. So welcome, Surma.
Hello, everybody. I'm actually really relieved that I can be here on stage, because a few days ago, it didn't look like I would be here. I had like this massively hoarse throat and didn't have any voice left, which what you kind of need when you want to be on stage. So I went to the doctor the next day, and he did the whole wooden spatula flashlight thing, looked, and then he said, "Oh yeah, I see it." And I was like, "What?" And then he grabbed a pair of pliers, went into my mouth, and pulled out like an inch of bamboo fiber, a splinter that I apparently swallowed and that just lodged in the back of my throat. And 5 minutes later, everything was fine again, my throat was normal, my voice was back, and I thought, great, then I flew here and caught a cold on the flight. I guess that is bad luck. Also, if you're wondering if that story had anything to do with my talk, it absolutely didn't. So my name is Surma. I work with the Google Chrome team in London, and I'm here to talk to you about instant loading and how HTTP2 ties into that whole story. So instant loading, you probably know the experience. You have something on the home screen of your phone. You tap that icon, and you expect the app to be there instantly, to open up, and to be ready for you to work with. And that is something that shouldn't have any white screens or spinners, ideally, so you just want to be, the app should be there right away for you to work with. And I'm here to talk about how you can achieve that with your web apps. And it's actually pretty easy. You take a service worker, you slap it onto your web app, you make it cache everything offline, enjoy your instantly loading app. Done. End of talk. See you later. Obviously, my talk is supposed to be a little bit longer, so it was more of a setup. However, that advice is technically correct. You can't load much faster than loading from local cache with a service worker. However, how do you get all your things into the cache that the service worker uses? And with web apps, that involves the network, because you have to download them into the cache. And then you have new bottlenecks. You have the network, and you have latency, and all these kind of things. And what do you do when some of the assets have to be updated individually? In this talk, I want to talk about these kind of questions. I will not even cover service worker, because there's so much that you can do before service worker actually get into the whole equation. Because on the first load, the service worker is not there. And on the first load, that is your first impression. So you have to get that right too. So let's rewind a bit. Yes, we want to achieve instant loading, but that includes the first load as well. And with the web, that involves the network and downloading with HTTP before the service worker is there. To a certain degree, all the optimizations that we're going to talk about also benefit the service worker because loading from cache is kind of similar. However, the impact will be a little bit smaller. So I will I'll focus on the first load, because that scenario is the worst case on the web. You have nothing there locally, so you have to get everything on the web. If you have something cached, for that resource, you already removed one of the biggest bottlenecks, that is the network. The overarching theme, as you will realize, of this talk is keep your assets small. If your markup is small, it will go faster over the wire, the parser has less to do, and it will be done sooner. Same goes for JavaScript, same goes for style sheets. So just keep all your assets as small as possible. Once we have that, then we can actually look at the remaining optimizations in the instant loading problem space, so to speak. And as I said, I'm going to tackle this entire thing without even talking about Service Worker. We're going to look at the features of the web platform as well as the HTTP protocol. And if you don't know about the HTTP protocol all too much, good news is we just launched a new Udacity course today. And if you want to sign up for it, just go to the URL that is on the slide right now. You can sign up, and we're going to start from zero and take you all up to the all modern things of HTTP 2. So let's get back to the actual talk. The assets. What actually are assets? Well, actually, something like your index HTML, the images, the style sheets, the JavaScript, everything that needs to be requested as a file is an asset. And if these assets are not delivered fast, your app won't be fast because your app won't work without your assets. It can't operate without them. And there's a lot of opinionated discussions out there, what framework to use or what CSS preprocessor is the right choice. And this is not what this talk is about, because whatever you choose, whatever framework you choose or preprocessor, the files still have to be delivered to the user. So get your infrastructure right first, and all the other choices can be made after that. And you might be asking, why is instant loading important anyways? And Garber made a really interesting observation here, which talks about conversion. Every step that you make a user take before they get value out of your app will make you lose 20% of your users. And loading is definitely a step, both for native and for web apps, because you're forcing your user to do nothing, to just sit there and wait. And installing is actually another step, and the web is great at that step because we have no install step. You just open it up and you're right there, while on native you mostly have to actually install the app. So if you do it right, you can have much more users on your web app than a comparable native app. And additionally, multiple companies in the e-commerce sector have independently researched and confirmed that a reduction in load time also correlates to revenue. So for example, Amazon has famously stated that an increase of their loading time by just 100 milliseconds will cost them 1% of their revenue. And that really makes you think about how much it is worth to spend time on this. But let's get down to tech. Let's talk about how we actually tune our asset delivery to the max. And there's a lot of facets that can be tuned and that have varying degrees of impact and require varying degrees of commitment and investment by you. So let's start with something that has a very high or at least medium impact and requires almost no commitment at all, and that is compression. If you take one thing out of this talk, please enable compression. There's a lot of sites still out there that don't do it, and it is so easy to do. You mostly need usually one line in your backend configuration to enable it, and your content doesn't care. The browser of a user can be very old. It is so good, so well supported. Your logic doesn't care. It is performance for free. It is practically money in the bank. And some people say they are concerned about increasing their CPU load on the backend, and I think it is only partially true, because at least for static content, you can compress ahead of time or cache the compressed response so you never have to compress again. And if you choose to enable compression just for static assets for now, it would still be a big win for everybody involved. And when I say big win, I actually mean 60% to 80% data savings without you putting in any actual effort. The compression ratio, and you have to realize that, is actually both money saved in traffic and speed gained in loading time. In general, talking about this table, minification plus compression will give you a little bit better results than just compression alone. If you look at CSS files, they will mostly have almost the same size, while the gap between compression and minification plus compression will be a little bit bigger when you talk about JavaScript. And that is mostly due to the fact that JavaScript tends to have comments in it, which are stripped away by minification, but remain there if you only compress. One of the main causes of slowness of the web today is network latency. Mostly we have solid connections and rather predictable speeds, but the time it takes for a byte to go from A to B and back varies widely across the world. And that has a huge impact on how your web app performs. These round trips are deceptively expensive. Even on a wired connection, when you're visiting a highly optimized website, a round trip can cost you, or will cost you, 20 to 50 milliseconds. And with HTTP, that means when you send a request, you can't use the connection for anything else until the response has been sent back. So this is time spent waiting, doing nothing. And then you have to realize the average website nowadays makes roughly 100 requests. So with a little bit of back-of-the-napkin math, it turns out that when you have 100 requests and at most 6 connections to the same server, that means that the browser will spend at least 833 milliseconds waiting just because there is a round trip. And that means that shaving off a single millisecond of your round trip time is worth the effort because it has a huge impact. HTTP multiplies the impact of the round trip a lot. And for example, redirects are something that I encounter very often that mostly don't bring any value to the user and can be easily avoided most of the time, which for example, HSTS is for, that Emily just mentioned. And on the contrary, redirects can actually be even worse because they usually mean not only another round trip, but also a new connection, a new TLS handshake, and therefore are even more expensive and just delay the user getting to your site. But so far, we have mostly talked about how we can make things go faster over the wire. And that's good. That is really important. However, our job as web developers is not done when the data arrives on the user's device. We also have to structure our app in a way that it loads fast and also is interactive as soon as possible. And interactive or visually complete is something that is a purely psychological measurement. And a screen with a few empty boxes will be much more pacifying to the user than a white screen. And if you have content above the fold actually fully rendered, that's even better. And that will influence the opinion of the user about your app very heavily. And one thing that you can do very easily to increase the time to be visual earlier is to delay your JavaScript until the HTML has been parsed. By default, without any attributes, a script tag will be blocking. That means when the HTML parser is going through your document and it encounters a script tag, the HTML parser will pause until that script has been executed. If that script is an external script, that means the parser will pause, it will open up a new connection, it will possibly do a TLS handshake, it will request the file, download the file, parse the file, execute the file, and then the HTML parser can finally continue. This is actually something that will delay your render quite significantly. And with the async keyword, you can tell the browser that it's all right to keep parsing HTML while it is preparing the JavaScript to be executable and will pause when it can finally execute. Defer, on the other hand, is even stronger. That means you are fine with deferring the execution of the JavaScript to the point when the HTML is done. And that means that you can be sure that the DOM has been parsed, has been put on the screen, and you have something visual to keep the user busy while the JavaScript is spinning up. And if you're like me and you can't remember which one is async and which one is defer, just be like me and put both. Because defer is stronger than async, and you should always be doing defer anyway, so you will end up doing the right thing. Can't go wrong. Sadly, link tags, which we use to pull in CSS, don't have support for async or defer. So, but just like JavaScript, they do block the parser, so we're kind of screwed in that regard. So what do we do about CSS? Well, there is this tiny piece of code by the Filament group that allows you to dynamically load CSS. And that's a great tool. However, be careful to not just slap it onto all of your style sheets, because you will end up with flash of unstyled content, because now you have deferred everything. Your HTML will be rendered without styles on the page, and then all your styles come in, and it will have like things moving around and changing colors, and it will be a really, really bad experience. So we have to find a good middle ground between putting everything in the head and be blocking, and deferring everything and have a flash of unstyled content. And good advice is here to use regioning or critical CSS. A common practice is to inline the styles for things that you consider critical and defer everything else. This also gives you a chance to prioritize which style sheets need to be loaded next and in which order, so you have more control over when bandwidth should be allocated for what job. Regioning CSS ties into that. That is the part of the CSS that make elements assume the size that they're going to have once the full styles have been loaded. Basically, that means that you won't have elements jumping around on the page when the full styles come in, because they have already assumed their final size. You could even go further and inline the styles entirely for your above the fold content to basically keep the user busy while everything out of screen is rendered later. A good example for regioning CSS is Paul Lewis's Guitar Tuner app. What you see on the left side is the styles that have been inlined. And the markup for it is really, really small and is therefore on screen very, very early. And then the JavaScript is being bootstrapped in the background, and when the app is finally loaded, it will look like the image on the right. But this is a purely psychological trick, but it goes such a long way on how the user feels about this app, because it feels like it's there immediately, even though it is actually not. Another issue is iframes. Iframes are a resource, and that means that a page is not allowed to fire its load event until all the iframes are completely loaded themselves. And if the iframe contains iframes, things get even worse. Basically, what I'm saying is iframes make you lose control over your page's load event. And that is bad, because most libraries and a lot of frameworks actually use the load event to know when to start working. So what can we do about this? You want to have that event fire rather sooner than later, because you want your framework to spin up. So if you have non-critical iframes, I wrote these 3 lines of JavaScript that basically say, put your source for the iframes in a data source element. And you can have this JavaScript run after the load event. It will move the data source attribute to the source attribute, and then the iframe will start loading, and the load event has already fired. You have gained back control over your site. However, keep in mind that these iframes won't work if JavaScript is disabled or doesn't run for some reason. So use it for non-critical iframes. So as I said, conserving data is probably the easiest way to make apps load fast. If your app doesn't need a lot of data to get running, it will be fast by very definition. And that's why a good caching strategy will improve the loading times even more. And I know we have Service Worker, and with Service Worker you can do arbitrarily complex offline strategies and caching stories and whatever. However, Service Worker, the foundation of Service Worker is progressive enhancement, and that means that your app should also work when the browser doesn't support Service Worker. And ideally, it should even perform when there is no Service Worker. And so I think this is a good time to look at what HTTP, the protocol, actually offers in terms of good caching. Most HTTP responses contain both a last modified and an e-tag header. The last modified header says, well, when the document was last modified, and the e-tag header actually contains a unique value that is solely based on the contents of the file. Most server implementations actually use a checksum like SHA-1 that is solely based on the content of the file and will only change if the contents change. And both these headers can be used to avoid re-downloading a file if there is already a cached version locally available. If the browser has a version locally available, it can add any of these 2 headers to the request, basically telling the server which version it has available, The browser can check, the server can check if the document has changed ever since, and if not, it can respond with a status code 304. That means not modified, basically telling the browser to use the locally cached version available. And what we've just did, we basically saved the user from re-downloading files that they already had. And that is really important. And as you can see in the example, actually specifying both headers is allowed. And e-tags will take precedence over date-based headers as they're considered more robust. However, it is still a request and response. It is an entire round-time trip. So there's still a lot of time being wasted here. And this is where actual HTTP caching comes in. Caching tells the browser how long it is allowed to consider this version of the document fresh, and to deliver it straight from cache without even checking with the server. Expires is the older HTTP 1.0 header for caching, and cache control is the newer HTTP 1.1 version for cache control. Cache control is much more powerful and complex. It supports multiple variants of different cache types like public and private. You can get very granular control. It actually has its own domain-specific language, so it's a little bit overwhelming. But most of the time, you should be fine with what you see on the screen right now. Public and the max age, which is the number of seconds until this document expires. And the next question almost immediately becomes, so what are good values? Should I cache my JavaScript for 10 minutes and images for an hour or a week? And I think Jake has a really good answer here, because he said, with interdependent resources, which JavaScript and CSS mostly are, the only sensible HTTP caching options are must revalidate or a year's worth of max age. So what does it mean? This means that something like your index HTML should never be cached. It should always be revalidated with the server, as we saw before with one of these if modified headers. Something like web fonts should probably be cached with years worth of max age, because they will never really change. And now we are still at the point that every resource would be revalidated with the server, which is not really what we want. And this is where a trick comes in, where we incorporate the hash of the file into the file name and crank up the caching time to a couple of years. Because the index HTML is your entry point. It will pull in all the resources with its file name. And that means whenever a file changes, the file name changes now. And the index HTML will pull all in these resources. And the resources that haven't changed will still be in cache and can load much faster from the local cache. There's actually a gulp plugin that does this for you. It basically goes to your files and renames them, adds the cache, the hash to the file name. And gives you a translation manifest that can be consumed by additional plugins that you can find in the README of this plugin, of this gulp plugin, to rewrite your HTML files or your JavaScript files to use the hashed versions of these files. And now let's get to the highlight. Let's talk about HTTP 2. HTTP 2 is, as the name suggests, the successor of HTTP 1. And HTTP 2 was based on Speedy, an experiment by the Chrome engineers. And this picture has been passed around a lot on Twitter, saying a picture says more than 1,000 words. I personally think that picture only says more if you already know what HTTP 2 is about. So I will give you a very quick overview on HTTP 2. The biggest improvement is probably that instead of using 6 connections, HTTP 2 only uses 1 connection. And that sounds very bad at first, but let me explain. Basically, what used to be a connection in HTTP 1 is now considered a stream in HTTP 2, and all streams share that single connection. A stream is broken up into frames, and when a stream is done putting its frame onto the connection, because it's blocked, or it has to wait, or it is just done, then another stream can take over. So this one connection will always be fully utilized. The problem that we had before, where you send out a request and have to wait until the response came back, is called head-of-line blocking, because one request blocks the head of the line of the rest of the requests that are waiting for being sent. So yeah, as I said, most streams can be, the streams can utilize the connection very well. And that alone is a huge improvement. When you have a lot of small assets and therefore a lot of requests, HTTP1 becomes unbearably slow, which is why concatenation and spriting is a thing right now. You pack up multiple assets into one big asset, which you can get with a single request, and unpack them on the client side because that is more efficient in HTTP1. So I made this website where I split up an image into multiple tiles, basically artificially blowing up the number of requests I need to show this tile image. I just included it with simple image tags, and then loaded this website over HTTP1 and HTTP2. I'll let you guess which one is which. HTTP1, as I said earlier, heavily multiplies the impact of the round-time trip, while HTTP2 does not. This is an emulated 3G connection, and even then, HTTP2 seems to load instantaneously. The second big improvement of HTTP2 is that we have frames, and these frames are used to distinguish between header data and actual payload data. That is really important for us because, amongst other things, we can now finally compress headers. In HTTP1, if you enable compression, only the payload will be compressed, the actual body. In HTTP2, we can now compress headers. And actually, the engineers went a step further and came up with their very own compression specifically crafted for HTTP2. The compression works on a per-connection basis, means that all the streams share the compressor. And that is really, really handy because that means if the compressor realizes it has sent a header before, it will not resend the header, but just says same header as before. So some headers that never change, like host or accept or cookies, will not get resent. And that will save a lot of bytes. And not just bytes, for most websites, it will save hundreds of kilobytes on average. But most importantly, in case you're scared, HTTP2 is backwards compatible to HTTP1. That means if a browser doesn't support HTTP2, which it really, there should be no browsers out there really at this point, it can fall back to HTTP1. And the semantics stay exactly the same too. You still have request response, you still have a header section and a data section, you still have the same methods, the same verbs. The bottom line is, just by switching to HTTP2 right now, you can reap most of the performance benefits without doing anything. However, there's additional features in HTTP2, like push, that do require you to do a little bit of work on the back end, but might very well be worth it. Push is a technology in HTTP2 that allows you to respond to a request that hasn't even been sent yet. And what I mean is, I guess the best example is just your index HTML. Somebody requests your index HTML, you respond to it, but you know that in 99% of the time, they also want the main style sheet and your JavaScript, so you just send that along with it. And the browser will already have it in its local cache when it realizes that it now needs those files. You basically reduce the round-trip trip to 0 milliseconds, which is amazing. Of course, pushing everything is also not the optimum for the best possible performance or the best possible experience for the user. And since browsers now actually have good support for push, we thought it was a good time to look at how to use it right. And the Polymer team actually came up with the pattern that is called PRPL. It is an acronym, because yay, more acronyms, that allows you to, that guides you towards being interactive as soon as possible. But the first step is pushing the resource that you need for first render. Pushing or use inlining when you don't want to use, or when you can't use HTTP2. You have that all in the first request, so they can get on the screen as fast as possible with a response to the first request. And you have the first two steps already done. The next step is preloading the things that are very likely for the user to do next. So for example, if you know it is very likely for my user to open up the sidebar, load the JavaScript and the styles for the sidebar and have those ready for when the user actually starts interacting with your page. Or if a navigation is most likely, note the next view or the next route, whatever is appropriate in the context of your app. And everything else should be lazy loaded on demand. There's a talk by Kevin Schaff from the Polymer team from I/O that I'll link to at the bottom, which goes into more detail on the whole topic. If you want to play around with HTTP locally, I wrote a tiny tool, which is just like Python's simple HTTP server, but uses HTTP2 and also has support for push. I wrote it in Go, so there's binaries for macOS, Windows, and Linux alike in the release section. This tool also takes care of generating a certificate for you, because for HTTP2 you always need a TLS certificate, but it is taken care of in this tool for you. And all the details you need are in the README in the repository, so go there if you want to play around with it. And this is all I have for you today. Here's a little bit of a summary of the things we talked about. It was quite a lot. If you have questions about this, or you want to know more details, I'll probably be in the CodeLab area today or be in the office hours tomorrow. And next up, we have Owen, who is going to talk to you about push. Thank you very much.
Hi, my name's Owen, and I'm a product manager on Chrome's push notifications. So just before we get started, I feel like now would be a good time to clarify that we actually have two new features in browsers, both with the name push. I think it said that there are three hard problems in computer science. Two hard problems in computer science: caching, naming things, and off-by-one errors. And so I think we've fallen into the naming things trap here. So there's HTTP2 push, which allows servers to send down data to the client before they even expect it when rendering a page. And then we have web push notifications, which are about sending notifications to our users. And that's what we'll be focusing on today. So I'm super excited that we're all here in this room full of amazing web developers, and I think at last count, 5 different browser vendor teams to talk about progressive web apps. These are web apps that are reliable, fast, and engaging. And I'm going to be focusing on the third point today, engaging, specifically sending push notifications to your users. So push notifications on mobile aren't anything new, but I'm really excited that we finally have access to these as web developers. I'm sure there are a number of you out there that have built great mobile web experiences and then had to wrap it in some kind of Cordova wrapper and suffer the friction of an app store just so you can get that notification capability. So our shackles are now free. We can now go ahead and do this. I think that's really exciting, especially when you look at the services and apps that have been successful on mobile, and just look at the top ones and think about how many of them are fundamentally successful in part because of push notifications. And we now have the ability to take advantage of that in the web. And so there's a bunch of new opportunities that have emerged here that I'm excited about. And this can be really huge for business as well. For example, if we take a look at Jumia, which is a leading e-commerce company in Africa, they had a problem. And their problem was that 1/4 of their users were adding items to their cart, but then not actually checking out. They were abandoning that cart. And the site tried to deal with this by sending those users emails and reminding them. But getting a user to type that email in on a tiny screen is really difficult. And then the open rates on those emails were extremely low. So it's still early days, but Jumia have implemented push notifications on the mobile web, and they found that their notifications get a 38% open rate by users. And that users that have enabled web push notifications convert on those previously abandoned carts at a 9 times higher rate. And so I think these kind of results are really exciting. OK, so push notifications is this amazing new superpower that we have on the web. But everybody knows that with great power comes great responsibility. So this begs the question, what makes a great engaging notification? And so we believe that great notifications are timely, they're relevant, and they're precise. And so for these penguins here, a push notification letting them know that there's a leopard seal behind them would really change the course of their day. And so as you're designing your push notifications flows, just think about whether what you're sending is important enough to warrant an interruption. Would you want to be walking down the street and feel your pocket vibrate? And really use that to guide you. And so let's break this down further. I said notifications work great when they're timely. So try and use notifications primarily for time-sensitive events, especially if these are synchronous events that involve another user. For example, being sent a chat message. There's another person out there waiting for you to respond, and it's something that you care about, and it's important that you see it within the right time. So that's a great use case. Calendars is another fantastic use case. You're about to be having a meeting, and you need to know where you're going and be reminded to go there. So timely is really key. Secondly, being precise. Notifications should contain all of the information that a user needs to understand what just happened and to take action on it if possible. And thirdly, relevant. It's important to users that the notifications they're seeing are from people that they care about and about things that they care about. OK, so let's give this a go. Here's one example notification. What do we think about this? I think this is pretty good, right? It's timely. I'm probably at the airport and I'm about to get on a plane. It's precise. It tells me my flight number. It tells me when the flight has been rescheduled to. And it's relevant. It's my plane. It's my flight. It's super important to me. So I think that's great. How about this one? Your credit card has been compromised. Well, I think this could have done better. B- on our scale. So it's timely, it probably just happened, and it's relevant, right? It's my credit card. But it's not very precise. Which credit card? Why was it compromised? What's going on? What action do I take? And so if we reimagine this notification, we can add some extra information, let the user know that a suspicious transaction has occurred, and give them buttons that let them take action and provide feedback to the bank. OK, how about this one? Awesome chat app. You have a new message. So awesome chat app, your notifications are not so awesome. It's probably timely. I expect a message was sent to me, but it's certainly not precise. And who can say if it's relevant, right? Who knows? So we redesign this, and we get Jake says, I heart service workers. Instantly, I think there should be an award for getting his profile picture in the most number of talks today. I think he's maybe at 3 or 4 so far. So that's a great way to redesign this. How about this one? As a side note, I think if Google does launch a self-driving car service, we should definitely call it Goober. And so this one is great. It's timely. My car is arriving. It's precise. It's telling me where it's arriving at. And it's relevant. It's my car. I'm going to get in and drive away. And then here's probably the worst possible example I could conceive of. This is none of the above. And the risk here really is that if you send notifications to your users that don't provide them value, that distract them or spam them, they're going to turn off notifications, and then you're going to lose the ability to get the value from that interaction in the future. OK, so we've talked a bit about the kind of notifications which are good for our users. So now let's take a look at the flow and really how this works on a high level. So push notifications on the web is built on service workers. This is probably a theme that you're seeing emerging throughout the day. And I think it talks to how service workers are becoming this fundamental capability that are allowing us to extend the platform in all these new and interesting ways. And so once you get everything set up, which we'll go into, sending a push notification, the flow is roughly that your site first makes a network request to a push server, a push subscription endpoint. And that's managed by the push server, which then magically wakes up the user's device and manages to fire an event into their service worker. And then that service worker runs some code, and it uses the notifications API to show a notification to the user. So let's break that down a little more. The first thing that happens when a user lands on your site is you have to check if the user's already subscribed, so you know whether to show them the opt-in flow. Once you've checked, if they haven't already opted in, you just wait until it's a good time. Maybe the user has just done a search for flights, and you give them a button that says, get notified when the price drops. And then once the good time comes, you ask the user to subscribe. You explain the feature to the user that they're opting into, and then you eventually show them the permission request. And then once you've subscribed the client, it generates a subscription object. You'll then pass that subscription object up to your server and save it somewhere in a database. And then on your server, when you're ready to send a message, you just generate the message, you send that message to the endpoint that you were given previously, and that endpoint, essentially the push servers keep one persistent connection open with the device, and then they use that connection to tell the device to wake up the browser, wake up the service worker. And so this part is special because it means that we're sending push notifications, but the browser doesn't even have to be running on the device. The site doesn't still have to be open. It doesn't use much power, and so it's a really great performance feature as well. And then the push message is received by the browser. And when the push arrives in the browser, it wakes up the service worker and fires an event into it. Your code then handles that event and decides what to do and shows a notification to your user. Easy, right? OK, So now let's take a look at subscribing for push and when you should prompt your users to opt in to get push notifications. So I think that this step is super important because if you're going to be successful with push notifications, you have to get users to turn them on in the first place. And so it's really important to focus on this step in the process. And I think it's important to be clear and intentional and treat this like any other part of your UX process. The key is not to just add a permission prompt on page load without thinking about it. So make sure that the user understands why they're being asked, make sure that they understand what they're opting into. And so we'll take a look at an example of the weather channel. So the weather channel have built this page where you can choose to enable push notifications and control some options. So I think this is great because it's specific. You know, you have this page where you know what's going on, you have all of the context that you need, and the permission request itself is user initiated. So when the user goes ahead and checks that box saying activate browser notifications, they see a permission request. No surprises, right? They're very likely to click through at that point. So that's great. And we think it's really nice how they give users options. I can opt into breaking news or government-issued alerts. If you're never sure about what users are going to want to enable, just give them options and let them decide. OK, so we've talked about this on a high level, and we've talked about UX. Let's take a look at the code and how we actually subscribe for push notifications. So the first thing I said that we do is we check whether the user's already subscribed. And because these are progressive web apps, the first thing that we do is verify that service workers are available on this client. If the service worker is available, we go ahead and register our service worker. If a service worker is already registered, this will just return with the registration object of that service worker. And then we can call pushmanager.getSubscription to get a push, the existing push subscription for the user if one exists. And so now we know whether they're subscribed or not. We can store this in a cookie, use it later, or use this to decide whether to show them an opt-in flow. OK, now we're deciding to subscribe the user for the first time. So again, we're going to get the registration of the service worker that we've registered, and then we call pushmanager.subscribe. Essentially, this is setting up that connection with the push server, so it knows how to talk to this client. It knows that this service worker wants to be able to be woken up. And then there's an option here which says user visible only true. Essentially, what we're saying here is we're promising to the browser that when we send a push message down to the device and our service worker runs in the background, that the user will see something. So we'll either show them a notification, or maybe if they're already looking at the web app, then we don't need to do that. And the idea here is making sure that browsers can show that permission request saying this site wants to send you notifications, not this site wants to run in the background permanently on your device silently and use all of your battery. So that's why that exists. And then once you've subscribed, actually when you call subscribe, that will be the point where that permission request is shown to the user. And if they accept that request, the promise resolves, and we get back a subscription object, which we can then send to the server. And of course, we catch the case where they deny, and we can decide what to show them in that case. So I recommend you all check out the Propel sample code up on the Google Chrome section of GitHub. And this shows some great sample code to manage those subscription states, gives you a really nice API to manage them. OK, so next, once we've subscribed, I said you get that subscription object. What is that? What does that look like? So this is how it looks. It essentially gives you all of the information that you need to identify the user to the push server so it can wake up the right device. It starts with an endpoint. This is like a magic URL. It acts kind of like the user's phone number or email address, but for push notifications as a way of identifying and reaching out to them. It starts with the URL of the push service that this operating system uses, in our case here, Google Cloud Messaging. And then it has a long string of random letters that identify the current user to that push service. It also includes a bunch of encryption keys. And this is so when you're sending data down to the user's device, so you know what notification to show, that message can be encrypted and can't be read by anyone in the middle. OK, so let's take a look at sending that message from the server. There are two ways that you can send a notification. Firstly, there's what we call a tickle. This is essentially a push message which arrives with no data. So the service worker gets an event that says a push message arrived, but it doesn't get to find out what happened. And the second kind is push with payload. This is where you include data, you let it know what happened on the server and why it's being woken up. And if you're sending payload, it's encrypted with the keys that we talked about earlier. And so let's take a look at actually sending those. Just before I do, it's worth calling out that the sample code I show here is for using the web push protocol. So the web push protocol is about to start working around now in Chrome, but as the standard's been evolving and the implementation has been evolving, it hasn't been the exact same implementation in older versions of Chrome. So there'll be a link at the end which shows you how to do a backwards compatible implementation. But I'm going to focus on the future-facing and what's really going to be happening from now. So when your server wants to send a push message to the user, it sends a request, which looks roughly like this. It's a put request to that endpoint we were given earlier. It has a time to live, which essentially tells the push server how long should you keep trying to send this to the device for, and give up if it's taken more than 2 minutes. It includes a content type and encoding, and then it includes the public key and salt used to encrypt the message, a vapid signature, and the encrypted payload. I'm not going to go too much into the details on those last encryption aspects now, but again, there'll be a link at the end which gives you the full breakdown of how this works. And at this URL, you can find sample projects to handle the encryption and message sending on the server side. We have them in Java, in Node.js, in Python. So go and take a look. This is kind of contributed by the open source community. There are contributions also from Mozilla and from Google, and they're a really great set of libraries that will get you up and running. OK, so now we've worked out how to subscribe the user and send a push message. But how do we receive it on the client? What does the service worker do? So in your service worker, you just add a new event listener for a push event. When that event fires, you call this magic method called wait until. So wait until, I had to look at this a couple times the first times I was trying this. Wait until essentially says, I'm going to run some code for a while. It's kind of asynchronous, and I'll let you, the browser, know when I'm done. And when I'm done, you can go ahead and kill my service worker. I don't need to be kept running. So this allows us to be very performant and efficient. And you basically pass into wait until a promise, and you resolve that promise when you're finished doing the work, when you've showed the notification. So here we go ahead and we just generate a notification, and this returns that promise that will resolve when it's been shown. So the browser can kill the service worker at the right time. But actually, if you look here, this notification I'm showing basically breaks all the rules we talked about earlier, right? It's static. It doesn't say anything useful. So how do we read the payload? How do we know what was supposed to be showing the user? It's pretty simple. So you just check if event.data exists. If it does, you call .json to convert it into a JavaScript object. If it doesn't exist, then that's the point where you'll want to make a fetch request to your server to ask, hey, what happened? What should I be showing the user? And then once you have that data, you again just call show notification with the correct title and the body. And note in this case that we actually need to return that show notification to the event.waitUntil to make sure that the browser knows that we were still doing work. If you don't do this, you might notice in Chrome that you get a little notification saying, this site updated in the background. That generally happens if you resolve the promise to wait until before you show the notification. Because that's Chrome checking and saying, hey, did you show a notification? Oh, they didn't. We'll show one on their behalf to make sure the user knows. That's the user visible only true thing coming into play. So we also have support for action buttons on web push notifications. These make it easy for users to complete a task without even opening the app. Here we can see that a user can confirm their reservation. You could also use this to have users like or retweet something, to pay a bill, increase their bid on an auction. There's many interesting opportunities there. And using action buttons is super easy. In the show notification call, you just pass in an actions object, and you give the title, the icon, and this action string key thing that we're going to use to recognize when the user taps on one of those buttons. So then if a user does tap on a button or on the notification, a notification click event will be fired. And that's where we'll say, hey, if the action was like, then we'll reach out to the server and let it know that it was liked. And if there's no action, then we know that they just tapped on the notification. In this case, we're just going to open a new tab to the notifications page on the server. OK, so we're almost there. We're just going to wrap up now. And I don't think that we can do this talk without talking about browser support. So it's worth noting that web push notifications are already supported today in Chrome and Firefox. I was excited to see that Opera shipped web push notifications last week. Samsung browser shipped web push notifications earlier in their browser 4.0. And I read last week that the Edge team have just announced that they're currently implementing push notifications on the web. And at this point, you might be looking at that and saying, that looks great, but there's maybe one missing that we care about. What do we do? And I think that there's a big takeaway here, which is that progressive web apps are fundamentally progressive. So when you invest in your web experience, you make the experience better for your users everywhere. And if you use progressive web app features, in the browsers that support those features, it's going to be even more awesome. And this actually turns out to be true when you look at the data. Earlier this year, AliExpress, a very big e-commerce company, rebuilt their site as a progressive web app. And in Safari, they saw an 82% increase in conversions on average. And that's a browser that doesn't currently support service workers and these new features. But I think it just goes to show that there's a huge opportunity in investing in the mobile web. And if you build a great progressive web app like they did, you can get that value across all of the browsers and even more value in the browsers that support these features. OK, so we're going to build better engagement on the web using web push notifications. We're going to send notifications that are timely, precise, and relevant. Just think about these things and ask yourself, would I want to receive this notification? Are my users going to be delighted by this experience? We should make sure to ask for permission in context, so the user knows what they're signing up to, and they're likely to click through because they see the value proposition in what you're giving them. And be awesome. We have these new amazing superpowers. Use them to build awesome, amazing new experiences for your users that you're going to love, your company's going to love, and that they're going to love. And with that, I'm going to leave you with a few links where you can read more about this. We have a guide for getting started with push notifications, and then some details about the encryption aspects. Tomorrow, we'll have some codelabs where we'll go through some of this stuff. And coming soon on Udacity, there'll be a course there, so you can learn about that if you're watching from home. So thank you very much. And I'm actually really excited to be the person that gets to tell you that it is now lunchtime. So you can go around and back. There'll be lunch also up on the mezzanine level. And we'll be starting back. The next talk will start at 2 o'clock. So make sure that you're in here at about 1:50 so you can be ready on time. Thank you.
When you're building an app that needs to store and share data from a server, there are a lot of things that you'll need to keep in mind. Setting up and maintaining a database can be a hassle. And if you want your data synchronized in real time or need offline support, well, now you're talking some serious time commitment. But with the Firebase Real-Time Database, you can get that time back. The Firebase Real-Time Database lets you store and sync data between your users in real time. This makes it easy for your users to access their data from any device, web or mobile, and it helps your users collaborate with one another. Whenever you update data in the real-time database, it stores the data in the cloud and simultaneously notifies all interested devices in milliseconds. The real-time database is also optimized for offline use. Whenever a user loses their connection, the database SDK uses a local cache on the device to serve and store changes. This means that when the user comes back online, their local data is automatically synchronized. And how do you keep your data secure? You can use database security rules to specify who has access to what pieces of data and how your database should be structured. The security rules are securely stored with the real-time database on our servers. So, if you want to make sure your users can only access their own data, or ensure that their message is no more than 141 characters, you can do that in just a few lines of code. Getting started only takes a few minutes. The Firebase real-time database is hosted for you in the cloud, so there's no server maintenance or operations. And there are SDKs for Android, iOS, and JavaScript. To get started with the real-time database, check out our Quick Start, which will get you up and running in minutes. We can't wait to see what you'll build with Firebase.
Hey there, Polycasters. Rob here. Welcome back to the show. So it's been a little while since we last talked. In the previous episode, we started off a series using Carbon Route to build an application. And actually, since we did that episode, the Polymer team has renamed that element to App Route. So we're going to be picking up where we left off last time. This time, they will be using App Route to continue working on our blog. And what we're going to do is we're going to make sure that we can lazy load content on this blog. And we can also manage the flash of unstyled content that we see when we switch between pages on a slower connection. So to grok what I'm talking about here, let's switch over to the laptop. And you'll see that I've got the blog, as we left it last time, showing here. And I'm going to just go over to the network panel. And I will click this tab right here. And this will let me actually throttle my connection down. Let me zoom in on this a little bit so it's easier to see. So I'll go to the network tab. I will go over to right over here where it says throttling. And we can set our connection to something like regular 3G. So this is what someone on a typical cell phone connection is going to experience when they're trying to use our site. So maybe I go and I click on the film section. And maybe I go and click on one of these posts. And then I go back to the art section. And did you see how there was kind of like a moment where we saw a flash of the old film section when we switched to the art section? That's kind of the thing that I want to address today. I want to deal with that flash of unstyled content. Make sure that when our users are using our application, the only thing that they're seeing is kind of the relevant page and something that's really fresh and up to date. So to do that, we're going to switch over to our code editor. And this is where we left the project last time. And I've already gone ahead and renamed and downloaded our app route, renamed it throughout our project. So we don't have to do anything there. Any place you see Carbon Route in the old project, we can just update that to app route. The API and everything is still essentially the same, just kind of a small name change. So thankfully, we don't have to do a lot of work there. Now, one thing that we do need to do, which I noticed in the previous episode, is I made a little mistake in this blog app element. So if you see down here, when we set up our iron selector menu, in the previous episode, I was passing category data as this two-way binding like this. And while this is cool and this approach did actually work, what was happening was it was creating this weird situation where when you clicked on this binding, because it was a two-way binding, what happened was first it would look down at this data page element and it would say, oh, you're trying to go to the film section. So I'm just going to update carbon location to /film. Then it would see that, well, actually, we clicked on an anchor, so we want to go to /film/list. And it would say, OK, cool. Well, I'll update it to /film/list. Now, what would happen then is we would change the URL twice really, really fast, so fast that no one would notice it if they were just looking at the site. But if you hit the back button, it would go back to /film. We don't actually have a film page, so everything would just break. So the fix there is pretty simple. What we want to do is we just want to change this to a one-way binding. So basically, the menu always gets its information passed down to it from carbon location. And if you click an anchor or something, it'll dispatch that event. That'll go back up through carbon location back down to our elements. So it's this nice one-way loop, and that solves that bug. Now, the next thing we want to do is we want to tackle that funky, weird flash of unstyled content. And there's two things that are going on here. The first is I'm loading new JSON for the page, so our text is going to swap. And the second is we're loading new paths for our images. And those actually have to go out and fetch the images and sort of re-download them. So I want to tackle each of these problems individually. I'll start with what to do so we don't display kind of like stale or outdated text. And my thinking here is I'm probably going to display like an overlay over the screen with like a little spinner. So that way, the user doesn't see like a weird swaparoo with our headings. They just see a spinner page. And then when that content's finally ready, it just sort of reveals the new heading and the new paragraph content. So to do that, I'll go over to this blog pages element. And I'm just going to go ahead and drop in a div. I'm going to call this overlay. And inside of here, I will drop in a paper spinner. And I'll just leave it with this, this active attribute. And I need to go up to the top and make sure that I have imported paper spinner. OK, so far so good there. And then I'm going to go to my overlay. And I want to give it some CSS style so it's actually like full screen. So I'm going to drop in a little bit of CSS. I've already got the CSS saved because I'm totally cheating here. And I'm going to boost this up a little bit so you can read it a bit easier. OK, so here I'm positioning the overlay so it's absolute. Top, left, right, and bottom are all 0. So it's actually going to stretch to fill the entire screen. I'm setting it to display flex and setting flex direction to column and align items and justify content to center, center. And that basically means that paper spinner child that I added there is just going to be vertically and horizontally centered right in the middle of the screen. And finally, I'll set the background to an opaque white so it hides whatever page content is behind it. So we can actually just verify that this is working. I can go back over to the blog that I was working on. I can probably go ahead and close the DevTools and refresh the page. All right, so now we're just seeing that overlay and that spinner. It's blocking all of the page content. So I at least know that that is working. But I only want this to display when we have a page that is kind of in a loading state. So what I'll do next is I'll go into my list page element. And remember, list page is the one that lists all of our individual blog posts. I'm going to give it a loading property. So down here in its properties, we have active for when the page gets swapped to by our route. But it could still be in a loading state then. So we'll add a loading property. This is also going to be a Boolean. The value is going to default to false. And I'm going to set it to notify true because I'm going to need to have the outside world listen to this as well. So next, I'll go up to my Iron Ajax element. Now, this is the one that's sort of loading all of our blog post data for this page. And it actually has already inside of it, Iron Ajax has a loading property. So here I can just bind my loading property to its loading property. Right? So that's pretty nice. So now this page can kind of tell the outside world when it's loading. And really what it's doing is it's just sort of telling the outside world when Iron Ajax is loading. So back in blog pages, which is sort of the common parent of all these guys, I will add a property or an attribute here. So I'll listen for this dude's loading property. And I'm going to call my attribute, just so I can differentiate them a little bit, I'll call it like is loading. Right? So I can do that here. Now down in my overlay, what I'm going to do is I'm going to bind the state of the overlay to that loading property. So we'll say, OK, we'll use the HTML hidden attribute. I'll use the $sign binding so I can bind right to the attribute itself. And we'll say that this is one of those fun double negative things. So we'll say when isLoading is false, hidden should be true. Yes. OK, so when isLoading is false, hide the overlay. When we are not loading, hide the overlay. OK, this is one of those like things where you got to think about it for a second. And then the active state of our spinner, we're actually going to do the reverse. We're going to say, OK, well, if it's loading, then we do want the spinner to be active. OK, so that means now as we switch back and forth between the list page, we should see that overlay for just a second. And when all that content comes in from Iron Ajax, it should hide itself. I'm going to go ahead and actually do the exact same thing for my post page. So I'll give it a loading property as well. Right, it's Boolean, defaults to false, and we want to notify true, so we can bind to it. And we will also bind it to the loading property of Iron Ajax. And now I can sort of duplicate that work that we did for list pages over in post page. And at this point, you might be saying, these pages, the sort of the signature of them is looking very, very similar in our markup. So it might be a good time to consider perhaps rolling some of this common behavior into behavior, I should say. So actually sharing that functionality between the elements instead of duplicating the code in both places. So that's something that we might do in a future episode just to kind of like tidy things up a bit. But for now, let's just verify that this works. So I'm going to switch back over to my browser. I will refresh the page, zoom out a little bit because we're pretty zoomed in there. And what I can do is, because this content's going to load in really fast because I have it local, I'll go back to my network panel and I'll throttle the connection way down. So I'm going to set it to GPRS. And now when I click on film, I should see that loading state for just a second. Now you notice that my image still did that weird swaparoo thing, but we're not seeing any stale text when we go and click on these items. One thing that does happen, though, when we switch between these is we can actually still scroll the page while that overlay is displayed, and that's kind of a bummer. We definitely don't want that. So I'm going to add one more little trick to blog pages. I'm going to add an observer for isLoading. So my observers array, let's get some more space down here. So I'll create an observer for, we'll say we're going to lock scroll whenever isLoading changes. And lock scroll will just be a method that I define where we say, all right, what is the state of isLoading? And if isLoading is true, then we're going to cheat here. We'll reach outside of ourselves. We'll go to document.body and set the overflow style to hidden if isLoading is true. And what that's going to do is that's just going to like chop off the page, and that way the user won't be able to scroll and see that content underneath there. Otherwise, if isLoading is false, then we'll set document body style overflow to visible, I think is the correct value. We'll double check. And then swap back over and bust out our dev tools so we can throttle this thing again. So refresh the page. All right, so far so good. We'll go to our network panel. We'll set throttling to GPRS. And now we'll click on like the film section. And you notice my scroll bar even like goes away. So I can tell I can't scroll or anything until that content actually has loaded in. OK, cool. So we handled the issue of the text being stale and that loading in. But now we still have these images. And this is a really tricky problem because when our data loads, all it's loading is a path to a new image, but we still have to go make that HTTP request to fetch that content. And that could take a super long time to load. But I don't want my user to, be waiting when they could be reading the text of the article while they still wait on that image to load. So we could kind of do a little trade-off there where we give them the text of the article, but maybe we serve like a downgraded image so something loads faster, and then we wait and kind of upgrade that image as the nicer version loads in. So let me do that. And this is kind of a cool trick that I discovered recently by looking at a project the Polymer team did called Shop, which you can find over at shop.polymer-project.org. And if you go to the site, you'll notice that when we first boot up the page, it kind of does this like fade-in effect on this image. You see like a low-res version, right? And then it just kind of fades in. And what the Polymer team is actually doing is they're taking the original image, and then they're downsizing it to 1%. So you get something that's like 200 bytes. And then in CSS, scaling that back up to the full size of the image. And then we're loading the higher res version, and we just crossfade them when the higher res version loads in. So this gives sort of a perceived performance improvement. The user can access our content a lot faster, but they're not waiting around on a super big image. So we can do that with our site. What I'm going to do is over in Finder, I will find the blog that I've been working on here. Blog, vlog, blog. OK, images. And I've already gone ahead and downsampled these images, but I'll walk you through the process of doing it. So we'll take this photo of a lion that we've got. So we've got Photoshop here. We'll drop in this image of a lion. Now this is a really high-res image. It's like 900 by 512, so pretty beefy. And I'm going to go to the image panel property, whatever this thing is called, and set image size to %, and we'll set it to 1%. So that brings it down to 9 by 5 pixels. And if we super zoom in, you can see this thing is just a bunch of random squares now. But it roughly approximates our final image. And then we can export that for web. And I usually use like a medium quality setting. And I'm just going to give it a different name. So I'll call it like picture 1 low res or something. Now, the next thing I'm going to do is take that low res image and base64 encode it into a string. So that way I can load that string along with all of the text content for my article. Now there's a number of ways that you can base64 encode an image. You can do it from the command line, I believe with the base64 command in Unix. Or there's a bunch of websites out there where you just look up base64 image and you can upload an image and it'll give you back a big string of text. And that's one technique that I used in this case because I'm lazy. So I've already gone ahead. I've base64 encoded all these images. I have all the strings for them. And I'll go over to the data that I'm loading in my application, open up the list page. And along with the title and the slug and the image and the alt tag and everything, I've got this image placeholder value now. And inside of there, I just have this humongous base64 encoded string. Well, it's not that humongous. It's like 200, 300 bytes or something, which is really actually quite tiny. And this is what I'm going to actually load into my application. Now, I can't just use a regular image tag to load this thing. I need to use a special element. And the Polymer team has just such an element. So if I go to the Polymer catalog, let's see, Polymer iron image is the name. So we can check this out on the Polymer element catalog. This thing is awesome. And what it'll let us do is load a placeholder while it waits on the higher res version to come down. So I'm going to just grab, let's see, there's a snippet of code here that I want. Here we go. So I'm going to grab the snippet of code. And I can go back to my list page and find this image tag that I was using previously. And I'm just going to replace it with an iron image. So let's see. So we'll set width to 900 pixels, height 512. You could also do this in CSS if you wanted to have like media query breakpoints to change the size of the image. I'm working quick and dirty here, so I'll just do it inline. For the placeholder, right, if you go back and you look at our data, we called that value image placeholder. So I'll grab that. We can use that in our binding, right? So image or item, because we're in a DOM repeat, item image placeholder. Size and cover. Yep, that looks good. I totally want to do that. Preload. There's a fade effect that iron image gives us. If we go and look at their docs, this is kind of a nice thing. So there's a fade attribute we can set on this guy. So I'll say preload fade. The source is going to be item.image. And then we can add an alt attribute too, which is important for accessibility. So we'll say alt equals, I believe it is item.image_alt. OK, so this is going to go out. It's going to quickly display a placeholder and then fetch the higher res version and fade that up when it is loaded. I'm also going to add the same chunk of code over to our, what is it? Our post page. So our post page, we got an image here, right? Replace that with iron images. And here we called it post content. So I just need to update, wherever it says item to post content. Hide that old image. OK, let's give it a shot. So I've turned off throttling. I'm going to refresh the page. And you'll actually even see, even though we're on a fast connection, we'll actually see some of that crossfade happening because it's able to load that placeholder super, super, super fast because it's so tiny. But this makes a huge difference if you're on a slower connection. So again, we'll go to the network. Let's turn throttling on now. So we'll set it to like regular 3G. OK. And now let's switch to a different page. So we'll go from art to film. OK, cool. So we didn't see any stale images. And we were able to get that kind of nice fade-in effect while we were waiting on these other images to load. I mean, if we go to a really slow connection, like GPRS here, what you'll see is as I go and maybe click on one of these posts, we see the spinner for just a second. Then we see the page content, though, and then that image fades up. And this is really, really nice. Let's actually do like a super hard refresh to clear our cache so you can really see this in action. OK, so let's say I hit this page for the very first time. I'm going to switch it to GPRS. So now I'm like super, super, super slow phone. I'm going to switch to the film section. And my text loads in super quick, right? And these images, they're kind of like rolling in along after it. But I don't have to wait for those images to be able to actually start reading the page and interacting with the page content. So the final product is just super, super nice. And it's very, very responsive and very friendly to folks who might be on slower cell connections. OK, so that about covers it for today. We've built an amazing site that is super quick on mobile using some of the fancier new app routing and iron image trickery that the Polymer team has given us. Now, if you haven't done so, please go check out some of the talks that the Polymer team recorded at I/O. These are all up and available on the Chrome Developers YouTube channel. And if you have any questions for me, you can leave them in the comments down below, or you can always hit me up on a social network of your choosing at #AskPolymer. As always, thank you so much for watching, and I'll see you next time.
So Matt, what's the one feature that keeps you coming back to native apps?
Probably offline support. It's that whole thing of you're going to be somewhere with flaky network and you just want it to work.
Yeah.
That's probably it.
So offline's probably the one thing that keeps me going back to native apps as well. Now, like, there's a bunch of apps that I need offline support in, like newsreaders and things like that. But there's probably, I don't know, kids today use a ton of apps that I don't, like dating apps. Back in my day, you had to run through the city with like a megaphone screaming, "Why does no one want me?"
You're probably doing it wrong. I'm just going to say.
Probably am. So offline, user goes to your web page. They probably are going to run into a situation where they have a flaky network. Maybe they're on the train. Maybe they're at a conference or in a hotel.
Yep.
Right. Now, in the past, we've had capabilities like app cache, which weren't really that reliable and sort of a nightmare.
Yeah, no one
debug.
really used it, and there's that classic Jake blog post.
App cache is a douchebag.
Yeah.
These days, we're in a slightly better position. We've got new APIs like Service Worker. Now, Service Worker is like a script that's run by your browser in the background, and it opens up the door to lots of new capabilities.
Yeah,
right?
so there's push, there's offline support, there's background sync.
And there's like a whole host of other features coming down the pipeline.
Yeah.
But it's like this really nice low-level API that lets you intercept network requests and just take control of what's going on with caching.
Yeah,
Super
so
nice.
you've got your web page, Service Worker in the middle before it gets to the network, so it can kind of manipulate and basically outgoing traffic or just keep stuff from going to the network and just return from like a cache.
So the first step to getting your app working with Service Worker is to register a Service Worker script that allows sort of background functionality without the web page necessarily having to be open.
Yeah, you're just making the browser aware that this is my special Service Worker JavaScript file.
How about we take a look at some code?
So the first thing you're always going to want to do is just check whether Service Worker is actually supported. So if Service Worker Navigator, assuming it is, you then just call navigator.serviceworker.register and you pass in the path of your Service Worker file. And here we're just using promises, so then in cache to just say whether it worked or not. And that's literally it. And the important thing to point out here is it's a progressive enhancement, right? So if you're in a browser that doesn't support Service Worker, that never gets called. You're just in exactly the same land as you would have been without Service Worker.
Right, so you get your same non-offline experience without Service Worker. What about what's inside the Service Worker script?
So the minute that kicks off, what the browser will do is it will just go and grab a Service Worker file and then just start running it in the background of the page. So in this case, the first thing you're going to want to do is manage the install event. So in this case, self.addEventListener. So you're just saying in this Service Worker, add this event. And you want to open up a cache. So caches.open, you give it some name. That's kind of important because over time you're going to add a different version or a different name.
Right, so that's your namespace, right?
Yep. And once you've got your cache object, you just call cache.addAll. This is a super helpful little method because you literally pass in an array of paths. And everything inside that array, it will just go and fetch from the network and cache.
So here you're interacting with the cache API.
Yes. Right? So that's different from the HTTP cache. This is a cache that you control. So nothing will get deleted or replaced or added to it unless you explicitly do it. But yeah, so the only real caveat to all of this is in the cache.addAll, if you add in like some random file that your server like errors out on and returns an error code, that will make the install event fail. The install event fails, that means the Service Worker won't install, which means the web page will never use it. It's kind of just a safety mechanism. If something bad happens in the install event, Service Worker just won't affect your page whatsoever. It will retry, but it won't actually affect the page. So that's the install event. That won't actually give you offline support because it's not actually getting used. Nothing's saying use this, use the cache to respond to a network. That's why you've got the fetch event. Ta-da!
Now fetch is using the new fetch API, right?
In this example we are, but it's slightly unfortunate the fact there's the fetch event and then there's the fetch API because of obviously the name is exactly the same. They are slightly different. So the fetch event will fire, and basically this will happen whenever a page that's controlled by a Service Worker makes a request. So for the page itself, images, styles, anything, it will run through this event. And here what we're saying is caches.match. This is a super helpful little method that just says, for this request, is there anything in the cache that can actually respond with it? So here in the following thing, we say, if there is a response, then just return it. Otherwise, return the fetch. So here, that's where the actual fetch API comes in. And this is basically the same as an XHR. So it'll go off to the network, find it, and return it, and then that'll pump it up to the browser. Those two steps alone will then just give you offline support if you cache everything. ahead
Okay,
of time.
so once you've got all of this set up and you want to test that your service worker setup is working correctly, you've got to dive into DevTools.
Yep.
So serve up your app, check that it works, go to network throttling and just toggle offline.
Doink.
And if you refresh your page.
And yes, we can do the annoying air horn noise.
That doesn't just work like on desktop, right? That should still work on phones as well. So it's the best thing ever.
But yeah, so now you know it works offline, which is super awesome. And this is kind of super high level. There is a much better place to get all of this information in terms of like stepping through Service Worker. It also covers some of the caveats as well as the activate step, which we haven't covered.
Yeah, if you want to learn more, check out the Service Worker offline code lab over on Web Fundamentals.
For too long, users have been left staring at a white screen. For too long, they've been let down by the cruel seas of network connectivity. And for too long, we've been powerless to help. We've been left waiting. But no longer. A new browser feature has arrived. A total game changer. A feature that lets you control the network rather than letting the network control you. Who is this new feature? And what promises does it bring? Introducing the Service Worker.
So my friend's son does this really cute thing where they install games on their phone, and then for weeks after they keep getting notifications saying that their village is under attack. Can you do that on the web?
Now you can.
Now you can. How?
Basically, what happens is you register your Service Worker, you then ask it to subscribe the user to push message. It shows a little dialogue saying, do you want to allow this to happen, yes or no? So hopefully then the kids won't actually enable this at that point. But if they do, then at that point you'll get a special token that is for that user. Send that to your server, keep it. When you want to trigger a push notification, you can then use that endpoint, send it a specific request, and that will basically wake up the Service Worker on that user's device and go, cool, there's a push message, what do you want to do about it? At that point you can just show a notification, you can go back to the server and say, hey, what was this for? You show your notification and then you can respond to click events.
Nice.
So that's literally like the whole end-to-end flow, start to finish.
So can push notifications, with the push API, can they show me like images? Can I include content in there? What can I include?
You can do title text, you can do body text, you can have an image to the side of the notification, and you can also do buttons now as well. So you can actually add like 2 buttons that you can respond to.
So I can show an image saying that showing that my village is on fire, but also a button to
like extinguish the fire.
Fantastic.
Or watch it burn.
Watch it burn.
I don't know what you're into.
It's got very dark very quickly.
It's also interesting because now we're looking at doing native notifications for Mac, which is really nice because it means that we get rid of our own notification like center thing. We're now going back into like native notifications and their trays and whatever else goes with it.
And push notifications are not a Chrome only thing, right?
No, so they're in Chrome and Firefox at the moment. I think other browser vendors, once they start doing Service Worker, they can start looking at it as well.
Sweet.
There is some bad stuff with Chrome in the sense that we use GCM, so we have some proprietary bits.
What's this GCM?
GCM, good point. Google Cloud Messaging.
Okay.
I've been drinking the Kool-Aid for too long. So there's some proprietary bits that you have to do for that. But again, there's new specs that are coming up that will wipe all of that out. So then, because at the moment you have to go into Google Developer Console, you have to register for an API key. All of that's going to go away. So you just have one API, one set way of doing this that all the browser vendors can then take and use.
It's going to be so much better.
If I'm correct, we have a CodeLab on push notifications as well.
Yes.
People can check out.
Which is well worth doing because that one is regularly kept up to date. I think my old blog post at this point has probably seen better days.
So basically you're saying don't visit your blog under any circumstances?
Oh, that's just a blanket rule for all of my content, but yes, that's what I'm saying. But yeah, there is a blog post and it'll step you through all the guides, and it also goes through GCM and how to set all that stuff up. So yeah, go check that out.
Oh, and if someone wants to simulate push notifications, DevTools lets you do this, I think.
Does it?
Yes, it does.
Oh, is that the bell icon?
That's the bell icon.
Yes, and you can do that from Service Worker and Tournaments.
Cool.
Welcome to this Supercharged. Now, normally when we do our videos, we get lots of comments, we get lots of questions on Twitter, loads of things that kind of come into us. And so we thought, why not? Let's actually take a step back and answer some of those questions. How are SVGs rendered? They seem quite slow. Are they GPU accelerated? If so, in what ways?
I have actually no idea.
Cool, I do. So, they're actually DOM elements. They
not only the SVG, but every child is an actual DOM element, right? All the rectangle.
Right. So you've got to be careful because if you move them around, they're going to trigger layout. But the layout operation will stop at the SVG root. It's one of the times we actually have what we call a layout boundary, where the layout actually is not document scoped, it's going to be scoped to the SVG element.
Would you look at that?
Yeah. The other thing is a transform. Normally we promote this thing to its own layer and then transform it around. That doesn't work in SVG context in Chrome. I'm not sure about other browsers, but in Chrome we don't promote anything to its own layer when you actually add will change or translate Z0.
So it's always a repaint?
It's always a repaint, so you got to be cautious with that.
To be fair, I actually expected that for an SVG because I think for some reason I think of it more than canvas-like than anything else.
Right. But hopefully some point that optimization might land. Don't know though. And then are they GPU accelerated? They can be if you've got GPU rasterization switched on. In fact, one of the best ways to improve SVG performance today on mobile is to make sure that you've got GPU rasterization, at least for Chrome. And the way to get that, if you just Google for, I think it is actually Magic Viewport Chromium, possibly. Or I think it's Ganesh or GPU rasterization Chrome. One of those will get you into the world that you need to be in. Next question. Is it possible to disable, I don't know why they put in quotes, but anyway, is it possible to disable web animations on very, 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 very slow devices? It has to be at least 5, and they put 3 tortoise emojis afterwards.
I think I know what that person is getting
They're going for slow, going fully slow devices. I can't think of a way to adapt to your animations, really.
I think what you could do, potentially the performance observer that is in the works at the very least right now could eventually help you do this. My first intuition when I read this question was that maybe you can kind of abuse request idle callback, because that will only be called if your web page is not too busy, and if that is being called, you could use it to enable your web animations. Go the other way around, have them disabled by default, and basically enhance your web page with the animations, provided it is not under too much of a load.
Yeah, but the problem I had with that is that your now main thread so if you're animating with JavaScript, right, all your animations are coming from the main thread, which is fine. So you can then test for main thread availability with request idle callback or request animation frame or both. But if you've got something that's like a CSS animation that is done with, say, a transition, and you're just using the compositor thread and it's just going to keep going even if the main thread is janked up, then you can't use that technique, because it's going to be like, well, I can't do any animations right now. And the problem I have is that even with the frame timing API, it's still only main thread availability. So it's kind of going to benefit anybody who's animating JavaScript, but it's not going to benefit anybody who's animating just purely with, say, CSS or something like that. Overall, though, the thing I wanted to kind of ask myself was, is it the right decision to disable the animations in the first place, right? Because I was like, if your UX can stand not having the animation, it feels like you don't need the animation, right? Animations just shouldn't be for the sake of. Ideally.
Usually they serve a point, and if they don't serve a point, then you might as well skip them because it's about being a little bit mindful about the user's resources.
Right. So I was like, but I get it's a sliding scale, and somebody might be like, hey, it's an added bonus if your device can take it or whatever. As I say, I don't think you can do it reliably today, and I don't know of anything that's like in the works that's just like, this is the cast iron way of saying this device should be good to go. But I think you're right. Request added callback is probably the closest we're going to get. Well, there you go. So those are the questions that you asked, and we would invite you to ask more questions in the comments below. Twitter, I'm at AeroTwist.
At Das Surma.
That's like the Surma, but in German, which I learned. I'd forgotten all my German until
I taught him.
He did. So ask your questions, ping us on Twitter, and we will catch you next time.
So Matt, I'm working on a new web app for lonely people.
Okay, what does it do? What's it called?
It's called Words with Cats. Now, Words with Cats, it's a brilliant name. Now, I want to show an icon on my phone's home screen. Someone launches this, and I also want to be able to show like an icon or some visual in a splash screen.
Of a cat reading a dictionary or something?
A cat reading it. You were a thought leader.
Yes.
How can I get that done?
So Chrome now has the add to home screen stuff. So basically, if you meet a certain set of criteria, when a user is basically engaged into your web app, it will come up with a little banner saying, hey, would you like to add this to home screen? So you basically need to be on HTTPS, you need to have a service worker, and you need a web app manifest. And then after that, it's basically, depending on the user coming back a couple of times, then it will show the banner. So the web app manifest is the main thing that you need to enable all of this, along with the other bits. But the manifest is just a JSON file at that point.
Cool. So it's just a JSON file. Is this a Chrome-only thing?
No, this is all the standard space. So basically, any browser can look for this link rel tag that links to your manifest JSON file. At that point, they can pass it, and it's just going to be, you have to have certain things defined for then browsers to take it all out.
Right. So the manifest lets me customize my icons. What other stuff can I configure in there?
So you can define short name, which will be the text underneath your icon that you'd normally see. Theme color, which Chrome uses as like the URL color along the URL bar. Background color is for the splash screen. So if you have that add to home screen, they click on it, it'll launch. And basically, while Chrome's loading, what you can do is show a splash screen that's like solid color and then have an icon on top of it along with the text. So background color does that. You've got an array of icons. So again, depending on what the browser wants to use the icon for, it will just pick the best size for it. Start URL is super awesome. What that is basically, you remember back in the day we used to have add to home screen in Chrome where it's like hidden in the menu?
Yeah.
So what that would always do is whatever page you are on, that is where you will get pointed to when you click on the icon from the home screen. Start URL lets you define where that is now. So if someone was in the middle of a blog article, clicked on add to home screen, now you can say actually just go to the home of the blog. Then you've got display. Display is basically, rather than launch it in browser mode, you can sit there and say, actually, I want it to go full screen.
Oh, so you can launch it full screen the same way that a native app might look like, right?
Yeah, exactly. But alongside that, there's also in the spec orientation. So you could theoretically lock it to portrait or landscape.
Oh, cool. So for games, that's particularly useful.
Yeah, like if you want to do like forced like thumbsticks. And yeah, the nice thing, especially I was going to say with the start URL, you can actually then add the query parameter. So then you can like track how many people are using it. So like home screen equals true, and then analytics will just show you.
Cool.
So that's pretty much the bulk of it.
Nice. Is there, if I wanted to like validate that I've got a legit manifest, is there a tool I can use for that?
Yes, someone has built a web app manifest validator. I think DevTools were also going to do it so you could like force a download of the manifest and get DevTools to pass it.
I believe we mentioned as much in Totally Tooling Tears.
But I haven't actually used it yet myself. And admittedly, if you don't use something like that, it's kind of hard to figure out whether it's working or not.
Yep.
So those are well worth checking out.
Okay, so we talked about the web app manifest, the manifest validator. So we're checking out. DevTools is looking at it. Are there docs on this available as well?
The best thing to look at is Paul Kinlan's blog post. It covers example manifest, how to add it to the HTML page, and then how to debug it as well. So that's probably the best bet.
Sweet.
And plus it's in Web Starter Kit and a whole other host of the projects that we do.
How are we doing? Are we all good? Hello? Welcome to... Hi! Yeah! Welcome to the fireside chat about progressive web apps. I'm Paul, and this is the panel that we have here. So what I'm going to do first is introduce them, and then I'll just explain what it is we're going to do. So we've got Dion Almayer right here, who's engineering director from WebDevRel. To his left, Jake Archibald, developer advocate. I could be so much ruder, but it's taking so much effort. Immediately to his left, Dmitry Glazkov, who's a software engineer on Chrome. And then it's Alex Komorowski, who is group product manager on Chrome. Who's next? Owen Campbell-Moore. To his left, there we are, yeah. Product manager. Adrian Porterfeld, who's a software engineer on Chrome. And then last but not least, Alex Russell, also a software engineer on Chrome. Now, so we're talking progressive web apps, and if you've got any questions during this, there are microphones to either side. Please do use them. Please come up and ask your questions, but do use the microphones because it means that they get it for the recording, so that'd be great. But we also put out questions onto Twitter and Slack and so forth, and we're going to probably start with some of those. Also on the screen you can see URLs for pinging at Chromium Dev and the Slack and so on. So you can also ask questions during this that way, and they'll make their way to me via the power of Google Docs. Okay, so the first question that we got through, which is going to go to Jake, I think. How should I build a progressive web app when Safari doesn't support service workers?
You should use progressive enhancement. Is that the correct answer? Yes!
I like how you're looking at me like I'm somehow responsible for the question. I mean, this came in, seriously, no, come on.
Yeah, so I think progressive enhancement's the right thing to do here. Like, when you first load a page, even on a browser that supports service worker, that first load is going to happen before the service worker installs and activates. So, you can make a site depend on service worker, but we designed it so you have to jump through hoops in order to do that. And if you do jump through those hoops, I might try and find you and kill you, because I'm a true believer in the whole progressive enhancment thing.
Are you threatening bodily violence on a panel?
No.
Once in a crowd. But so when you start enhancing with service worker and things start loading faster in the browsers that do support service worker, which is at the moment Firefox and Chrome and Opera, then that becomes good evidence for the browsers that don't support service worker to start implementing it or to make their implementation faster. What I'm saying is you have the control here over the future of the extensible web.
But there is a sense in which a lot of the things that people look to from a progressive web app, they do rely on a service worker, right? I mean, this is what people are, it kind of feels like that, right?
Well, we've survived for a long time without service workers, and the web was still usable. So being able to add these features in to get more engagement, I think that's a great thing.
I think, too, that progressive enhancements is so important that we made it part of the name. So that just gives an emphasis on how much we think that's central to the idea. In fact, we just published a case study yesterday. AliExpress, which is a company that is an e-commerce company, they built a progressive web app, and in doing so, they also invested in improving their mobile website. And they actually saw a lift of, I think, 82% in the conversions that they saw on mobile Safari as well. So the idea is that by investing in your mobile website is always a good idea. It just so happens that in browsers that support service workers, that experience will be supercharged. So I think it's really quite compatible, actually.
And we saw this already with things like the Facebook website. Their website has been there for years, and then they've added service worker in as an enhancement, and now you get the push notifications and hopefully soon some kind of offline first experience. And now they're seeing more usage, usage grow because of that. I mean, I don't know the figures there, but I know it's definitely from one user. I use the website rather than the native app now because of that, because it does everything I need it to do.
All right, let's move it on. Oh, this is a good one. How do progressive web apps work with AMP? That'll be, I guess, Alex Russell.
Without which?
With AMP. AMP.
Oh,
with AMP.
Oh,
with
yeah.
AMP.
So for those who haven't seen the sessions, AMP is a web component dialect for making very, very fast loading pages, usually articles, content articles. But AMP has a validator, which means that you can't run your own scripts. You can only run AMP scripts, which is how AMP continues to stay fast. That's why AMP files generally work so well, is that the validator keeps you from running your own or third-party scripts. So this seems incompatible with service workers, which require you to register a service worker. Well, the good news is that the AMP team has built an AMP install service worker element, and that element is something that you can use on your AMP pages. So from there, once you have the service worker installed and running on your site, you can intercept navigations like you normally would to serve up an app shell, and that can be an AMP viewer. So you can keep the same content while upgrading from a relatively bare bones but super lightweight AMP experience on first load to getting that richer, more immersive, more engaging second, third, fourth experience out of the gates very quickly once the service worker is there. And again, it does the progressive enhancement thing because you start with a totally valid, completely workable AMP document, which is a great way to read content. So AMP is the starting point, adding service workers and then layering in your app shell later for custom behavior for richer stuff. Once you know that you've got that cached in the service worker and you don't have to wait on the network to get that more immersive behavior, I think is this golden path. I think that's a great way to go.
In fact, you've got to talk about this tomorrow, right?
I've got a talk that outlines what the Washington Post did tomorrow, and we'll be talking about this extra sort of additional opportunity at the end. Yeah.
Did you guys see the Washington Post progressive web app with AMP demo that was today? Yeah, so I think that really shows off the experience. And, Alex, you talk about how progressive web apps are just, web experiences that take their vitamins. I feel like AMP is like the prescription medicine, where it's like, hey, you guys, you've screwed up for too long. Here's a quick pill that will help you, but you may want to change your lifestyle and take some vitamins.
A little bit of exercise, a little bit of healthy eating, yeah.
Just interesting thing that Washington Post is just the beginning of experimenting of how this stuff fits together, right? I mean, there's more and probably more interesting integrations that you can think of.
Just to follow on, because there is a follow-on question. Again, I guess it go to Alex, but is there a development strategy which allows you to have that one code base that will service both the progressive web app and AMP content? And if, can you reuse code and so forth?
Yeah, I think what I just outlined basically is that strategy, where you catch your navigations in the service worker and serve up an app shell which has that more advanced, more customized, slicker behavior, only for the users who can support it, once you know that it's going to be cheap or free. Right? Only when it's cached locally inside the service worker's caches, and you don't have to go to the network for it. But all those URLs should load nakedly as regular AMP documents, and you can move an entire site to AMP today. Have it on your origin, have it proxied out to the CDNs, have it validate, and that all works thanks to the AMP service worker element.
All right, let's move on. Question sounds deceptively simple. When does my website start becoming a progressive web app? And the context here is, let's say I just add push messaging. Have I got a progressive web app now? Who would like to take that one?
For me, and you can feel free to correct me, it's when Chrome will start offering users to add it to their home screen. So it's a set of requirements there, which is HTTPS. It's having a service worker. I think at the moment it's just having a service worker, but we're going to tighten that to offering some kind of offline capable experience, and having a manifest, so all the icons are in there and it's display standalone. So the user can add it to the home screen and it will look like a native app. And this is why we require an offline capable experience, because we want users to, when they have a home screen icon, and they tap it and it loads within Chrome, we want it to feel native for them. And if the browser has to show a default connection error message, then that breaks the native contract.
The way I think of progressive web apps is actually as a more general concept that you want to reach towards. And just like Ajax, it was like back on desktop web, it wasn't like, when am I Ajax? Like, what does that mean? I mean, you can always be doing more and providing a better experience that's more in line with that golden ideal.
Yeah, and I think when Jake mentioned Chrome there, that doesn't mean only when Chrome does it. Of course, lots of the browsers are supporting all of these features.
Yeah, so on a technical level, Chrome implements those specific heuristics. Other browsers may implement different heuristics, and you might imagine getting progressive web apps different ways, right? The fact that we have this one prompt that triggers at this one moment, which from a user perspective can feel a little bit arbitrary, is basically an implementation detail. All the technology is very open. It doesn't demand that browsers create any specific UI. So I expect to see a lot of evolution, actually, in how browsers present the ability and willingness to keep these things to the local system and how you run them. I expect that to sort of change a lot. You can imagine listing these things in stores or having persistent UIs that tell you that, hey, this thing is a progressive web app, as opposed to that occasional prompt. Those are all possible futures that other browsers can explore.
In fact, we're also exploring different treatments for it and seeing other ways to improve the treatment we've got today. But I also want to correct one thing, though. I think a lot of people think of progressive web apps as it doesn't count until it's on your home screen. And to me, that isn't the be-all, end-all that it is with, for example, a native app where it's the same thing. And I think that users can get value out of it from push notifications or just from it loading more quickly when you come back to it. And so the fact of the matter is, not everyone's going to want to add your thing to their home screen, and that's fine, because you can still create a really meaningful experience and add value for them. And as you do so, maybe over time they'll say, you know what, you are pretty cool. Maybe I will add you to my home screen.
Yeah, decoupling these was sort of this thing where we had to give it a name at some point because they added up to an experience, but the goal was an experience for the user and not a particular bundle of things that you had to have all at once. Like the native app model of having to go through a particular huge transition, a big step phase, big phase change, a big step to get to the moment where you can do all this stuff because you said yes to it all at once. That's pretty tough from a user experience perspective. And so we want to make them more a la carte. And the fact that they add up to that ability, that moment where you can get added to the home screen or that moment where you can ask for push notifications, that's just the strength of the web being more a la carte.
What you're talking about before, like being able to have some kind of store or place to find these, I think that's really interesting. I think that's something I'd like to see Google take on, is to create some kind of engine for searching content on the web, and somehow users can find these.
That sounds really hard.
It feels like a space we should get into.
So Jake, since you started talking again, there is a follow-on. Because you mentioned the fact that offline's a thing, and actually, Alex, you kind of mentioned that it's about the experience, not necessarily checking all the boxes. Why is it then that app cache isn't valid as part of the requirements list for a progressive web app?
So I've had a lot of questions from internal teams in the last couple of months about why isn't app cache good enough. And so I wrote a document, which I haven't shared publicly for obvious reasons, called App Caching Your Architecture Not Even Once. And the TLDR of this document was basically, you start with the best of intentions, and app cache's design decisions cause you at every moment to contort yourself ever further away from the experience you wanted to deliver. And before you know it, you've centralized on a single URL. And you've decided that you're going to do hash navigations and not push state, and that you're going to do offline only and not reliable performance, that you're going to give up on a bunch of the experience differences that you're really trying to affect to get to something that app cache will allow you to do. And so I think it's worth sort of understanding where the end point of that journey is, and then deciding that that's not something we should buy into. It isn't that app cache is bad technology, it's just that it's not designed to build reliable performance. It's designed to give you special case offline. And special case offline kind of isn't worth having, because offline is very much a special case. You're only in an offline mode very occasionally when you set your phone into an offline state or when a navigation finally fails. But you're on a flaky connection basically all the time. And so handling the flaky connection and getting reliable performance is the goal. That's the user experience win. And confusing the two doesn't really work. It doesn't help anybody.
Plus, we keep finding horrible security things in the app cache spec.
Oh yeah, we're taking it off of HTTP, by the way. Yeah,
even
so
on HTTPS, though. We're kind of terrified.
Okay, let's move on.
One thing.
Okay.
A lot of people spent a lot of time trying to make app cache work and went through all of this pain.
Jake, for instance?
Yes, this guy. But lots of other people. And so we did release just the beginning of a library today or yesterday that tries to kind of say, you know, if you've done all of this work to generate these manifests and all that, like, that's a lot of work. So here's a path to make that work with service workers. And then again, hopefully you then kind of move off over time. So if you do have app cache working now, we're trying to make that pain go away a little bit.
And it doesn't have the security bugs that app cache does, so safe to use.
Okay, the next question is a security-related one, I suppose. Will we ever get signed or trusted progressive web apps with the same security properties and the privileged APIs of Chrome apps? I guess, Adrian, do you want to take that one?
Yeah, that's actually a very interesting question. I've heard a lot of developers asking, when will we get specific APIs that I really like from the Chrome apps platform? And the answer is that we want to keep the web open so that you click on any link, and you as a user don't have to be afraid of what's going to happen when you click on that link. And so for that reason, we're taking a very reasoned and measured approach when we look at the different APIs that can be adopted by the web. I don't think that signing and packaging are necessarily the distinction here. Rather, it's the discovery mechanism. Is that you're getting to a website just by clicking on a link. You don't necessarily know where you're going. And we want it to just begin working immediately. So our approach has been runtime permissions for the web, where we try to, first of all, design the APIs to be safe by default, and then have permissions where users can opt into experiences that might potentially have some amount of security risk. Although, again, our first aim is to do it through designing the API so that there are no major security risks with any APIs. And this takes time, and we have to think very carefully about which APIs we release. So, in the long run, I'd like for most APIs, many of the cool things that you could do in Chrome apps, to be available to the web, but it's not going to happen overnight because we have to make sure that the security experience for each one is done correctly.
I think that's a really important broader point, too. The web's strength is its low friction, the ability to just tap that link and get to another experience. And that's one of the things that enables so many really cool business models and so many interesting, diverse things on the web. And it's not like we all woke up one day and said, you know what? It would be great if by tapping on a link we could load it immediately without an interstitial. That's part of the design from the very beginning. It's been very meticulously managed and evolved and strengthened over the past 20 years. And it's something that's fundamental to why the web is so successful.
Okay, don't forget you can come up to the microphones and ask your questions if you've got them, but there's an interesting one that's coming on the Twitters. Android Instant Apps, brackets, no need to install, versus progressive web apps. How/where do you see each being used?
Cage match.
Round one, fight.
Oh, in all seriousness, so of course, Google, I think we're a large company. We always want to make sure that developers are successful on whatever platforms they choose. The way that I think about it is the web has historically had this really low friction, which I conveniently just talked about. That's very important to this awesome, diverse ecosystem, but it's also had low capabilities. And if you look at native apps, those have historically had very high capabilities, but also very high friction, in part due to those capabilities. So progressive web apps has been a multi-year effort, working with standards, working with other browser vendors to design these APIs very carefully to maintain and allow us to responsibly bring these capabilities to the web. And I think that Instant Apps is the same kind of multi-year journey to bring the lower friction to native apps as well. So I think that really cool demo that I think we all saw in the keynote is something that's like an aspirational goal to get to, and I think will be a really cool place. Now, one of the reasons I love progressive web apps is because it's just web technology. We've been using this stuff for many, many years. It's been evolving over all the time, and you can deploy these things today. In fact, we published 7 additional case studies from businesses around the world, Indonesia, India, Africa, many other places, just yesterday, showing businesses having really, really, really strong business metrics by adopting these technologies. And that, to me, is one thing that's so cool about it. It's cross-browser, it's cross-platform even, because we've seen lift in conversion rates on iOS for people who invest in web.
That's good, because everybody else got an intro. And then they were like, you're just walking on. Sort yourself out. So I was prepared to be like, ladies and gentlemen, please welcome to the stage, Paul Lewis. But I don't need to do that because you all cheered. So thanks for that. But while I was waiting, I don't know, when somebody mentions something and you can't unnotice it, I'd like to thank Jake for pointing out the music before each of the sessions. Although I noticed that it has this kind of choral kind of thing going on, which I felt added a certain amount of gravitas and sort of epic to the proceedings. And I was like, what's more epic than UI elements? So good. Anyway, that is exactly what I'm going to talk about. Now, so far we've had Surma and we've had Jake talk about performance and streaming and stuff. And I wanted to talk about the bit that happens after that, the bit where you have your UI elements. And before I get into it, I kind of wanted to put that into a little bit of context. When we talked about performance historically on our team, last year and a half, we've talked about a thing called rail. And rail stands for response, animation, idle, and load. And it's a way of thinking about performance that puts the user in the middle and lets us figure out what they expect from things. So, for example, if you tap on a screen, you expect something to be coming back on screen in under 1/10 of a second. If you scroll or there's a transition, that's an animation, and we want that at 60 frames a second. Idle's a bit of a funny one, but the general idea is that you should do work when the user isn't interacting and when there's opportunity to do so, when the main thread has some time. And we do those in 50 millisecond chunks so we can keep responding to users. And loading, we want to keep the user on their train of thought. And so you've got about a second to get something up on screen, whether that's from a cache or the network. Now, when we talk about Rail, this is the kind of worldview that I think many of us have today. We kind of go, yeah, response is okay. Yeah, we don't want it to be laggy. That's fair enough. It's kind of important. Scrolling animation. I definitely heard that's a thing, and that's something I want to make sure is good. Idle. Yeah? Sure. Seems good. Load, yes. Whew. Back in the safe. Okay. Load, yeah. Minify, concatenate, all that good stuff. But here's the thing. This is kind of where we're thinking of being on people's home screens. And a closer look at that home screen raises an interesting question. Which of these is the progressive web app? Which of these is the native web app? And the truth is, users don't care. What they care about is that the thing that they tap on works really well. And they would never say something, oh, wow, it skipped things. There you go. Back, would go, rewind. Okay. Nobody's ever going to say this, and if they did, it would sound like this. That app looks like native. I hope it behaves like it. There you go. They expect it to behave like a native app. They expect your stuff to run well. When I say behaves, there we go. Hello. Behaves, for me, is like performance, and it's about, does it behave as we expect? Does it do the things that, when I interact with it, does it do the right things? Right. Since that's the case, I think we can reevaluate Rail to look more like bad clicker. More like this. The response part of Rail, well, we expect our responses to be instant, and like every time instant. So that's just now more important. Animations. Yep, they're down there, and there we go. They're going up there. Because we expect, again, we expect instant transitions. We expect scrolling to be super smooth. Idle. Well, now, if we're doing more work to make responses and animations good, idle is something we're going to have to be more tactical about. We're going to have to do some work when the user isn't, and we have things like request idle callback for that. So idle just went up. They're all going up. Good news, though. I think if you're expecting somebody to add you to home screen and run your stuff lots of times, hopefully you're going to have a service worker. Hopefully you're going to be running from a cache. And therefore, I think load drops down to here. I don't think it's unimportant. Don't get me wrong. You've still got to do a good job to get that first load there. But I think over time, I think that's what we're talking about. So if you're being home screen minded, I think it looks more like this. And I think if you think about the native apps that you run, you have a similar expectation. You don't ever sort of sit there thinking about, oh, this APK took a long time. When you're using it for the 50th time, you're thinking more about how this actually behaves, whether it's got the features you want, and so on. So with that in mind, I wanted to talk about 3 individual components, but they give me an excuse to talk about a bunch of other things, and I can explain, I suppose, the way I categorize my components. From deterministic, we know up front we can hard code the values for those animations and interactions, through something that's a little bit less known up front, all the way through to something where we've got no idea about how it's going to behave until somebody actually clicks on the thing. Or we have a little bit of an idea, but not much. So those three components are a side nav, some swipeable cards, and an expand and collapse view. Let's jump straight into the side navigation, which I think most of us have seen before. Seen these? Yeah, we've seen these quite a lot. So what I'll do for each one of these is I'll explain the theory of how I would approach them to maintain performance and to kind of be performance-minded. I will be leaving probably some glaring omissions in the area of accessibility, but just as well, Bob Dodd's coming on next, and he's going to talk about accessibility. Oh, it all fits together wonderfully. Anyway, the theory for the side nav, what we're going to do is we're going to pop on a containing element over the top of all our content, into which we can place a semi-transparent black background to obscure our content. And then we're going to have this contents bit with our actual side nav in it, which will slide in from the side, like so. So the CSS for something like that, for that containing element, is going to be position fixed, left 0, top 0, width and height of 100%. Some people like to do right 0, bottom 0. That's fine. Works just as well. Overflow hidden because we don't want any scroll bars. But the pointer events one is a bit of an interesting sidestep that I want to take. And it lets me talk about something that's kind of like a primed element. So these are elements where you want that thing to be ready to go. And a side nav is one of those, because when a user taps on the button, they expect the side nav to just come straight out, right? So the general idea behind a primed element for me is that it's something that could be activated at any time. Okay, like a side nav, yeah, it probably fits that bill. And if you were to toggle its visibility, it would take more than 100 milliseconds, as in, because they're probably going to tap a button, and Rail tells you you've got 100 milliseconds to respond. If you take longer than that, it's going to feel laggy. So these are my sort of two criteria. As I say, I'm leaving a glaring omission as regards accessibility. So hold on to your hats for that bit coming next. But all the same, we have a primed element. I think this is a primed element. I think it fits. And as such, we can take a couple of shortcuts, one of which is we're going to promote the contents bit to its own layer. And if you're not familiar with layer promotion, the idea is you want to separate out an element from the rest of the page so that when you paint it or move it around, you don't affect any other element on the page. It's the same kind of deal as, if you had an art package or whatever, and you create a layer and you can sort of mess with the pixels in it, and you don't mess with anything else. Now, the easiest way to do that today, to create one of these layers, called a compositor layer, is to use will change transform. So if you imagine the simplest possible page with a photo of a bald idiot and a nice guy, and you put will change onto said image, now you can move it around with a transform. And you can see that it's kind of separate from the page. Obviously, this isn't happening in real time. But it's the idea of separating these things out. Now, you may be sitting there thinking, goodness me, that seems like a great idea. Star, will change, transform. Burn that from your mind. Okay? If I'm not clear, don't do it! The reason you don't want to do it is twofold. Firstly, you'll want to keep your memory usage down, especially on a mobile device. If you create layers, you're going to use memory. You're going to have management, you're going to have textures on the GPU, all that kind of stuff. So you want to do this as needed. Now, with the primed element, I'm going to make the argument that you probably want to do something like the will change in your CSS. But in other cases, where it's not known until you start interacting, you probably do the will change in your JavaScript. The other reason is you want to keep your time in compositing to a minimum. Compositing is where we take all those layers and we squish it back together and put the pixels up on screen. Now, of course, if you made lots of layers, that's a lot of depth sorting, it's a lot of management, and it's a lot of putting back together, and that takes time. So you want to be tactical about this. So we've got our promoted layer, and as you can see in the CSS, I'm going to put will change transform on it, like so, and then come back. Then I'm going to transform the contents off to the left by a oddly specific
102%. And if you're curious about that, it's because I've got a shadow. And I just do an extra couple of % to hide it. Cheating. But that's programming, it's just cheating, right, sometimes. And I'm a cheat when it comes to programming. I'm very, very not otherwise. Especially not when playing little games with my kids. I'm very fair. Never cheat. Anyway, eventually the user is going to tap on a button, and that's going to show the side nav, which in this case is just going to add a class, and that class is going to remove that minus 102%. Fairly straightforward. And we get something like this, where it slides in from the side. That semi-transparent black background is the same kind of deal. Here we're going to do a wheel change of opacity from an opacity value of 0 to an opacity value of 1. And getting rid of it, like so, is just going to be the same in reverse. We're just going to remove that class. Everything goes back. It's great. And we can just do that with this hide side nav, which I put on the containing element. So if you click anywhere, I'm going to hide the side nav, which is a bit bad if you actually click on something in the side nav. So the way to get around that is to just add an extra handler for that particular situation, which cancels the click, which is just a stop propagation. So I'm kind of canceling the click. And it works out really well. In fact, so well, this is what it looks like in reality. This is one that Surma and I built. This is actually running on a Nexus 5X, and you can see, slide out, slide in. I actually added a bit of drag thing to it, which you can see if you want to afterwards. When you take a profile of this in the DevTools timeline, which is kind of what you want to be doing with all your UI elements, I have the side nav sliding in and sliding out, which doesn't look very big, so let's zoom in. You can see that green chunk is the frames per second, and we're hitting a nice, comfy 60 frames a second on a Nexus 5X. And below it is the amount of work per frame, which is pretty low, because we're not doing much. We're just using transform changes. If you're interested in seeing that actually being built for real, there's the TLDW, and there's also a live stream, which was about an hour long, with me and Surma, where we built the side nav, bugs and everything. It was great, but you can catch that if you haven't seen it. So let's move on. Since we've done the fully deterministic minus 102% to nothing, we can move on to the swipeable cards, which is a little more interactive, a little more dynamic. So that's this one. You've seen it probably something like Google Now, just cards, and it slides up to take its place. The theory here is, again, we want to promote to a layer for the thing that's being interacted with, but we want to do that on demand. We don't want to do this one ahead of time, because if you had a lot of cards, that's a lot of layers and a lot of memory usage. Not a good idea. We also want to use transform and opacity as well, because we're going to transform this thing off to the side, and from a kind of behavioral point of view, we want it to fade out, because that gives the idea of being dismissed. It's kind of something the user would expect. Now, at this point, I want to take a little bit of a detour and talk about kind of game loopy stuff, which is something that any game developer would be like, yeah. And it's extremely useful in this situation. What we want to do in these kind of cases is decouple our input, which can happen fairly sporadically and whatever, from the actual rendering and drawing bit, which you'd expect from, say, a game, because if your character stood there, you don't want to, you want the kind of game to keep moving, even when you're not moving the character, right? Same kind of thing. We want this animation to keep going, even when we're not actually doing touch events, for example. And the way we do that is we call request animation frame for every frame of the interaction. And we'll give it our update function, which is a nice side effect. It gives us a function that we can just call to be like, just draw it, even when there's nothing else going on. Now we've got a touch move at the start of the frame. Well, that's OK. We'll just use it. We'll just store its value, and we'll pick it up in the request animation frame. If it comes in a little bit late, or it doesn't come in at all, no big deal. We'll just use the last known good value. If by some weird chance we actually got 2 or more, well, again, we're not doing work per input event. We're only going to do it once per frame, and we're just going to use the last known good value. That's good. So this is a model that you probably want to adopt if you haven't already for this kind of work. Now we get to to adding the event listeners, and fair enough, I'm going to share them between mouse and touch. And I think pointer events might help a little bit here, but I've got this. So touch start, touch move, touch end, so on. And as a side note, the adding of these touch handlers to the document is bad, generally speaking. And the reason it's bad is this, really. You have the compositor thread, which gets the user touch It's the one that actually is told about the interaction first. And by default, it would do something like scrolling. It would just move the page up and down. But we registered a touch move, and that involves the main thread. And if the main thread was busy or our touch move just ran for a long time for some reason, then eventually it would come back and the frame will be shipped. But in between that, we've blocked the user. Oops. So that's not as good. And there is a way around this. It's new as of, I believe, Chrome 51, and it's in Opera and Firefox. It's in development according to Chrome status. And same with WebKit, but this is encyclopedic knowledge, obviously. And I'm not sure about Edge. I can check with the folks on that team. However, what we do is we add this passive true to the event listener. And what that says is, I won't call prevent default. I'm not going to do it, so don't worry about waiting on me in order to do the thing you were going to do. Still give me the events and give me the information, but I'm not going to prevent default, OK? And the browser goes, cool, I won't block, then I'll just get on with it. That's great. So anyway, back to where we were. We have our event listeners, and we talk about what they are going to do. For example, we have this card. It's in the start X position. So what we'll do is you've tapped on it. We'll go to our on start, which is going to basically ask for the position, which will either be page X or the first touch event's page X. And then we'll add will change on it dynamically, which will give us a bit of a hit because we have to create the layer and everything, but it's probably going to be OK. Probably. Now you actually move your finger across, and we have to kind of go, well, what's the new position? Which is fairly straightforward. It's the same kind of deal. We just track the page X or the first touch event's page X. And since we know where we were and where we are, we can figure out what the translation should be, such that in our update function, we can say if you're dragging the card, your translation is the current minus the start, and what we will do is we will apply a transform with that value. Great stuff. That's going to work. We're going to be able to slide across. We can change the opacity in the same kind of way. But we now need to think about the next part, which is I'm kind of dismissing the card, right? Or I don't go far enough, and it comes back to the middle. So this is the behavioral bit. So if we consider a normalized distance, so it's at 0. If it was out to the side, we could say that was position 1. Or, back in the other way, that's also position 1. What we can do is we can kind of throw up these thresholds. I put them at 0.35 when I was doing this. You could pick 0.36 or something else entirely. It's very exciting. What will I choose today? Who knows? That's web dev. So I put 0.35. And if you don't go past 0.35, I'm going to slide back to the middle. If you do go past 0.35, I'm going to dismiss the card. Fair enough? OK. So that's in the on end, like so. There we are. Threshold. Card width times by 0.35. And this target X value, which we're going to come on to in a moment, is defaulting to 0. If you go past the threshold, we're going to choose either the card width or minus card width, depending on which direction you were going. OK? And we can pick that up in the else here, where we say translate X plus equals target X minus translate X all over 4. And if you've been around for a while and you've done this kind of work, you'll probably recognize this. If you haven't, very exciting little one-liner that is incredibly helpful when you want to do what I call the easiest easing in the world, or easying. Easying always takes this form. Okay, it's value plus equals target minus value all over strength. And I genuinely have made other developers memorize that. Because it's incredibly helpful. Let me show you what I mean, a kind of worked example. Let's say you want to get this box from 0 to 100. And you basically target minus value, so that's 100 minus 0, all over strength, which is 4. We'll move it 25 pixels. Cool? On the next iteration, it's 100 minus 25, which is 75, all over the strength, which is 4. That's 18.75. And as you build it up, you're going to see that it's going to slow down. It gives us a nice kind of slow down, easing feel to this, so that your box would go, sound effects not included. OK, so that's this one line, but it's an incredibly helpful line. It's either going to ease us back to 0, or it's going to ease us to the card dismissal point. Now we need to detect doneness. There's no better word for what we're doing here. Is this animation done? Can I say that we're finished with this? Well, OK. The way we do that is, well, it's either you go there and back to the middle. Fair enough. In which case, we can just say Are you nearly at the start? If so, yeah, you're probably done. That'll work. That'll get us most of the way there. If you are, just reset the target, allow the user to interact again. Other one is basically you've done the slide out to the side like so. And we also know that we're going to fade out the card. So, I mean, this is pretty cheeky, but we can just ask, is the opacity really, really low? If it is, it's nearly invisible. If it's nearly invisible, it's going. It's going, going, gone. And in fact, gone so much that we're going to remove it from the DOM with remove child, like so. Now, that will cause all the other cards to jump up immediately because the DOM, we took out an element and so all the other ones went, oh, cool, there's some space, let's take it. Which we don't want. We want them to animate. We have this function that says as much. And it looks like this, that kind of slide up. There you go. That's the thing you want. So what we do is in our animate other cards into position, what we're going to do is we're just going to ask for the current card, and we're going to step through all the remaining ones like so, and we're just going to basically push them down, straight down, by a card's height. So you go back down to where you were, please. Just ignore the fact that we just removed a card. You stay where you are, and then what we're going to do is we're going to wait a frame for that to take hold, because styles will run after the end of our JavaScript. Cool. And then what we'll do is we'll switch on a transition on transforms, and we'll get rid of it. And that'll cause all the cards to go, and that'll look great. Cool. And then when we're done, we can reset the target. And in reality, this is what it looks like. This is another one that Surma and I built. Again, it took an hour. There were bugs. Weird. So you go, slide, swipe. It's great. If you go to timeline and you were to take a recording of that, again, zoom in, and it's actually in two parts, this one. The left-hand bit is the card dismiss. What are you doing? Slides. Don't do that to me. Maybe it's me and Jake. Maybe there's something bad going on. I'm blaming Jake. It was all fine until Jake came on stage and everything broke for him. Interesting. Coincidence? Yes. So the card dismissal, that's right there. And then there's the other bit here, which is sliding the cards. And you see there's a little dip at the start. And that's because that layer promotion or there's a bit of layer promotion, but the kind of setting up of those card animations did cost us a little bit. So if you're interested in that and you want to see that one built, what are you doing? Seriously. OK. If you want to see that one built, there's a TLDW. There's an hour-long live stream that you can catch of that one as well. Swipeable cards. Right. We can move on. Seriously, I'm just going to stand around here. OK. The expand and collapse is the final one, and it's the one that is the kind of fully dynamic one, because you could pick any of those cards. They could be anywhere on screen. And OK, in this case, in the mobile case, they might do a full screen takeover, but they might not. They might just expand a little bit or something like that. And we don't really know ahead of time. We can't hard code those values, and if we try, it's going to be pretty horrible. So how do we handle this situation? Well, the theory for this one is going to be a little more involved, but that's fun. When I get something like this from a designer or I do it myself, I kind of watch it over and over and over again. It's a thrilling few minutes. But it's a useful few minutes because as you kind of watch something over and over again, your brain starts to notice the patterns. And the patterns here are, in this case, I think that thing is getting bigger and it's moving. Yes, there's the pink header bit that's fading in, but predominantly this is about a movement. It's getting wider and taller, and it's moving. And therefore, I would normally go, wow, that feels like a width, height, left, and top moment. Great. That's probably what I would animate, except that would be bad. And the reason it would be bad is that in every browser, you would trigger layout with the purple chunk at the top there, paint, and composite. Layout is basically where the browser says, where is every element? It's basically a geometric process. Where is every element? What is its size? And so on. Paint is where we fill in pixels, and compositing is where we put the page back together, all those layers. Now, if you've got to do that for every single frame, and you might have a reasonable sized DOM, you're in trouble. You don't want to be able to, you don't want to have to do this work on every single frame. Chances of getting 60 frames a second, slim to none. You may have noticed that I use transforms an awful lot, and the reason is their profile is different. For an element that's got its own compositor layer, changing a transform is not going to trigger layout, and it's not going to trigger paint. It should only trigger compositing, which is something that we can probably get done comfortably at 60 frames a second. So this then changes the question to look like this. Can we do that effect with transforms? Can we remap this slow-mo Can we do that with a transform? Well, to me, that looks like a scale, and it looks like a translation. Cool. My approach is called flip. It stands for first, last, invert, and play, because there aren't enough acronyms. OK? So I'm adding another one. Cool. But it's an extremely useful way to think about the animation. What we want to do is we want to essentially ask the question, at runtime, where is the element that I'm interacting with? So we record its first position on screen. And we do that with something like getBoundingClientRect, which is fun to say and has been around since IE4. Brilliant. And it will tell you, in relation to the viewport, where this element is. Its left, its height, its top, its right, its bottom, all the stuff that we need to know. Now what we can do is we can actually snap the element in question out to its final position. Now I'm doing this with a class, but you could manipulate the styles. You could do whatever you need to do. So now our card is going to be in its last position like so, and we can call getBoundingClientRect a second time. So now we know where you were, and now we know where you're going to be. That's cool. That means we can start to kind of figure out our transforms that we might need dynamically. Now, there is a word of warning here. Going from first to last is going to trigger styles and layout. And the reason it's going to trigger styles and layout is because the second getBoundingClientRect came after some style mutation. We said, here's a new class for you, or here's some style changes. And then we asked for how wide and how high and where are you on screen, and the browser goes, I don't know, you just moved everything. Hang on, let me go and figure it out, and I'll come back with an answer. And that's exactly what happens. So you've got to bear in mind that there's from this first to last, and you might be sitting there going, hang on a minute, I'm sure you said triggering layout was bad, and I did. But the key is here, we're not going to do it on every single frame. There are two things we need to bear in mind. One, we're going to do it once at the start as a setup cost. Secondly, we have rail, which is going to be our friend here. Bear in mind, the user tapped on a card to get the animation. Therefore, in rail terms, they're here. We have 1/10 of a second in which to respond. We have 1/10 of a second in which we can do some work. And believe me, 1/10 of a second is actually quite a long time, especially when it comes to this kind of work. It's great. We should use it, and we do. So when it comes to rail and flip, you can typically afford to do a single styles and layout pass. No, seriously, one. But that's cool. That's often enough. And in terms of flip, that's a good setup time. You'll still need it to complete in less than 100 milliseconds. So you kind of have to be aware of how big the DOM is, and if you're able to use something like CSS containment to limit the scope of layout and paint, you should definitely do that. And that's really useful. However, we knew where we were. That was first. We know where we are. That's last. And now we can transform. What we'll do is we'll just basically apply an inverse transform to take us back to here. We can do that. So first minus left, blah, blah, blah. Do that with a scale, apply a transform that uses those values. So at this point, we've done first, last, and invert. And it's like this. So if I was to tap on the card, ready, steady, go, boop, there you go. From a user's point of view, nothing happened. What's really happening is this. We're going first, last, and then we're inverting. And it feels like a lot of setup cost, and it kind of is, but it gives us a huge advantage because what we can do now is switch on transition on transforms, and remove that transform, and our card will just go. We didn't know where it was at the start. We didn't hard code it. We just said, where are you going? Where are you now? I'll figure out the transform, and I'll apply it for you. We've just managed to remap something that was width, height, left, and top, which wouldn't have run at 60 frames a second, to something that definitely will, hopefully, all being well. Caveats, though, because there's always those. If you've got some scale changes that are being applied, something like text. Let's say you're doing something flip-like, and you've got something with text inside, that might get squashed or stretched. So you might need to move the content to a sibling element so that it's not affected and then just sort of faded in or something like that. Bit of sleight of hand. You might need to do that. Bit of gymnastics, but it's well worth it. Like I said, the first to last does involve forcing styles and layouts, so you have to be careful with that. But this is what it looks like in reality. This is a little kind of expandy, collapsy card thing. Which, that's running on a Nexus 5X. And this screen doesn't make it look like it's 60 frames a second, but it is. And I can prove it because I've got timelines that show it. And you can see it. I'll show you. It's great. It's also responsive design friendly. Like I said, we're going to ask at runtime what the first position is and what the last position is. We don't We don't hard code those values, which means the same animation on desktop looks like this. Different position, different sizes, but still the same stuff. And this is what it looks like in timeline. We'll zoom in again to the top bit. And you see the dip at the start, and you see those red markers. That's DevTools telling you your frames per second dipped below the comfortable point of 60, but we know that that was the setup of flip. That was the first, last, and invert, which on a Nexus 5X, on this case, was about 40 milliseconds. After that, that is a steady 60 frames a second afterwards. Tremendous. Cool. I get to call this one a day in a moment. Some closing thoughts. You've noticed probably that I use will change, and I would suggest that you start doing that if you haven't already, for elements that you intend to animate. You need to decide, is this thing primed? If so, I'm going to probably put the will change into my CSS. If not, I need to do it on demand, probably via JavaScript. But you want to use it sparingly. Don't go overboard. Transform and opacity are your best friends when it comes to UI elements running performantly. I hope in the future to be able to say that you can get away with a lot more. And actually, we are heading to that world with things like GPU rasterization, CSS containment, lots of really good things that might help us limit the work and mean that we can do more. But for today, for the cross-browser story, I would suggest that you stick here. If you find yourself in the kind of dynamic end, then something like Flip, where you can remap expensive properties, calculate your transforms at runtime, is very useful. Now, if all of that's news to you, and you've never come across like layout, recalc styles, or anything, here are some links. Inbound. Phone's out. Don't worry, you can get the slides afterwards as well. Oh, the phones went down. Don't care anymore. There's the Google Web Fundamentals render performance section, complete with Udacity course, which will take you through the same kind of content. Very useful to get up to speed. Secondarily, if you want the source code for those elements I showed, you can get that at Supercharged UI, which will take you to the GitHub repo. If you want to see me and Surma, where Surma basically spends an hour interrupting me, and I try and code, it's like real life. There are bugs as well. It's every time I do one, it's scary but brilliant. Oh, there's a TLDW, which is like 5 minutes if you haven't got that amount of time. Right, I need to shut up and move on. But before I do, I just want to say this again. We are hopefully going to be here. This is the first time we've been invited to people's home screens. That is incredibly exciting, but it's also a huge responsibility. We need to act like we deserve to be there. And that means taking our user interface work super seriously. The web is ready for us to do that. We can do that today with the tech. I've shown that you can. I hope that you go and give it a try. And with that, I'll say thank you very much. Now next, to tell you how I focused on performance rather than accessibility is I call him Bob Dodd. You can call him Doddlemax, the Doddinator, Sir Bobbily of Dodley. Or you can just call him Rob Dodson, but don't do that. Call him Bob Dodd. Ladies and gentlemen, Bob Dodd.
I think of those, my favorite is Doddlemax. That sounds like a transformer. So yeah, what's up? I'm Doddlemax of Bob Dodd. And today I want to talk to you about how we can make sure that as we build our progressive web apps, that all of our users can access the content in those apps. Now, Paul just showed some really cool examples of how to build amazing components. And as he hit on repeatedly in his talk, we know that performance is not just a nice to have. Performance is kind of a crucial aspect of a good user experience. We know that users will actually abandon an application if it doesn't have the performance that they expect. But it's often the case that when we're designing these components and these applications, we're doing so based on our own experience and our own physical abilities. So we're designing for the range of users who really see and interact with the world as we do. Meaning, anyone who falls outside of that range is going to be excluded from our design. So these users aren't abandoning our app. They're actually prevented from using it in the first place. And so as designers and developers, it's important that we not only consider how we interact with the world, but we really think about the full range of human abilities. And this becomes especially important when we're talking about mobile. Because as we use our devices in different contexts and in different environments, we may too experience situational or temporary impairment. So to give you an example, I'm sure many of you have had the experience of trying to use your phone or some electronic device outdoors when it's really sunny. And you need, you can't really read the screen, so you're kind of doing this thing, right? You need some additional contrast on the screen so you can actually read it. So if we have a design that also factors in the needs of low vision users, folks who also benefit from increased contrast in their reading experience, then what we end up with is just sort of a more robust application. It works well for those users. It works well for us as we take our mobile devices out in the sun. In other words, accessibility just equals good UX. I'm getting the crazy slider, too. There we go. Accessibility is just good UX, right? So this is what I want to talk about today. How do we make sure that all of our users can access the content in our apps? I'm going to do this by splitting this talk into 3 parts. So the first part is looking at really the diversity of users that are out there and touching on the accessibility topics that affect them. Then I want to look at 2 big areas that developers often miss, which are particularly focused on focus and semantics. But I want to start just by understanding who our users are and the kinds of assistive technology that they use. Now, I'm going to focus on users with permanent disabilities. But again, I want to reiterate that issues of accessibility really do affect all of us. Ensuring that users with disabilities can access the content in our applications is just going to make a better experience for everyone. But having said that, let me get some numbers out there, because I think these are pretty fascinating. So according to the World Health Organization, about 15% of the world's population lives with some form of disability. So to put that another way, we're talking about around 1 billion people worldwide. And we can roughly split these into about 4 different sort of categories of impairment. Those affecting visual senses, those affecting motor and dexterity, auditory senses, and cognitive senses. And I want to cover each of these individually, starting with visual senses. So users with visual impairment, you can kind of split them into 2 groups. Those folks who might be completely blind and have no vision, to those folks who might have limited or low vision. So someone who is completely blind might use a screen reader. This is TalkBack on Android to interact with their device. They may also use a Braille reading device to access their desktop and have it sort of translate the content for them in that environment. So that's users with no vision. Users with low vision, they may also use a screen reader, or no, go back. There we go. They may also use a screen reader, or they may choose to use screen magnification. They might use built-in zoom that's at the browser level, or sorry, at the operating system level, as you're seeing here. They might use browser zoom, just Command plus to zoom in the page. They may also use something like high contrast mode. So here you're seeing that the background and the foreground colors have been swapped to increase legibility. So that was vision. For motor impairment, these users really span the gamut of folks who maybe would prefer not to use a mouse because they have something like repetitive stress injury, something like carpal tunnel syndrome, or maybe even just like a broken arm or sprained wrist, all the way to someone who might have, or who might be physically paralyzed and have a limited range of motion. So for these users, they may be using head or eye tracking devices. This is an example of a program called Dasher, which uses a webcam to track the user's head and eyes and help them type. They may also be using a keyboard or a switch device, as you're seeing here, to actually drive their computer. They may also use voice control. So there's a lot of different mechanisms that they can use. For auditory impairment, these users range from those who are profoundly deaf to someone who is hard of hearing. So I'm actually in the hard of hearing camp. I've got about a 90% hearing loss on my left-hand side. So for these users, you want to make sure that you're not relying solely on sound to convey information in your app. So making sure that if you have a video, right, you've got captions, that you've got transcripts, that you're providing some kind of alternative if sound is part of your interface. And finally, for cognitive impairment, this is really a broad area that can be difficult to quantify, but it spans conditions like ADHD, dyslexia, autism, just to name a few. And while the accommodations for these groups are obviously extremely diverse, we definitely find some overlap with things like zooming to make it easier to read and easier to concentrate on the page. So this is a Chrome extension for someone with dyslexia. It applies color gradients to the text to aid in their reading order and help them read in kind of a more linear fashion. So broadly speaking, these are the 4 categories that we need to think about when we're working on accessibility in our app. Now, because accessibility is so broad and the usership is so diverse, it can be helpful to have a guide to make sure that we are covering each of these groups. And we can find that in the form of the Web Content Accessibility Guidelines 2.0, or WCAG. WCAG is basically a set of best practices which have been put together by accessibility experts to really try and explain what it means for something to be accessible. And WCAG is extremely comprehensive, but it can also be overwhelming. I know some folks look at that and they're like, that is not a thing I want to read right now, right? So to help mitigate this, the WebAIM group has actually taken WCAG and distilled it down to a very easy to follow checklist, which is targeted specifically for web content. So if you were watching those videos earlier and you were wondering, wow, how am I going to possibly cater to all of these different users and all these different assistive technologies, I think the short answer is to nail that checklist, okay? Figure out what the primary user journeys are in your application. If creating a new account is an extremely important process that you want all users to complete, then take that user journey, and for every step along the way, make sure you can check off those relevant checklist items. And do this for every phase of your process, right? So get your product managers bought into it, get your designers bought into it, and make sure this is, you're having accessibility audits in your design review, get your developers bought into it, get your QA team bought into it, and checking these things to ensure that the burden does not rely on one person. So with these checklists in hand, we're actually ready to start exploring some of the fundamentals which we'll need to actually complete those checklist items. And I want to start by looking at focus. And really what is focus? What does it mean for something to be focused in the browser? If we really try and get down to first principles. So in a nutshell, focus determines where keyboard events go in the page. To give you an example, if I go and I click on this text field, that act of clicking on it actually focuses it. And from then on, as I'm typing on my keyboard, all key events are directed to that element, which in this case knows to display the characters as I've typed them. Now, some users drive their computer entirely with a keyboard or some other type of discrete input device. So for these users, focus is absolutely critical because it's their primary means of reaching everything on the page. It's also really important for our screen reader users because if we're building something like a single page web app and we're adding new content to the page, right, we're fading in a new page or something like that, then we need to direct focus to that page so the user knows that it's loaded, they know it's available, and their screen reader can announce it. And we'll talk about that a little bit later on. Now, a lot of the controls that you're familiar with working with, things like button, input, select, all these elements are implicitly focusable. What that means is they are naturally inserted into the tab order, so a user can reach them hitting the tab or shift tab keys on their keyboard. And they have built-in keyboard behavior support. So if you take a select element and you hit the up and down arrow keys, right, you can select something. If you hit space or enter, it'll select something, right? So they have a lot of goodies built into them already. But not all elements are focusable. So for instance, this header here, this paragraph of text, this image of a cat, these are not focusable because there's generally no need to focus something if a user can't interact with it or provide it some sort of input. Now, if you're worried that someone with a visual impairment might miss some of this important content, don't be. That's why we have tools like screen readers. It's a screen reader's sole job is to read headings and read text and read the content of an image using alt tags. So don't make something focusable if the user can't interact with it. That might seem like you're helping out, but it's actually detrimental to the user experience. And this brings up an extremely interesting and important point, which is that if you build your interactive controls out of these sort of non-focusable elements, a div, for instance, then your users may not actually be able to interact with it at all. So I'll give you an example using Paul's side nav. This is actually not Paul's exact side nav. I've modified it a little bit. But you can see here that I've got my little hamburger menu up there in the top left. And obviously, I want to tab over and click that to open my menu. And right now, my focus is on that little start anchor up there in the header. So as I'm tabbing around, or hitting Shift-Tab in this case, you'll see that my focus never lands on the hamburger menu because it's a div, and a div is not focusable. So if I am a keyboard or switch device user, I may potentially never be able to click on that menu ever. So how do we fix this? This is obviously a bad user experience. Well, the straightforward thing to do is, instead of using a div, we can just use a button element, right? So now when the user goes to tab over to it, because button is easily styled, we can make it look like a hamburger menu. Now they're inside of our drawer. Things are all good. A side benefit of using a button element in this case is that the browser actually has built-in magic that you get for using certain tags like button. So a button element, if you give it an on-click handler, and someone lands on it, they focus it, and they hit Enter or spacebar, even though they didn't click with their mouse, technically, the browser will just say, Enter or spacebar, yeah, I'm going to run your on-click handler for you. If, however, you have a div, and you make it focusable, and I'll talk about how to do that later, and you have an on-click handler on that, and someone hits Enter or spacebar, nothing happens. You actually have to add an additional key down handler, and then you have to check which key was clicked inside of the key down handler. So there's really no benefit to using these kind of like less or non-semantic elements to do this kind of work. In other words, don't fight the platform here. So the browser has a lot of built-in stuff. It's trying to save you from having to write extra code. But I realize, there's not always a native element that has the behavior that you need. Or, as is often the case, there might be a native element, but it might be really hard to style. Things like checkboxes and radio buttons, input file, that thing's impossible. So if you are going to go and build a custom control, it's important to remember that you just have to add that keyboard support back in. And you can do that using the tab index attribute. So tab index lets you kind of configure the focus behavior for an element. And it can be applied to pretty much, I guess, many or most HTML elements. A tab index value of 0 is going to just insert that element into the natural tab order, meaning someone can hit the tab key on their keyboard, and they'll easily reach it. It also means that we can call its focus method to programmatically focus it. So here I've got this very fancy button that I've created. Right now, if I press tab, focus is just going to move right past it. So I give it tab index 0. Now when I press tab, focus lands on it, and we're all good. Tab index -1 means that the element will not be in the tab order. But this can be really useful if you still need to programmatically focus something using JavaScript, or if you want to temporarily disable a control. So what I've got here is kind of a list control, and I might have like 100 items in this list. So I wouldn't want all of those to be keyboard focusable, because a user's going to hit tab over and over and over and over and over again to get through them. I'd like the entire list to be a single tab stop, so a user can just move into it and move out if they need to. But when they're inside of it, maybe if they hit the up and down arrow keys or something similar, maybe then I can change which item is currently selected. So to do this, I'll use a technique called roving tab index, or roving focus. And you can see here in my markup, my currently selected item has a tab index of 0. And so what I'm going to do is listen for the user hitting the up and down arrow key. When they hit down, I'll just move the tab index 0 to the next element. I'll call focus on it. That directs all of our attention to it. But if the user wants to, they can still tab out of this control. But when they tab back in, right, the last thing they interacted with is focused for them. This is an extremely useful technique if you're building sort of complex controls and other elements. It has obviously great browser support, because we had tab index for quite a while. So definitely commit this one to memory if you're building anything advanced or super fun like that. Now you can also have a tab index value of greater than 0. You can have a tab index of 5, which just means it's going to jump that element ahead of everything else in the tab order. This is basically considered an anti-pattern, but I wanted to include it for completeness sake so that you know that it is a thing that you could do. The reason why this is an anti-pattern is you can end up creating a super confusing tab order if you do this, and you're mixing matching components, maybe by different authors, and they're using tab index greater than 0. Right? Things could get wild pretty quickly. So in general, you want to avoid tab index greater than 0 if you can help it. Now, I want to revisit the side nav that Paul showed earlier, because it presents an interesting couple of use cases for tab index. If we think about a side nav, when we open it, right, we want the user to be over there, right in the drawer, right? Either clicking a menu item or dismissing it. We definitely don't want them over there, behind the overlay, maybe interacting with the page when they shouldn't be. But if someone is using a keyboard or a mobile screen reader to open our drawer, there's really nothing that automatically moves them into that side nav drawer. And I'll show you an example of what I mean by this. So this is mobile Safari running VoiceOver. This is hands down the most popular mobile screen reader setup out there. About 70% of the people surveyed who use mobile screen readers use mobile Safari and VoiceOver. And you can see this little black rectangle up there on the reload button. So that is where my screen reader is currently doing its thing. And I want you to watch what happens here. So I'm going to start swiping to move the screen reader. I'll land on the hamburger menu. I'll double tap to select it. It looks like I'm inside the hamburger menu, but I'm actually, or sorry, it looks like I'm inside the drawer, but I'm actually still just in the header. I was still sitting on the hamburger menu. Now I'm just moving through the header when I probably shouldn't be. I might be interacting with the page when the author isn't expecting it. So my user's context hasn't been updated. They're not even sure if the menu is open yet. And if you have a site that has one of these kinds of menus and you have not done any work to direct the user's focus into your drawer, this is probably how a blind user or a screen reader user is going to interact with your app. So how do we fix this? This is obviously not a good situation to be in. Well, one approach is to find a suitable heading inside of that drawer. I've got this one right here that says menu, and that seems like a good one. And I'll give it a tab index of -1. So remember, when I give something a tab index of -1, it's not in the tab order. The user can't reach it hitting their keyboard, but I can programmatically focus it using JavaScript. So now when the drawer opens, I can call its focus method, and now the user is going to be directed inside of here, and they can start acting on the drawer very easily. So I'll show you an example of that. Right? So same experience. We double tap the drawer, and we just move right to the menu, and the user can keep moving with their screen reader. They know exactly where they are, and they have that nice sort of continuity to their experience. So this is a technique called managing focus, and it can be extremely, extremely valuable for your user experience. It's useful for situations like this. It's useful if you're building a single-page web app and you're fading in a new page. So super good technique to have in your back pocket. Now let me show you another issue that I found specifically relating to tab index and this side nav. So this is more of a kind of a desktop, say, version of the site. And I want you to pay attention to what happens to my keyboard focus as I tab around the screen. So I'm going to focus those two things, and then it kind of disappears, and then it focuses that anchor. So watch that again. We're kind of moving around in the header, and then we just disappear for a little while, and then we focus that anchor in the page. Now I'm actually hitting tab the whole time. We can't see our focus ring anymore. And what's happening is because we have that drawer off screen, and because inside of that drawer we have anchors and things like that, focus is just moving off screen. It seems like it disappeared, but it's actually just over there somewhere where the user can't see it. Now we probably don't want someone to be able to interact with off-screen content, especially if we're kind of trying to hide it on purpose. Again, this would cause sort of an error state in our application possibly, and it can be very confusing for the user. So how do we fix this? By the way, I see this all the time. You should go to some big websites and start tabbing around. This will totally happen to you. OK, so how do we fix this? Because it's a super weird situation to be in. Well, the first idea is well, the thing's off screen, right? So let's set it to visibility hidden. It's off screen. That makes sense. It is hidden in a way. And this would totally work. But if you recall in Paul's talk, he talked about primed elements, and he talked about flip, and he talked about this idea of having your elements already kind of in the DOM, already ready to go. And if we set them to visibility hidden, then we're going to destroy the compositor layer, right? We're going to have to do all that work all over again every time the user presses a button. So that seems like maybe that's not the best solution. And to me, this is really frustrating, because I feel like developers and users should not have to choose between 60 frames per second animations and good accessibility. So I tried to come up with two solutions to this problem. The first is to ignore Paul and say, I win and I get what I want, and set it to visibility hidden anyway. And the reason why this is potentially workable is because, as Paul mentioned in his talk, you do have about 100 milliseconds from the time a user clicks on something until the time you need to start animating. So if our drawer is simple enough, then maybe we could get away with actually setting it to visibility hidden and recreating that layer. So the way we do this is we listen for the transition end event for when that drawer is off screen. Right? I check to see, hey, does it have the side nav visible class, which was how I know that it was either on screen or off screen. If it doesn't, I'm just going to set it to visibility hidden and do sort of vice versa for when we animate it on screen. So what does this look like in the timeline? Here's Paul's original version. And the time that I am interested in is this little block right here. So that's the time. The yellow bit there is the click. The end of that blue rectangle is sort of when we ship the next frame. So right now it's about 8 milliseconds in Paul's current version, well within that 100 milliseconds range, right? And if you look down here, you can see the amount of painting that we're doing. So I've got these 2 little chunks of painting that are happening. Because this thing's already in the DOM, we don't have to paint it much. So here's the version where I set visibility to hidden. And you can see that there's definitely more paint work going on. But if we look at our time range here, it's about 10.4 milliseconds. So we added a little bit of time, but not too much. And a lot of that time was actually idle time. So in terms of how this frame stacks up with Paul's version, they're pretty similar. And again, it's because we can get away with this because the drawer is super simple, right? It's a very simple element. If you had a bunch of images, a bunch of icons inside of there, then that paint may be more expensive. So this leads me to option 2, which I am calling the detabinator. Unfortunately, there's really no easy way to remove all focusable children of an element from the tab order. You have to go to every single child and set it to tab index -1. You can't just set it at the parent and have it cascade down, which is a bummer. So that is basically what this library does for me. I create a detabinator, and I give it the side nav element. And when I set it to inert, I set all of its children to tab index -1. I set it to inert false. I restore all of their tab indexes. The way that I do this is really gross, but I wanted to show it. So I have this query selector all, right? And I have this lovely query selector string inside of there to select everything that could possibly be focusable inside of an element. And this is not entirely bulletproof. There's weird quirks here. If you have like links inside of SVGs or stuff like that, like it may not be bulletproof, it may not be perfect, but it does probably, for general use cases, do the right thing. Then for each of those children, I'm going to loop through them. If they already have an explicit tab index, I'm going to save that. Remember when we set that menu to tab index -1 because we wanted to manage focus? So I'm going to hold on to that so I don't lose that information. And then I'll set everything to tab index -1 regardless. And when we're going to open the drawer, I just restore all those values. Okay? So here's the detabinator version in the timeline. You can see our little block of time right here is back to about 8 milliseconds, 8.4 milliseconds. So we're pretty similar to where we were with Paul's original version. And if we look at our paint time, we're back down to sort of like 2 little blocks of painting. So hopefully we're in sort of the same ballpark. Now again, there's sort of trade-offs to each of these, right? The visibility one, you have to do a little bit more work there in terms of painting. With detabinator, you would also have to add things like ARIA hidden to prevent a screen reader from going in there. So there's additional work that would be required in that case. But again, what I'd say is, maybe if you're running into this problem, try one solution or the other, measure it, see which one works better for you and which one your team prefers. OK, we talked a lot about focus. I want to switch gears now and talk about semantics. So this is the other half of ensuring we have a good user experience. Semantics is really crucial for making sure that our screen reader users can understand the content of our page. And the first question that comes to mind when I think about semantics is like, well, what does good semantics mean? Like, again, let's get to first principles. What the heck does it mean if something is semantically like rich or right or whatever, right? And how does that actually benefit someone? And to answer this question, it helps to think about this idea of affordances. So an affordance offers or affords a person an opportunity to perform an action. And a teapot is a really great example. So a teapot, just based on its physical design, has affordances. It has a handle. And because I've seen other things in the world that have handles, I know that I can walk up to a teapot and pick it up by that handle and interact with it. No one has to explain to me how a teapot works. Now, when it comes to graphical user interfaces, affordances still represent the actions that we take, but now they're kind of more metaphorical. So a button is a good example, right? Someone can't go, touch the screen and feel the button, so we try to make it look like a 3-dimensional button that you might actually interact with in the real world. But the obvious problem with this is that if someone can't see the screen, then they're going to miss out on those visual affordances. So we need to make sure that the information in our application is expressed in a way which is flexible enough to be accessed programmatically by assistive technology, which can then create an alternative interface for those users. So I'll give you an example of what I mean by that. Here I've got some semantically rich markup. So I'm using a select element to create a list. And this is going to generate a visual UI, right? But because I've used good semantic elements, it's also going to produce this alternative UI. It's going to produce a spoken UI for a screen reader user. Now, roughly speaking, for just about any element, you can expect some subset of the following semantic information to be expressed for it. the element will probably have a role. So the select element, in this case, its role is pop-up button. It will have a name. And I don't mean like a name, like the HTML name attribute, but you can think of the name kind of like its label, or the sort of the computed text value of that thing. The element may also have a state. It's optional. Some elements have states, some don't. And it may also have a value. Again, that's optional. But in this case, we have a value of no preference here. So what's happening is when we write HTML, the browser does two things. It generates a graphical user interface, and it generates a separate accessibility tree, which is just a collection of all that semantic information that I was just going through. This tree then gets handed to assistive technology, like a screen reader, and then that produces a spoken UI for our user. So this is actually why semantics really matter. Even though nav and div look the same, right? Because they don't look like anything, they just look like a container. Semantically, it produces something very different in the accessibility tree. So as I mentioned, just like with Focus, native elements, many of them have implicit semantics. So for example, VoiceOver on Mac, when I focus an input element with type equals password, it's going to announce secure edit text to the user. And just like we saw with Focus, when we try to bolt functionality onto non-semantic elements like a div, then we end up missing out on all these goodies that the browser is trying to give us for free. So here's another div button, another very fancy button, and it's got tab index 0, so it's focusable for sure. But when a user lands on it with the screen reader will say group, because a div is just a grouping thing. It's a container, right? But that definitely does not say to me that I should click on it. So again, don't fight the platform here. Whenever possible, use native elements because you're going to get good, rich semantics for free. And just as an aside, I hope at this point no one is considering writing a div button ever again. If anyone leaves here and writes a div button, I have failed all of you. But there are times when you're going to need to build something that just doesn't have a native element equivalent, or you need to just kind of go off-road and do your own thing. And in those situations, you can use the Web Accessibility Initiative's Accessible Rich Internet Application Spec, or ARIA. So ARIA allows you to specify attributes on an element and then basically modify that element's semantics. You can think of it like doing surgery on the accessibility tree. However, semantics is the only thing that ARIA changes. ARIA does not change behavior. So I used to think if I put a role equals button on something, that it magically became focusable and worked awesome with a keyboard. This is not the case. All it does is change the semantics that get expressed to assistive technology. So let me give you an example of using ARIA in practice. So here I'm going to build a custom control. I'm going to build a checkbox, a custom element checkbox. And in this box down here on the bottom right, I'll show the output from my screen reader, just the textual output, right? And the first question when I look at this checkbox is, OK, I'm building a checkbox. I want it to be accessible. What do I need to add to this? What sort of ARIA do I need to add? Now, there's two approaches here. The first is you could go look at the ARIA spec, which comes with this very helpful diagram. Or you could go check out this document called the ARIA Authoring Practices Guide. And this document is a bit of a hidden gem. It is pretty freaking cool. So over on the left-hand side there, you see all the UI patterns that you could probably imagine. There's a ton of them in this document, right? Grid, dialogue, tree, whatever you're trying to build. Checkbox, for instance, is included in there. So you click on the UI pattern, and I'll take you to a little section. And it's just going to walk you through all of the support that you need to add to that element. In particular, there's a whole section down here dedicated to the ARIA that I need to add to a custom checkbox. So it says it needs to have a role of checkbox. It needs to have an accessible label, which we'll talk about. It needs to have a state of ARIA checked if either true or false. OK, cool. So let's add this to our checkbox. I'm going to give it a role of checkbox. And you can see now my screen reader is announcing unchecked checkbox. Nice. Now, in the world of ARIA, role is the absolute most important attribute. Everything falls out of the role. Okay? There's a lot of ARIA attributes which don't even work if they are not paired with the proper role. So, and you can also see that now my state is just defaulting to unchecked because of the role, right? So it's like trying to start doing stuff for me. It's like coming alive, which is cool. But you can see that my checkbox actually is checked, so I need to change that state. So I can add ARIA checked, I can set it to true. And ARIA is sort of unique in that you always need to pass it like a literal string value of true or false Most HTML attributes do not work this way, but this is the case with ARIA. It's kind of a weird quirk. Now, the design pattern doc also mentioned I need labels for this thing. And there are a couple options for how I can label an element. The first is ARIA label, which is really just a label that you can apply directly to an element. A good use case for using ARIA label is something like a hamburger button, where I probably wouldn't have any other text on screen to explain this thing, but I need to explain it for assistive technology. So what I can do is take that button and add an ARIA label of main menu. And now it'll announce main menu button. Nice. OK, that's good. That's one option. The other option is ARIA labeled by. So ARIA labeled by lets you specify another element to act as your label. It's sort of similar to using the label element like you might do with a native input, but that element really only supports a few kinds of children, whereas ARIA labeled by can be applied to just about anybody. And the cool thing about ARIA labeled by is that it can be composed. So I can take other elements and combine them together for a bigger label. In this case, I've got this button that says Shop Now, and if you look at our text up there, the screen reader is just going to announce Shop Now button. I don't know what I'm shopping now for. I'd like to combine it with that header. So using ARIA labeled by, I can take both the header and the ID of the button itself and compose them together to create the label men's outerwear Shop Now button. Nice. So this is what I want to do in my checkbox. So I have this little span here. I'll give it an ID of sign, drop it into my labeled by, and now the screen reader is going to announce that I have sign up checked checkbox. There we go. Nice. Now, if you are building controls and you want to verify your work is correct, I highly recommend you check out the Accessibility DevTools extension created by my teammate, Alice Boxhall. This thing is awesome. It lets you inspect your element's accessibility properties the same way that you inspect CSS and other things like that. So here's our sign up button. I'm going to open it up, go to my elements panel, find this element, and then I can go check out its accessibility properties and see now its role and its values and its name and all these other cool things. So I don't have to go around with a screen reader and manually test every single element. So this is super handy to have. You can find it at bit.ly/A11y-devtools. Another cool example in the progressive web app space is this app created by the Polymer team called Shop. I really love this app because I think it shows off that you can build these bleeding edge, beautiful experiences using web components, using all the all the progressive web app tech that we're talking about, but still have it be really accessible too. So you can see the text down here. This is the output from my screen reader. And as I'm navigating around, it's giving me lots of really useful, actionable feedback. Right? It's telling me the proper thing that I'm interacting with. So definitely go check out Shop. You can find this at github.com/polymershop. If you find any accessibility issues, please file them. We want this to be like a showpiece of web components and a good accessibility. All right, we covered a lot. Let's wrap it up really quick. The three big things that I want you to take away. When you're planning your applications, make sure that you're really nailing that WebAIM checklist. Familiarize yourself with WCAG and ensure that you can go through those user journeys, and for every major primary use case, you can check off the relevant checklist items. If you're building controls, you want to ensure that they have good keyboard support and that everything is focusable. Use native elements whenever you can, because it's just going to save you a bunch of work. And if you need to create your own elements, use something like tab index to make sure that the user can interact with them. Also, make sure that you're offering the right affordances in your app. So again, use native elements because they have rich semantics for free. But if you need to go off-road, you can use something like ARIA, and that ARIA design pattern stock, seriously, that thing's a lifesaver. So definitely check it out. Now, if you're interested in learning more about accessibility, myself and Alice Boxhall, we have put together this entire Udacity course. It's launching today, I think, actually. So if y'all go sign up, you'll be some of the first people. So it's bit.ly/web-A11y. This is a multi-week course. It goes super in-depth on all of these topics. So definitely, please go check this out. Finally, the main takeaway that I'd like for you all to leave here with is this idea that accessibility is just fundamentally good UX. Ensuring as many users as possible can access our content should be our primary goal at all times. Cool. So that's it for me. Thank you so much. Coming up next to talk all about progressively enhanced markup, please give it up for my friend, Eric Weidelman.
All right. Do we have the slides? There they are. Thanks for sticking around, everybody. We're going to talk about how to use web components to build progressive web applications and the notion of progressively enhancing your markup using custom elements. So this is me. It's at eBital on Twitter and GitHub. I get crazy sometimes. I'm a digital Jedi at Google, which basically just means I'm a web developer that helps other web developers outside of Google build really awesome web apps. And I built a number of web apps at my time at Google. So we've worked on things like developer sites for HTML5 rocks. We built developers.chrome.com, Polymer's website, chromestatus.com. Santa Tracker's on a developer site, obviously, but it's kind of a fun project that we work on developer relations, so you can track Santa around the globe, see where he delivers presents. We built the codelabs site that you see here today at the show in Polymer, and we've also worked on the Google I/O progressive web app the last couple of years. Speaking of the last couple of years, I've gotten really excited about web components. All these emerging standards, several new APIs that allow us web developers to build applications. Code reuse, reusability, these are really good things for the web. And it's important to know it's a set of emerging standards, so it's not just one API, it's a few. And you can use them each individually, that's totally cool, but together it becomes a web component and it becomes very powerful. So they allow us to extend and create new HTML elements. That's the core, that's the principle here. And over the last 4 or 5 years since the standards kind of first started to evolve, we've grown the community quite a bit. So there's webcomponents.org, which you can check out. It's got articles, it's got people there contributing. That's also where the polyfills are hosted. If you want to actually write an app in production, you can do that using the polyfills. So check that out, it's a great resource. But browser support's actually been lacking. So I think Chrome 36 was the first browser to land all of the web component APIs. So you can create a component without the use of a library. That's really awesome. But browser support's been lacking. And so if you take away nothing today from this presentation, take away this slide. Basically what's happened is that Chrome implemented the APIs very early on, so Shadow DOM, custom elements, template, and HTML imports. This is what the API calls looked like. These are called now the V0 APIs. What's happened is that the browsers recently got together and said, hey, we want to tweak a little things here and there about each of these specs. And they decided and came to consensus, and what's going to happen now is there's a new version of Shadow DOM and custom elements. We call these the V1 APIs. So if you've learned about web components in the past, all the concepts still apply, same stuff still applies. It's basically just syntax and name changes. In this presentation, I'm not going to talk about template, which is actually supported in all the modern browsers now, which is great. You can use that without a polyfill. And I'm not going to talk about HTML imports. I'm just going to focus on the two that have changed. And implementation in the browsers is well underway. So Chrome has started in on custom elements and Shadow DOM. You can play with these today in Canary with a flag. Over at Firefox, Wilson Page, who's an advocate there, tweeted this recently. So they're actually started in on Shadow DOM v1. Custom elements has an open bug. They haven't started that yet. Safari last week, in fact, at WWDC announced Safari 10 will ship with Shadow DOM. So that's 2 browsers this year alone will have Shadow DOM. And they've also started in on the new custom elements API. We thought that might land in Safari 10, but they just didn't get it in on time. And over at Microsoft, Edge is playing crazy catch-up, implementing all these things. Service worker, push notifications. You see Shadow DOM and custom elements and web payments on there. So very exciting times for web developers. This stuff is coming in hot. Love it. Browser support really matters. Turns out native support really matters. We don't want to use polyfills for the rest of our lives, right? We don't want to drop in a needless library that we don't have to. And the notion that polyfills goes away over time is the promise of a polyfill. The other reason browser support really matters to me is because if you look today at all these libraries and frameworks, they all produce and allow developers to create components, but there's sort of no standard way to build the component. Some use a lot of JavaScript. Some use more HTML and JavaScript. Some just use a massive amount of HTML. So the goal of creating a tab strip is the same, right? You want to create a reusable tab strip, but the way you get there is very different across the board. And so that's what Web Components is here for. It's here to have a standard way to create reusable components. So a Web Component tab strip would look something like this. It would be declarative. It would be my-tabs. We'll just call it that. It's got a selected attribute that you can use to select the tab that should be selected. And it's got div for its content. It's got HTML attributes. It's very readable and very clear what's going on here. The other thing that people often forget about is the fact that it's just DOM and HTML that we're creating means we're integrated with the browser. We're integrated into the platform. So Rob mentioned all these great accessibility features that the browser and the HTML elements already give you. We're integrated with that. We can take advantage of what's already there and don't have to reinvent the wheel ourselves. And we're also integrated with every web developer's best friend, which is the DevTools. And I'll show you an example of this. This is Polymer's old site, and I'll just fire up the DevTools and show you what happens and how you can kind of debug a web component. So this is a tab, a selecting tab strip that we have for our code that you can kind of poke around, see the code, and then you see the live output on the right there. So I'm just going to open the DevTools, open the inspector, and immediately it's just DOM and HTML, so I can just poke around with the inspector, see what's going on, see how this custom element is built. You see that there's a shadow DOM attached to some of these elements. I can open up the console, and then I can start tweaking properties, DOM properties of this element, so I can change its selected property, and you can see it live update in the DOM. Since we're integrated with the platform in all ways, we can actually change CSS, right, and affect how this component looks just by changing the color of the text of one of its panels. I can discover it's got a panels property, and it's got an API. It's got methods, so things like updated panels, we can call that, and it does something. Who knows what it does, but we're discovering that in the DevTools. And it's got a bottom property. This one happens to actually change the way this thing renders. And by changing that, you can see the live DOM update. So this is really cool. And the fact that we're integrated with the tools and the platform means we can build apps even better. So for the rest of the presentation, I'm going to show a lot of code. Web Components is one of those things where it's a developer feature. It's for us. It's not a fancy feature like WebRTC or WebGL. So it's not sexy. It's actually for ergonomics. It's for you guys to produce reusable code. So let's dive in. Let's talk about custom elements. Custom elements is sort of the foundational piece of web components, and it allows you to create new HTML and tell the browser about that HTML. So let's build a button. There's no better way to actually learn this stuff than to actually build something, so we'll start simple. We'll build this very simple component, a button component. Now, if you probably know, right, HTML already has a button. But a lot of people have stopped using button over the years. It doesn't look that great. You know, it renders differently in different browsers. But it's got a lot of great built-in features, if you think about it, right? Rob talked about focusability and keyboard behavior. It's got that built in. When you tab into this thing, it actually highlights itself, and it has this effect, this gradient that it applies. It's got special properties to treat it like a button. It's got a disabled attribute that you can apply that actually affects the rendering of this element. And if you put this in a different context, if you put a button inside of a form, it actually does something different, right? It submits the form and participates in the form submission. So this is magical and kind of cool. We get all this stuff for free just by declaring this on the page. But of course, we want to create an even better button. We'll call it a fancy button that's got a nice little ripple animation when the user clicks on it. It's got a box shadow if you apply this raised attribute. And we can make this thing behave exactly like button. So I'm going to do what Rob told you not to do, which is create a div button. Don't do this. This is just building up the example. But this is the way you might start off with this, right? And you could start off by using button and then remove the default styles the browser applies. But we're just going to have a blank slate here. Create a div, give it a class better button, and essentially that class is just going to style this thing to look like a button. So it's got a box shadow, it's got some border radius, it handles disabled state if you have this disabled class on it. So we're just making a thing that looks like a button. But of course, if you want this thing to quack like a button, you have to do some things. So we'll add a tab index 0 and a role equals button. We'll actually tell the screen reader that this thing is going to be a button, and we'll allow users to keyboard into our button. And maybe, right, we want to have this ripple effect. That's the extra functionality we're adding to the button. So we'll rip the element out of the DOM and attach an event listener for that. And if the button isn't disabled, we'll allow people to click on it, and we'll draw the ripple animation. So very simple, not much going on here. But this has a couple problems. The first is that users have to know how to style this thing themselves. They have to kind of know all that magic that we gave them, put that on their page. And the second is that we have to add a click handler for all instances of the button that are used on the page. It's not very reusable. I can't really reuse this thing. Users have to add their own tab index equals 0 and a role equals button. It's not very component-y. So of course we can do better, and the answer is to use a custom element for this. We can create something that's reusable. So the first thing I've done here is just replace div with the name better-button. I'm creating a custom element, and custom elements have to have a dash in their name. That's just part of the specification. We are calling our button a better button. And instead of CSS classes to style this thing, I'm just going to use HTML attributes. It's a little cleaner to read, and it's going to map really well to the JavaScript properties we're going to define on this button. In my CSS, all I've done is just replace classes with that new tag name. Nothing's changed about the appearance of this thing. Of course, we can do even better. We can progressively enhance this markup from itself right now to something better. We can give it an API and use JavaScript to do that. And so the way you create a custom element is just define an ES6 class. We'll call it better button, and it's going to extend the browser's native HTML element. So it's going to gain all of the DOM API. And since we're creating a button, maybe you want to have a disable property, just like the normal HTML button has. So we can do that in ES6, just define a getter and a setter for disabled. And in this case, what I'm doing here is I'm keeping the attribute in sync with the JavaScript property. So if somebody changes the JavaScript property in JavaScript, we're going to actually reflect that value back out into HTML and set the attribute on the HTML tag in the live DOM. And other properties on the web today do this too. The hidden property, the ID property, if you set them in JavaScript, they'll actually update the markup as well. So we can do that in custom elements. Something else you can do is go the other way. So if somebody tweaks an attribute, you want to get a notification about that. You want to react to that. And so for that, there's two special things you can do in element code. The first is to define an observed attributes array. This is sort of a whitelist to say any attributes in this array I want to get a callback for. And so what the browser is going to do if it observes a change to one of these attributes is call it your attached attribute change callback. It's going to be provided the name, the old value, and the new value that the attribute is changed to. And here what I've done is basically just look at the disabled property when that happens and set a tab index and an ARIA disabled attribute accordingly. So we're kind of mimicking the button again by adding this functionality ourselves. Something else you can do is run code every time an instance or your element is created and declared on the page. So to do that, we'll just define a constructor. And the first thing you need to do in an element constructor is call super. That's just part of the spec. It needs to set up the prototype correctly. And then from there, you can put in whatever you want. So in our case, we're going to define a key down listener. We want to actually have when people press enter on our button to react to that, and that's what this code does. And then we'll add that click listener that actually adds the ripple animation. So if the button's not disabled, we'll allow people to click it and draw the ripple at the user's click location. We can also react to when our element is added to the DOM or removed from the DOM. And so for that, we can use the connected callback. This is a great time to do any setup work. In our case, we're adding the role for screen readers, and we're adding tab index 0 at that time. And disconnected, while we're not using it in this component, is actually very valuable for things like cleanup. So if you add a bunch of event listeners in your component or do other kinds of setup, you can remove it at this time. The browser will call that method. If you're curious on how draw ripple is implemented, it's pretty simple. This is the way I've chosen to implement it, just a div with a ripple class that styles this thing to look like a ripple effect. So it's a div with a border radius that kind of just grows and fades out. Pro tip, I'm using CSS containment here. We're creating a reusable component that's self-contained. Might as well tell the browser to optimize this for us so it knows to scope layout and paint. That's awesome. We can just basically drop that in our web components. And the other thing I want to point out about this code is I'm basically creating a declarative style API and providing a little bit of functionality and flexibility for this component. So if some user that uses better-button styles the color, the font text with red, we're basically styling that the same as the background ripple is going to be styled the same as the font color. So this is kind of cool. You can do these things in your components and document how this stuff works for users. Now we've got a component, we've defined its ES6 class. The last thing we need to do is actually tell the browser about this new element. And so the way you do that is to use the custom elements interface and call the define method. You pass it the tag that you want to create and the class definition that you just created. And then from there, the users can use this element as if it was a div or a span or any normal HTML element. They can declare it on their page, they can use the new operator in JavaScript with the element constructor, or they can call document create element. The same tricks apply that always apply to the web. So that's a lot of stuff, right? If you think about it, there's a lot of CSS involved to make it look like a button. We have a class that mimics all the behavior of button. And the last thing we do is have the registration. We actually tell the browser about our new element. We can do better. We can progressively enhance what's already available in the web platform. So again, we have a button already in HTML. Why are we reinventing the wheel? Why are we mimicking everything it does for us? Why don't we just progressively enhance the button element? Well, sure enough, we can do that. Custom elements allows you to extend HTML that's already existing in the web. So instead of extending the HTML element, we're going to extend the HTML button element. We're going to extend the specialized version of that element. And then what happens is this is our entire class definition. So all that work we had to do before with tab indexing and key down listeners, all of that stuff goes away because we get the DOM properties and methods that button has for us just for free. And then we add the extra functionality. In this case, it's that ripple animation with the click handler. So this is really convenient. This is called a customized built-in element. And the way someone declares this on their page is a bit different. So instead of using better-button, they're going to actually declare a button, and it's going to be an is better button. So this button is a better button. That's how that reads. So we've done a lot, right? We've made a custom element. It's reusable. It's a fancy button, a little sexier than the normal HTML button, but it's got all the benefits that the original one had in it. I want to take a little bit aside and talk about this call here. The notion that you call custom elements.define with the tag name, and you kind of upgrade the element. What's happening is what is called an element upgrade. This is part of the custom element spec. You kind of endow your markup with an API by defining some JavaScript that gives it its API and its methods and properties. So you take an HTML element and you make it something better. So the notion here is that custom elements are really just progressively enhanced markup. You're taking something that doesn't have any functionality and you're progressively enhancing it to have functionality. We've taken advantage of this notion of element upgrades on the developer's codelabs site. We built it in Polymer. And if you dissect this thing, you can actually see where the components live on the page. So our search bar is a component. Our sorting and filtering widgets are components. And also this main section in the center is a card sorting element that knows how to rearrange its children based on the user's sort and filtering. So that's how this thing is kind of structured. I want to show what happens when we load this page. I'm going to slow it down to a 3G connection so you can really see the effect. So we'll navigate to the page, and instantaneously it paints. The browser, it turns out, is really good at just painting pixels, HTML, CSS, very small payload. And then eventually what happens is the components fade in. We'll see that one more time because it was kind of fast. So first paint is really fast, and then as the components upgrade and get their supercharged API, they fade in asynchronously. So it turns out this is really fast. I clocked this at about 2.2 seconds for a first paint on a Nexus 5 3G connection. And of course, this would get even faster with a service worker if we had caching and the user came back to the site. So the way you do this is to use another feature of custom elements. It's the CSS:define. So you can basically pre-style elements before they're ready, before they get their JavaScript API, and you call custom elements.define. So in our case, I'm styling that paper tabs, that selecting widget, basically giving it a little layout, giving it initial height to kind of replicate the styles that paper tabs defines in it. And I'm also just hiding it, right? On page load, it's just hidden, and then when the browser removes this defined pseudo-class, our element will transition in. So the effect is that these things kind of just take up placeholders, and you see them just fade in when they're ready. The rest of the page is very simple, just a little bit of markup at the top to describe the website. We have that sorting and filtering section. That's got some custom elements in it, the paper tabs element. And the main bulk of that intersection is this card sorting element. It's just a custom element. It's on the page, ready to go. Everything's server-side rendered, so all these links just show up on page load, and they're styled to look like a CodeLab card. So this is great. This paints really fast. The content's there, available to users. They can start reading it right away. And then eventually, at some point in the future, we actually register these elements in the browser. And at that point, that's when the card sorting element gets its API, it gets its filtering API, and its sorting API. That's not critical on page load, so it's a great story for progressive enhancement. So let's think about what we've done so far. In a very short period of time, we've created a reusable component. It's got custom elements API. It's got reusable styles. If you drill down into the dev tools, you can actually see a problem, though. One of the implementation details is kind of leaking, right? This ripple div that we're creating dynamically is kind of mucking with the user's DOM. It's taking up space. It's implementation detail, they really shouldn't see that. We can fix that. The answer here is to use another part of the web components, which is shadow DOM. So if you think about today's elements, there's the select element, right? And you drop a couple of option tags in it, give one of them the selected attribute, and somehow the browser magically knows to render this thing as a drop-down widget and select the correct element. That's kind of cool. If you add the multiple attribute to this HTML element, it completely changes the way it looks. So instead of a drop-down, you get this multi-select widget. Pretty magical. The video element, couple of attributes on the single tag. You get an auto-playing video with video controls for free. Where did these UI controls come from? And input type equals date, or any of the various specialized versions of input are pretty cool. Instead of a text box, right, text input, you get a UI that allows you to select a date. So this, my friends, is Shadow DOM. Shadow DOM allows us to do the same thing the native browser vendors have been using for a long time. They use Shadow DOM to create these widgets and hide away markup and CSS. We can do that inside of our component as well. So in order to use Shadow DOM inside of a custom element, it's just 1 or 2 lines. So inside of the element constructor, we can call this.attachShadow. That's going to create a document fragment, a shadow root that's going to kind of attach itself to our element. And we can fill that document fragment with anything we want, any markup you want. In our case, we're bringing in those styles from the page, so users don't have to define them themselves. This is great because styles inside of Shadow DOM are scoped to your element. So that means styles and selectors aren't going to bleed out into the page, and page styles aren't going to bleed into your component. So that's why you see I've replaced some of the selectors here. I've changed better-button to use :host. That's the way you style the element itself inside of Shadow DOM. And my selector for the ripple div has gotten simpler. We're just using .ripple now. And that's because, again, these styles are scoped. We can use common IDs again. We can use common class names again. They're not going to collide with the main page because we're inside of Shadow DOM, which has this scoping for us. And the last thing you see is I've moved in this ripple div. It's become part of kind of the implementation detail of my component. Users are not going to see this inside of their DOM. So let's take a look at this. When you do this, when you call this attach shadow root, what happens is that you get a shadow root attached to your better button. That's great. We have Shadow DOM in the works. And you can see that we have the styles scoped to this element. You can see the actual style information. This thing looks like the button, but it's actually lost something. It's lost that fancy button text that we have and that users have declared. And so the reason for this is that Shadow DOM is kind of like a party. You have to invite things into it. You have to invite things in the outside world to render inside of your Shadow DOM. For this, you use composition with the slot element. Slot's another element that's part of Shadow DOM that you can use for bringing those things into your Shadow DOM. So let's say I have a Shadow DOM that looks like this. I have style information and a slot element. What's going to happen here is that when someone declares a better button on their page, fancy button text is going to get projected into this slot. It's going to render at that location inside of my Shadow DOM. And the effect is that you get the text back. That's exactly what we want. You can also have default content. So if someone doesn't provide the text themselves when they use our component, you can render just button as the default text. And you can have an entire DOM tree in here if you wish. It doesn't have to just be text. And there's also a more advanced form. It's called name slots. So we can have as many slots in your component, in your Shadow DOM as you want. In this case, we're defining a slot with the name equals icon and a default slot that doesn't have a name. When someone uses our button like this, maybe they want to have a little gear icon next to some text. What's going to happen is that the name slot is going to get projected into that location. It's going to render in that slot, and the settings text is going to render in the other slot because it's not using a name. The effect is exactly what you'd expect, which is that gear icon and a settings text. So I think of composition, I think of the slot element as kind of a declarative API for your element. It's a way to really provide a level of functionality and customization. And this is exactly what the select element and those other native elements are doing, allowing for you to configure their UI based on attributes. But let's say somebody wanted to use our button like this. They want a ginormous pink button with a lot of padding and a different ripple color. Well, since we brought the styles into our component, how do you actually allow for this type of customization? The answer here is to use another new web platform feature, which is CSS custom properties, essentially CSS variables. So what we can do inside of our Shadow DOM CSS is basically have placeholders for users to fill, if they want, if they so choose. Support for this is really good right now, actually. Everyone but Edge has this available as a native feature. So when someone uses your custom element, they define some CSS for better button. They can fill in the values if they so choose. So they'll define, in this case, they're defining the button padding, and they're defining the size of that ripple animation we're going to create. And so in this case, we'll use those values, but if they didn't provide them, again, we'll just use our defaults that we set up ourselves. So CSS custom properties is a great way to have like placeholders and allow people to customize your component and the styling of your internal elements in your component. So that was fast. Let's recap what we did. In a very short period of time, in less than 30 minutes, we created a reusable button. It's progressively enhanced from the native HTML button, which means we have all the benefits that the browser and that element already gives us. It's got keyboard behavior, all the stuff that Rob talked about baked in. It's self-contained using DOM and CSS scoping of Shadow DOM. It has an imperative API, a JavaScript API, thanks to custom elements. It's got a declarative API, thanks to composition and the slot element in Shadow DOM. And it's also configurable, so we can have people can use it in different ways with HTML, and they can also configure the CSS. That's pretty cool. So this is why I'm so excited about web components, because it allows for this flexibility, allows for the good reuse on the web again. And this is just a button. You can imagine building an entire app out of components. If you don't want to get started, so if you do want to get started, go back, you can actually check out and try to use some web components yourselves. So Polymer has put together a really awesome set of reusable and very useful components for different types of things. And there's also customelements.io that has a list of web components you can check out. So with that, that's all the time I have. Again, this is me on Twitter if you want to hit me up with questions. I think now we're going to transition to a break. We're going to take 20 minutes because those guys went over. But I really do appreciate you guys sticking around. Thanks for your time. Go componentize the web.
So, welcome to Total Tooling Tips. This is an episode on DevTools where we're going to talk about our newer progressive web app tooling.
Yeah, so the reason we have to do this is we recorded an entire video episode and then everything changed.
It's Tuesday, so DevTools has changed. Right, so the resources panel has now been replaced by the shiny new application panel. So I'm currently on Progressive Web App. This is smaller pictures, and some of the newer stuff that we let you preview include like your web app manifest.
Yeah, so basically Web App Manifest is kind of, if you've ever built web apps so you've had to do icons for different devices and browsers and you had to put in lots of link tags, Manifest is a JSON file where you can put all of that stuff in one separate resource and the browser will only go and grab it when it needs it.
Yep, so we summarize everything from like your name, your short name, through the different theme colors and background colors that you're using. We show you your orientation chosen in your manifest file, and then just like preview all of the different icon sizes you might have set up. So I've got like all of them because I'm crazy.
You are crazy.
I am crazy. It also lets you emulate as a home screen if you click on this little link here. That's just like the experience where it'll show you, okay, well, what do you want to name this thing?
So the reason this is important is because whenever you click on Add to Home Screen, what it will do is it will go through all of the criteria that Chrome looks for to basically decide whether it's going to show the user the banner or not. So it'll be things like, does the web app have a service worker? Does it have a short name? Does it have theme color? And if any of those criteria aren't met, it will print out an error to the console just saying, yep, you need to have this, and because it's not there, I can't do Add to Home Screen.
Cool. So the next thing we're going to take a look at is the service worker panel. So debugging service worker has been like historically really, really painful. And I think DevTools has nicely evolved over time to make that experience a little bit sweeter.
Yeah, this is definitely like the best version of it. It's just really hard when you're starting out to understand what is going on when you're doing this stuff for the first time. But I think this is definitely like the nicest version so far.
Yeah, so we're going to quickly walk through all the options here. So the first one is an offline checkbox. And basically, if we go and we refresh, you'll see that the app is working offline. This just emulates offline in the same way that the network throttling dropdown will let you do.
Nice.
Fairly useful when you're testing offline support with Service Worker. The next option is Update on Reload, which forces your Service Worker script to update on refresh.
So the reason this is super handy is before this existed, what you'd have to do is you'd make an edit to your Service Worker, you'd save it, you'd go back into your browser, you'd refresh, And once you've refreshed the page, it will still be using the old service worker because your new service worker will be grabbed by the browser. It will go through an install step, and the new service worker can't take over the page until the old one's gone. So when you check update on reload, what it's doing is it will unregister the old service worker, register the new one, and once the new one's ready to go, it will refresh the page. So then the page is using the new service worker. So it's one checkbox, so there's kind of a lot of stuff going on behind the scenes, and it's super useful.
Next up, we've got bypass for network, which will bypass your service worker script and load resources from the network.
The reason this is handy is when you're not working on a service worker and you're working on other files, you don't want anything to be pulled from the cache. You just want to be using the files that you've just changed.
Yep. Then we've got show all, and show all will basically show you every single service worker that's registered. Because we've got like an increasing number of sites and apps using this, you might find this a little bit noisy.
I'd just say you're very unlikely to ever want this until something like foreign service workers come in, but
yeah, we're just letting you know that it exists today, unless they change it tomorrow. But it's here today, at least. What else does this let you do? Okay, so you can update your service worker. There's a push option as well. What does that do? Let's head over to your demo.
I'm going to guess it's going to do something with push messages.
You're so bright, Matthew. Right, so this is a push demo Matt wrote a while back. We're going to go and we're going to enable push notifications, and your demo worked this time. Yes. Right, so what we're going to do is if we click push, it's going to emulate a push event, and you'll see that we get a push notification.
This is kind of interesting because this is the first time I've actually seen or like tested this myself in Canary, and they basically added a new feature where it's populating a little bit of data in there, which is kind of super interesting. Slightly weird with the fact that you can't determine what the data is, but it's awesome that it's there because it does mean that if you wanted to check what data would look like when it comes in your service worker, it's now something's there. It's awesome.
Sweet. And what happens if we click send a push via XHR? Does anything happen?
It should do.
It should do. Did I actually? Oh, I didn't. There we go.
Oh no, you did. GCM just took a while to kick in.
Okay.
So there, because there's no data, it's just like a super generic, hey, thanks for sending this message.
Sweet. You can also go and click on the little name. Oh, you've got a minified service worker.
Yeah, man.
What do you do? Okay, let's go to someone who hasn't done that. And if we click on source, you can go and you can check out the source to your service worker.
He just doesn't care about users' data. That's offensive. So the reason this is actually super cool is the fact that you can now add breakpoints to your service worker like you would any normal JavaScript file. So when that code gets executed in the service worker, it will actually stop the service worker from running, and you can start debugging stuff like you normally would with DevTools, which is nice.
Sweet. You can also, so you can see that we've got like these activity indicators for the status. So green means that something is active and it's running. You can stop your service worker, so we can go and do that. They'll say activated and stopped. You can focus your clients, so we're currently focused. You can also hit details, and it'll show you in line any of the exceptions or error messages you've been getting.
So the one thing that used to exist here that's been removed is you used to be able to have like an inspect button that you would click and it would open up an entirely different dev tools just for service worker. I still kind of like having the two dev tools, one for the page, one for service worker, but I think the dev tools team are trying to get everyone to work just out of the one dev tools and change different contexts. So in this case, all the service worker logs would show up in the one console and you select different frames within that. So it's kind of interesting. It's the only thing that I'm anxious about, I guess. But this is quite a nice way of at least servicing just the errors.
Because I'm ADD, I'm just going to click clear, and now all of our problems have gone. It's great.
If only life was that simple.
If only life was that simple. Clear storage is basically the best thing ever. If you're developing any non-trivial progressive web app and you're trying to support offline with service workers, you're maybe using a storage mechanism like IndexedDB or local storage or session storage, you've probably run into the situation where you need to manually go in and clear all of your different storage mechanisms out and then head to different panels to unregister service workers, and it's this whole super tedious thing.
Yeah, I've ended up writing helper scripts that I just drop into the console to delete everything. It's annoying when you get to that point.
So in an effort to make Matt Gaunt redundant, there's now like a clear site.
Well, that escalated quickly.
There's now a clear site data button. I think the label for this might be changing, but the button is still there. Basically, what this does is it almost resets the world for you, which is kind of really nice.
Yeah.
It does all the things it says above, like it will unregister your service workers and your storage and clear out your cache API storage.
And yeah, this does seem like an obvious feature, but at the same time, it hasn't existed for the longest time. Yeah. And when you start working with service workers, you realize how quickly you just get into a mess and you just want to reset everything. And the old solution for that was to just develop in incognito windows. Yeah. So this is super welcome.
Yeah, this is so nice. We were talking about cache storage because this was resources panel. You can still go in and debug all of your different storage mechanisms. That includes the cache API. So in the case of my app, I'm using SW precache, so I have all of these entries. For someone like Paul Lewis's voice memos app, we go in here and you'll just see that there's an entry that's got all the different files listed that he's got cached in the cache API.
I wonder why the response is empty.
It's all perfect. It's all perfectly perfect. And you've also got other options in here like frames.
Don't just say that like it is. No one knows what frames is.
I don't know what this does anymore. It's basically got a breakdown of different things.
It looks like a list of assets that are
different
downloaded.
Assets. Let's assume that it does that. Maybe this gives us something to do another episode on.
Next week on Totally Tolling Mini Tips. What is frames under Applications tab?
All right, so I feel enlightened. That is the application tab. Is there anything we're forgetting?
You got device art on the screenshot that is also new.
I've got device art. So Canary DevTools now lets you preview device art for a few different devices. So we got the Nexus 5X in there. I think the 6 might also have device art. It does not. It does in the very, very latest version, I think.
Okay. So it's coming.
I think it's coming. But basically, device art is awesome. Just lets you see what it would maybe look like on an actual device.
And it adds in the navigation bar at the top and
yeah. So you can
stuff.
you can go in. You can go in here and get your little navigation bar in. I have asked for us to take the theme color into account.
Oh yeah.
'Cause you could do that.
Yeah, that'd be really nice, and then it'll
Assume that by the time you've seen this, maybe we've convinced them, and this is already out to date.
And if not, raise issues, and then maybe we can get it.
All right, so that is the application tab. Hopefully, you'll find that a lot of this stuff makes it a lot easier to develop and debug your progressive web apps. That's it from us.
Thanks for listening.
Bye.
Welcome to this supercharged TLDW. I'm Paul. If you didn't catch the live stream with me and Surma last week, well, basically we built a side nav. Let me show you what we built. So you've got your standard app bar here. You can click on this sidebar and you can click on the background, or you can dismiss it with a sort of drag gesture like that. Awesome stuff. So let me show you how we built it. But before we do that, as usual, we're going to head over to, yep, you guessed it, Theory Corner. Join me. Hello, welcome back to Theory Corner. So this is what we've got. We've got our page and we've got a container element. The container element is going to be the home for the side nav and the background. What we're going to do, first of all, is we're going to put overflow hidden on this. We're going to make it take up 100% width and height. So it's got overflow hidden because this is going to transform out to the side and we don't want any scroll bars. So we put that in place. The background, we're just going to transition its opacity from 0 up to 1, and we'll set it to have a transparent black color, or semi-transparent black color in the background. The other thing is this side nav. We want this to slide in from the side, so we need to have will change transform on it so that it gets its own layer, very much like we did with the swipeable cards, and then we can transform it in and out. We're also going to need some buttons for bringing it in and out, and we're going to have some touch events so that we can do the dragging stuff. All cool? Let's go back to reality. Welcome back to reality. Oh yes, yes, reality. That's where you'll find us today. Pragmatic to the end. Code. Okay, so the markup and the CSS is pretty much what we discussed in Theory Corner. We've got an aside, we've got a few JS classes here so that we can pick it up in the JavaScript, but mostly it's pretty much what you'd expect. There's a button for closing, there's a button for opening, we've got a title here for the side nav, and then we've got the list of the side nav content. In terms of the CSS, here's what we've got for the background. You can see it's actually done with a before pseudo element, and you can see that it's got a background of black with an opacity of 0.4. We've switched on will change opacity because we know we're going to be changing the opacity, so we're going to say will change opacity. Didn't say will change pasty. That would be a different thing entirely. We'll change opacity, and then we can set a transition of opacity with that curve. That looks quite nice. 0.3 seconds, nice and quick. Then the other thing is when we set the side nav to visible, which we're going to do with some JavaScript, and we can say to that before that we want you to fade up from an opacity of 0 to an opacity of 1. The same is pretty much true of the side nav itself. Here it is. And you see it's got a box shadow, so we got a nice little bit of shadow on the side. The interesting thing is we have to transform it by, in my case, 102%, which sounds really odd, but the reason is there's that shadow. And if you just transform it 100% to the left, you still see a little bit of shadow on the left-hand side. So we've just taken it a little bit further, solves that problem. The interesting thing about the side nav itself, the one that comes in from the side, is that it has a separate animatable class. The reason is I want to switch that off when they're doing the drag motion and have it on when they're doing the automated transition from the side in and out. So we use this class to basically say this is kind of, it's doing the automatic transition, or when it's off, it's going to be used for the dragging. Cool. The JavaScript is over here. And it's the same trick as last time, a bunch of event handlers that we bind on with this. If you haven't seen why I do that, go back and watch the Swipeable Cards TLDW explain pretty much why I do this approach to my event handlers. You don't have to take this approach, but it works pretty well for what I'm doing. So we bind all those on, and you can see here we've got the show and the hide. Now here's an interesting one. I actually say that if you click on the side nav, the containing element, the container from Theory Corner, I want you to hide the side nav. Well, that will work, kinda, but then if you click on something inside the side nav, well, that's kind of weird because you clicked on something in the side nav and it's going to dismiss. And the way we get around that is we basically say the side nav itself, that's going to hide it, but any clicks inside, we're going to call this block clicks function, which you can find down here. And block clicks, all that does is stops the propagation. So it's almost like canceling the event. Now, you don't want to do this all the time. You only want to do it when it makes sense for your app, and it makes sense in my case, I think. So that's all good. So I think all that's really left is to just have a quick look at that drag motion. Now, if you remember, the drag motion looks like this. We can click and we can drag, and if we just come away from the side a little bit and let go, it dismisses the side nav. So let's see how we code that in. Well, we have our on-touch start here. And basically, because this is bound to the document, I basically say if the side nav isn't open, bail. Don't hang around. So we're going to call this anytime somebody hits touch start, but we only want to deal with this if the side nav happens to be open. And what we do, very much the same kind of deal as the swipeable cards. We capture the start position and we copy that across to a current position. And then in the touch move, we basically figure out how far we've moved, and then we can apply a transform in a kind of game loop and update function, which you can see here. There's the translate, current minus start, and then we apply it as a transform. If you've seen swipeable cards, this is all sounding very familiar, I'm sure, but it works, and it works really well. The last thing is, on touch end, we basically say, if you've translated just a little bit to the left, hide the side nav. That works out really well for us. One other little thing to note is this. In terms of the on-touch move, by default, you'll get that throttled back in Chrome. So you won't get them every frame unless the very first touch move event has an event.prevent default on it. So what we do is we calculate the translate, and we say if it's less than 0, as in you've started to move it, we prevent the default, and that means it will get all the updates from then on. So there you have it. That's the side nav. Pretty straightforward in terms of these things, but this works really well. It works at 60 frames a second, even on a mobile device. If you haven't caught the live stream, again, it's about an hour long. It's in the description below, so have a look through there and have a watch of that if you've got a spare hour. Again, it's usual kind of stuff. You see all the bugs, you see all the chat, you see all the discoveries and the kind of discussion that Surma and I had. Don't forget to subscribe. Done. And I'll catch you next time. If you, like me, like clicking on things, you can go, okay, hit the subscribe. And there's the live stream.
Hey folks, welcome to Totally Tooling Tips Season 3.
Come check us out. We're going to be talking about progressive web apps, some of the tooling around them.
On first visit, we've got a relatively fast time to first meaningful paint. Module bundling, accessibility. Do you know what the top 4 things to look at when it comes to web accessibility are?
No, I can only think of 2. Like, I only think of audio and then visual.
So there's visual, hearing, mobility, and cognition.
The first episode will be out on April the 27th, so subscribe to the YouTube channel, check out season 1 and 2 before season 3 starts, which will be happening soon.
We promise that season 3 is going to be equally as mediocre as seasons 1 and 2.
Chrome 51 makes it easy to know when an element enters or exits the viewport with intersection observers. You can make the sign-in process way easier with the new Credential Management API, and you can reduce jank with passive event listeners. I'm Pete LePage. Let's dive in and see what's new for developers in Chrome 51. Intersection observers let you know when an observed element enters or exits the browser's viewport. No more jank-inducing calls to get bounding client rect or listening for scroll events. To use, simply create a new intersection observer, provide a callback and an options object. Then tell the observer which elements to watch. Boom! When the element enters or exits the viewport, the callback is fired. Check the description below for a link to a demo, browser support, and more. Creating, remembering, and typing passwords is a pain in the neck, especially on mobile. Chrome 51 supports the Credential Management API, a new W3C spec that allows your site to interact with the browser's credential manager and federated account services like Google and Facebook, improving the login experience. The API has 3 key methods: navigator.credentials.get to get the user's credentials and initiate a sign-in flow, store to save the user's credentials in the credential manager, and require user mediation to disable automatic sign-in. There's more info about the Credential Management API, including a demo and links to the docs below. Did you know that simply adding an empty touch event handler to a page can make scrolling janky? Less than 20% of touch events call prevent default, canceling the scroll. But because the browser doesn't know if it'll be called or not, it has to wait for the JavaScript to finish. Chrome 51 adds support for passive event listeners, allowing you to declare that an event listener won't prevent a scroll, making it easier to eliminate jank. These are just a few of the changes in Chrome 51 for developers. Check the description for more details. And be sure to like and subscribe so that as soon as Chrome 52 is released, you'll know what's new in Chrome.
So here we are next to a rainy river, our natural environment for working on code.
Yep, and this one's going to be on DevTools, so it's DevTools, rain, and boats.
Nothing synthetic about this in the slightest. Right, so today we're talking about responsive toolbar. Now, for a while in DevTools, we've had device mode, which has been useful for like building responsive sites. This is sort of an evolution of that tooling. So some of the new things we've added are support for this little toolbar that lets you toggle between like different mobile sizes, like medium, large, tablet, desktop. But we've also improved device emulation. So if we switch over to Nexus 5X, for example, you now get a little bit of device artwork from Android showing on the top and the bottom.
Yeah, and then they've added an extra little drop down where you can then say you want portrait with a navigation bar, which is like Chrome's URL bar. But you can also do portrait and landscape with keyboard as well, which is kind of nice, especially if you're doing like form input, just to see how it renders. Nice little step up as well.
That's kind of cool. You also have a drop down for being able to say, you know, how much of the viewport you want to occupy for your actual device preview. And we've got this little menu with a few extra options in here. So one of the things that you might have tried out before is the show media queries option. Super useful. It basically like parses out the media queries in your page, and you can just see what your page looks like at different media query breakpoints.
I already have some beef with this because if you try and use it as is after you've selected a device, it does nothing. But if you go to the responsive mode and drop down and then click on it, then it starts working.
What are you talking about, Matt? It's all perfect. It's all perfect.
No, it needs an issue.
Okay, you file a bug on that.
Yep.
Other things that we include in here include show device pixel ratio, so you can switch up your device pixel ratio settings. Another thing that I usually have on is network throttling. So if you're building to be resilient against like really flaky network conditions or Wi-Fi or anything like that, network throttling can be useful to toggle on. Usually you can have on like a good like 3G or 2G setting, and that just means that when you're loading up your page, we're going to throttle that connection, and it'll load up a little bit more slowly than it normally would.
It's kind of nice just having that there, because otherwise you bury it in the network thing. It's way too easy to leave it on some random setting, start looking at the elements, fixing other problems. It's nice just having it constantly there in the responsive mode.
You can also, like, let's say you're building an app, like a progressive web application, and you've got service worker support. You can also switch on offline to try out your service worker and just make sure it's working well offline.
It would be great if there was just like one button, like disable internet.
Yeah,
just the airplane icon. That's all you need. Done.
Folks were asking about ruler support, so we've got a show rulers option there. Wasn't there before, it's now back. You can check that out if you like rulers. Some of the newer stuff that we've been playing with are the ability to trigger add to home screen. So let's say you wanted to emulate your web application manifest experience. You can click trigger add to home screen. It'll bring up this message at the very top that says, add this site to your shelf to use it any time. You can click add, and it'll bring up a little prompt that says, okay, well, what do you want to customize the name of this thing to? And the idea behind this is that it's supposed to just emulate that add to home screen experience you get on Android.
Yeah, and it was kind of annoying because before you'd have to do it on your phone, you need something to download the manifest file, and normally the reason you'd want to do that is because if there's a problem in your manifest file and Chrome wasn't happy, it wouldn't pass it, and it's just tricky to debug. So having this hard way of just saying go and download it and pass it is insanely helpful when you just do it.
As a reminder, we also have another little panel called sensors, which lets you go and emulate different sensors. So you can emulate geolocation coordinates, device orientation, and you can decide whether or not you want to emulate touch based on your device or whether you want to do force touch, force enabled. Yeah, that's about it for the responsive toolbar and the new device mode.
Yeah.
Hello and welcome to Supercharged. Now this is a kind of TLDW. Last week I did a live stream with Surma where we made some swipeable cards. Now you probably recognize swipeable cards from things like Google Now, where you just kind of take a card and you dismiss it. And you can actually see what I've got on screen. This is what we ended up making. There you go, you see? Dismiss it and all that kind of good stuff. Now the idea is, if you've not got an hour to watch that live stream back, although if you can, I would recommend it, and you can find the link to that below. If you can't, that's exactly what this is for. I want to step through the things that we learned, the things that we did, and just so you can get an insight into what actually went into it. So, before we actually get started, what I want to do is I want to step over to Theory Corner. Oh yeah, theory. Love theory. And what we can do in Theory Corner is discuss what we need to do. Join me. Welcome to Theory Corner. You can tell it's Theory Corner because there's some theory in a corner. Now, this is what we have. We've got the cards. You can tell it's a card because it says card. The cards have will change transform on it. The idea I have here is that we want each card to be
People never get that excited for my talks, so just cool. How's everyone doing? Are we good? Yeah, cool, great. I was thinking about kind of how I was going to start this whole presentation off, and I'm terrible at starting presentations, so just be warned. But I was thinking about kind of like the structure of the entire day, right? And progressive web apps and how we think progressive web apps fit into the overall, like kind of the way that we think developers should be building or you should be building for the web in the future. And the one thing I was thinking about was every single one of these things that we've talked about in isolation is a great thing for you to be able to kind of take home and kind of work on, for instance. So if you're not interested in necessarily progressive web apps right now, but you want to build a great user experience for your users, then like Paul's talk around user experience on that side of things is great. Same with like HTTP2 and SSL. Like we want to make the web more secure. We want to make the web faster on the networking side of things. Like all those things individually will be a great thing for your business and your services and your sites. But kind of putting them all together, like we think that that's where like the progressive kind of web app part kind of comes together. And I think like what we're trying to get to with this is like, this is my talk, by the way, like putting the progressive into progressive web apps. I'm kind of worried about this a little bit because like there's a lot of tension between what progressive actually means in terms of progressive web applications. And one of the things, and right there, I was going to talk about, is that when in the research that I was doing for this talk, I was going back to when we first kind of thought about progressive web apps and when it was first kind of talked about, and it was Alex Russell, and it was on his site, and it was literally a year ago to this month that they coined this term with his wife, Frances Berryman, progressive web apps and progressive open web apps. And when you read the article, it's really interesting, right? Because it starts off with this whole idea of as the user uses the experience more, it becomes more progressively installed on your system, which is not necessarily the same thing as like progressive enhancement, which is a very important thing that we want to kind of cover on the web. There was we did talk about it a little bit. The idea behind it is that when you integrate a service worker and you can start intercepting the network requests, you actually, you progressively enhance the network. You get more speed for essentially for free at that point. And I think that's actually quite an interesting way to think about it, right? Is because we talk about the progressive kind of installable nature. If you want push notifications, you don't have to install an application to be able to do that. You can start to get these experiences. If you want them to work offline and be resilient and available, you can integrate a service worker, make them work offline. But you don't necessarily have to have them installed on the system, right? Your web application, your website is just better by having these features in there. But at the same time, we know that progressive enhancement is important because we want these experiences to work in every single browser. Like whether you have service worker or not, whether you have JavaScript enabled or not, it's an important and critical point and part of the whole progressive web app experience is that these things work everywhere. And when we talk to a lot of developers around kind of what progressive web applications mean, is like, hey, we got service worker, we can make it work offline, and everyone always asks, does it work on iOS? Right? It's not like, does it work in Opera Mini, or unfortunately, it's like, it's great that it's on Chrome for Android, but like, does it work on iOS? And I think that's the wrong question that people ask. It's the wrong kind of the concept that they go into, because our whole idea behind progressive web applications is that your application should work really well everywhere. It should excel when you've got the ability to use something like service worker. And like the interesting thing is like iOS has got a lot of users, and those users pay, they apparently buy a lot of things, which is kind of interesting. But I think it's about 10 or 15% market share. But like if you look at it, like it's not one browser that's like hugely dominant. There's lots of different browsers used by lots of different people. You go to different parts of the world, and Tal Oppenheimer is going to talk about that later. Different browsers like UC Mini, for instance, are incredibly popular. Well, UC browser in particular are incredibly popular. And we as developers, are we building for them all the time? And I don't think we are building progressively across the entire platform to cater for every single type of mobile user that's out there at the moment, or desktop user. And I went through this same experience, right? I went through airhorner.com. Like, this is my site. Jake's got a very rude word about this, what it looks like, but I'm not going to talk about it. But Airhorner is a site that, it's a simple air horn, right? It's a very kind of small concept demo about what a progressive web application should be. And I started off building it on desktop, right? I was like, this is going to be really easy, right? I can make this experience work everywhere, and it's going to be instantly accessible, and it's going to destroy the entire App Store model, because like the App Stores are littered with these kind of air horners experiences. Like, go to the URL, enter the, go to the URL, start using it. You never need to download another app again. That was my thought, at least, anyway. And hey, heard it. Who's got it? So like it was kind of interesting model, right? I started off on desktop, and then I was like, well, I can make it like Chrome on Android is pretty good. I can make it mobile. Got it working on mobile pretty well. Used a bit of Flexbox. Brilliant, right? Worked great. And then because like WebKit and Blink at the time on Chrome, and you know, they're not too dissimilar, they support web audio and all the different APIs. Worked on iOS, it was great. And then I thought like UC browser is like iOS at this point, so I was like, that's great. And then last week someone said, doesn't work on UC, right? And I was like, what? Of course it works on UC, I made it, right? I'm not like completely stupid. Anyway, you get to the page, it's like that. Like the really interesting thing is when you start to look at the stats, is like 20% of the potential user base, especially on mobile, like India is a massive place, China is a massive place as well in terms of usage of this browser. Like 20% of the users couldn't use my site. They couldn't even see a single thing, right? Like I've looked at the stats. UC browser users come in, they bounce out pretty much straight away because it's completely useless for them. Hey, that's also the sign for me to get off stage as well, by the way. I haven't run over. So that's pretty cool. And then I was like, okay, cool. I'll see what it's like in a Lynx browser. Again, right, it's like there's literally no content. That button isn't the actual button for the experience that I have. Like it's not you press the air horn and it kind of downloads a WAV file or something. Like there's an install button that's hidden behind the scenes, and it's like, I just made a lot of decisions in the wrong way. And the thing I did that wasn't the greatest thing was I kind of targeted it off one API, right? It's like the audio API is the thing that I was building my experience around. And for me, like I said, it's a very small application. It's not probably like any of the applications that you're building today on the web. But it was a really bad thing for me is because I was like, audio API has got pretty good support. And I'm kind of happy with that. And I was like, okay, cool. But then I looked at the profile of my users. And it turns out, like, this is kind of iwanttouse.com, which is a site that I made. But it's all backed by the can I use data. And the idea behind it was that you choose a feature and go, okay, I want to use audio, like what features do I get for free? I mean, you know, use web audio API, you might get kind of like CSS fonts and a whole bunch of other stuff, which I can integrate into my app. And I chose this as the model for how I was going to build the experience. And I think that was a really bad way of actually starting to build my site at the time. Like, the thing I want to try and get across at this point, at least anyway, is the fact that I started off with the technology. It was a demo application. I started like, I'm going to use the web audio API because I have this thing where you press the button and you can hold it and it air horns forever and ever and ever. And I didn't actually start with the experience that I wanted to build. I did actually want my site to work everywhere for by every single user on any different browser. But I just made this kind of decision. And like, this is what I see when we're building kind of new web experiences, whether they're progressive web applications or just good web experiences. We go, I want to use this experience, but it needs Service Worker. Well, you don't actually need Service Worker for every single experience that you want to build, but when you do integrate it in, like, you get a better experience for users who have those browsers. And I think it's more about the features that you want to build into your, or the experience that you want to build rather than just the features. So like, you want to build a great mobile website. Like, I should have, in my, my experience, I should have like, well, I'm going to back it off the audio element, which will then allow me to play in pretty much every single browser. And then I just won't have all the same experience inside the site. So I should have started with that whole kind of experiential kind of focus rather than the ability to actually go, okay, I can do something fancy with a web audio API. I haven't changed it. And I think like when, like one of the things I was thinking about, and when I was especially looking at Tao's keynote earlier on today, is that the progressive web app model themselves as well is, it's more of just a way of thinking about how you potentially architect and construct your applications than the necessary kind of individual different APIs behind it. And I think like AliExpress is a good example. They chose to go mobile only rather than kind of have a complete desktop solution. But they chose to pick off this kind of tactical battle first, right? And I think that's a good experience where they followed the kind of progressive web app model, and then they found out that all their users benefited because they were building a good web experience that just so happened to work even better in the browsers that support Service Worker, whether it's Firefox, Samsung, or whether it's Chrome as well. And soon to be Edge and a bunch of other ones, I suppose. But like, that's the thing is, like, they got more users coming through, spending more money and a whole bunch of other stuff because they built a good web experience that was kind of, in theory, kind of progressive from the start rather than just focusing on, hey, this experience is a progressive web app that needs to use a Service Worker and go from there, which I think is the wrong way of looking at it, and they did the right thing. So I think I'm probably preaching to the choir at this point, but like, the interesting thing for me when I speak to a lot of people is understanding what progressive means. And the dictionary definition, and I've got it exactly what it is here, is like developing in stages, right? It's like the idea of you can do things in multiple steps and build on top of them as you go along, which is a decent way of thinking about like progressive web development as a whole. Now, the way that we kind of start to think, well, the way I at least start to think about breaking it down is like, I do want these experiences to work in every browser. Sometimes as a pragmatic developer, I have to target different kinds of experiences to different developers or different browsers at least. But my whole kind of fundamental thing is I want to get the experience out to as many people as possible and not block on, you know, whatever browser the user is using, because in most cases, the things that I'm building shouldn't be blocked on the fact that, you know, an API doesn't support web audio because audio can be played on the web. It's a good example. Now, again, with the air horn example, I didn't do the incremental approach to the APIs, right? I just relied on Web Audio API in this case. And if I was thinking about it again, I'd probably go back from the start. And then whether you have the diverse set of users, like the importance behind why you would do progressive enhancement is because you have users from all over the globe, and Tal will talk about this later, all over the globe using every single different type of browser that you can possibly think of. So you have to build these experiences catering for the fact that you have a potentially wide and diverse set of users. Now, there is this kind of, you've probably seen this before in the past, there's an illustration by Dave Stewart, at least anyway, but like the core fundamental tenet from the progressive side of things is you make sure you get the content and deliver it to the user. Then you have the presentation kind of wrapped around it, and like there's the kind of the proper definition is around kind of adding in CSS and then JavaScript on top, or CSS to kind of like improve the presentation layer, and then JavaScript on top of that to actually make it kind of a little bit more functional and maybe a little bit more interactive at the time. But I think the important thing from our side of things is like not every experience has a lot of content in, right? Like not every single site that you build, like Airhorn has not got a huge amount of content, but I still built it wrong. But this is one thing that we built in 2014. We, as in our broader team in DevRel, like Sam Thorogood and Eric Beidelman in Australia and America, built this kind of the Santa Tracker experience. And it's a great experience, right? Millions and millions of users use it all the time, and they get a great experience out of it. But I want to talk about one specific kind of individual piece about it in terms of one of the good things about Santa Tracker is that you can say, well, where is Santa in the world, right? You sit there and go, okay, Santa is in Iceland, and I live in Scotland, right? He's not that far away. I need to get to bed, in theory, with the kids, at least anyway. So Santa exists, by the way, in case anyone's watching. So the idea behind this is, like, we have this idea of, like, we as the developers of this piece of the software, we want to know where the user is so that we can provide some kind of level of interaction to the user. And obviously, we chose geolocation API because the geolocation API gives us pretty much exactly where the user is based off their current GPS location. Whether it's on the Wi-Fi cell towers or kind of satellites and a whole bunch of other stuff. It's a really powerful API. But the problem is, like, not everyone actually accepts it. So you don't get a whole bunch of usage off the back of that. And this is, sorry, I've jumped a slide forward. In 2014, like, this was our entire experience. We had, like, you go, well, what would happen is you go to the page, you say, where are you? And then people will either accept the permission with pretty much no context or reject it. It turns out when you prompt the user, you know, hey, where are you? They're like, I'm not going to tell you where I am. Like, you didn't give me any context about why you need this. So we had this experience where a whole bunch of users didn't get the full rich experience of, like, the Santa Tracker experience because they either disabled the geolocation, never used it, or, you know, they didn't have the geolocation API even available in their browser. And, like, we found that we didn't have a great accept rate for, like, using that one particular feature. In 2015, like, it was changed up a little bit, right? It's like, we know that the GPS can give you a really accurate information about where the user is, but, like, we want to provide this great experience, and there are different ways that we can do that. We can have no experience at all, which is like this is like the progressive way, at least in theory in my head. Like, you have no experience at all, then you ask for, you basically use the IP address to get the geolocation. And then if you can do some other things, like if you know that the user's language is in Japanese, then there's a good chance that they might be in Japan if you can't get the geo information. But then you can tie the two pieces together to actually say, like, hey, you're in Japan, and, like, Santa's not too far away. But then if you really want, and you want to provide a super accurate piece of information, then you can ask and kind of say, hey, we know kind of you're in Japan. Do you want to find out exactly where Santa Claus is? Give them some context, and then they can use the API. But the fundamental thing here is that we've still, as a browser developer, or not a browser developer, as a developer of this piece of software, we still roughly know where the user might be by saying, okay, we're going to use the existing information that we have. And I think that's one kind of small form of, like, the progressive experience, is you start from no experience at all and then use all the different pieces of information that you can get before using the more complex APIs. So I think the critical thing I want to try and get across in this bit is that you probably want to know and kind of tactically think about how you're going to use the different APIs, when to upgrade the user to the different experiences. And some of the reasons why you want to do that is because, not because the API doesn't exist, is because it's behind, like, a permission or a privilege that says the user has to go, okay, you know, if you want access to geolocation or you want access to the camera, like, you have to ask the user. And if the user says no, like, what do you do at this point? And if you've built progressively, you don't have to retrospectively go, okay, cool, I'm going to add a file element in which lets you kind of pick from the camera. You're just going to provide that experience up front and kind of just smooth out your development model at least. So that's kind of my rough introduction. We did 15 minutes, it's pretty long. Some of the things we're going to cover is that our progressive web app model covers multiple different stages of like how you're thinking of building your software, but like around the app shell, like how you construct your application, but also some of the different technologies as well that you can use if you want inside your app, whether it's push, install for add to home screen, or making your piece of software a lot more resilient to network connectivity issues. So like these are some of the core tenets of what we think like a progressive web app might take. And I'm going to kind of briefly cover some strategies about what you can do. The first is the app shell, right? And like what most people don't understand is that, well, when you're thinking about it, is the HTML is an imperative language, right? It's an ordered sequence of elements. This is without CSS, at least anyway. It's an ordered sequence of elements that are executed from start to top, and then they construct your document based off the back of that. And I think that's actually pretty cool, because like, if you look at kind of procedural languages as well, where you can have functions and a whole bunch of other stuff, they get a lot more complex, but HTML by itself is an actual imperative language. Now, actually, I forgot what I was going to say in this one. If you take your, I've skipped a page, that's why. Clickers. Oh, okay, cool. So this is like a rough case study, right? It's a very simple blog, right? It's not really contextually relevant to a lot of experiences that you're building. But the idea behind this, like if you've ever gone to like the Google blog site from ages and ages ago, like you had to have a whole bunch of JavaScript just to be able to run a bunch of content. It was just a nuts experience. But the idea behind this is like it's a very simple site. It's created from normal, simple HTML and Java, or HTML in this case, just rendered from the server and pushed out to your site. Now, one of the things that we've seen in the kind of the broader web industry is that a lot of developers are building sites where you have the app shell. Like this is like kind of the app shell model. Like a lot of people have been doing this for a long time with other frameworks, and just normally in like whether it's Angular or Ember and a whole bunch of other ones, where you construct the shell of your application and then dynamically load via Ajax content in. Like this model works really well, right? We can build some great experiences. Like Gmail is pretty much built this way. Lots of other different applications are built this way, where you load the structure of the application and pull the content in. But like Paul Lewis has done this kind of nice tweet a while ago, where he kind of like ripped apart the different problems that you have when you're building these experiences, when you're trying to build a fast experience, at least anyway, is that we'll get given the HTML, right? Like the browser will download the HTML. We had all the content before, but now we haven't got the content, which means we can't really put anything on the page until all the JavaScript is downloaded, the frameworks are booted up, the JavaScript and the CSS are downloaded and kind of done all the layouts that they needed to do. So you have this massive gap between having HTML available, fetching some data, and then actually having something rendered on the screen. And like I said, like this is like what we think of today as the app shell model, and this is one of the ways that we're asking developers to build applications, is using the application shell. We know the application shell works really, really well for building different types of experiences, but it's not necessarily the only way that you'd want to build a progressive web application. But it's an interesting model, because one of the things that you can do is that you can focus on your content, get everything out as a rendered. So you can focus on your content, at least with the app shell model, get your content out rendered in that first request. And then, like you've probably been doing in a lot of applications, is then start to incrementally take over the experience. So this is just a simple thing where, if you click on the link inside your application, if you click on a link inside your application, you'll go normally navigate to a different URL. Now that's good, but inside like that whole kind of white page refresh model is something which is a detraction from the user experience, especially in the kind of the web versus app world. So what you normally do, and you're probably all familiar with this, is that you intercept a click, then go, I'm going to load some content, and inject that content back in. That's a perfectly reasonable way of doing it. But one of the things that we're trying to get to right now is that we want you to think about you do the page load, so you get the content out. You're still using the app shell model where you incrementally take that over. And I'll go back one slide. If you think about this model where you kind of intercept the content, or intercept the link click and load the content, you've probably been doing this already in the past, which is quite a good thing, because when you go to this kind of progressive model, we still want you to go and do that, right? So if you have a service worker behind the scenes intercepting all the requests and kind of loading the content, you have a number of different choices about how you serve that. You can still do the incremental load. So you can basically say, well, not the incremental load, sorry, you can still get the HTML, parse it as you go through, render on the server, and if you watch Jeff's talk in a little bit, he's going to dive into that kind of universal kind of JavaScript rendering side of things, where you can render out on the server and push out to the content. But we're doing that progressive render. The web has got 20 years of being able to kind of progressively render content to the browser. We shouldn't kind of just throw that away because we want to get to that nice model of app shell and then load the content in. We definitely do encourage you to think about the app shell model, render the content with it, and then start to kind of tactically replace that. Like once you know that you're inside the browser, you can do a bunch of different things with the service worker. You can fetch JSON data endpoints and kind of have them cached and pulled through, or you can just keep doing kind of full-on page requests, server rendering, push it out, and then kind of parse out the content and load it. There's lots of different models, and I think this kind of progressive rendering approach, at least anyway, and the flexibility that you get with service workers helps. So the thing I do want to say is like AppShell is a model that we definitely know works. Like it's been used for a long, long time already. We know it works well, but there are many different tactics and strategies that we would use. And I would definitely encourage you to look at Jake Archibald's Service Worker Cookbook, because I stole a whole bunch of his code to get my blog working. Like my blog is definitely not an application, but I want that resilience from a service worker. I want it to be available whenever the user goes back to it. But more importantly, if the user goes to any other page inside my site or refreshes the page, it's available instantly. It's not an application, it's a content delivery system, in this point for me. And I just chose basically a stale while revalidate method for actually kind of fetching my content. So the request comes in, I'll pull the data back from the cache always, but always then go and, at the same time, go and fetch the latest content. And then subsequent requests will then refresh. When the user refreshes the page with subsequent requests, that'll load my new content because it's already been kind of cached. That worked for me in a model, as a model for kind of making my site resilient and work offline. And I definitely encourage you to have a look at the different models that you can have to build an experience where the service worker is there to enhance the experience rather than actually say, we have to push everything into an app shell. The other area, and I know Owen talked about this a little bit earlier on, is kind of push notifications. Now, this whole section is, we can talk about a little bit as well. It's kind of interesting because the push notifications API is incredibly powerful. It's supported across a number of browsers, but it's not on on a relatively large number of different operating systems, and it's not on iOS basically at the moment. And that's another question that we get is well, I want to do push notifications, but it's not on these experiences. So what do I do? Well, the first natural thing you want to do is you just want to check for support, right? You can easily check with Service Worker. You check via a Service Worker to see whether you can support push notifications, and then you can say, well, we haven't got push. We just won't do anything with it. But that's the problem, right, is that we're not going to do anything with it. There are a number of different tactics that you can use at the time to actually say, we can do and give the user more compelling experiences. Even if they don't have push notifications, we can keep the user up to date with important information. Now, there is a little analogy that we've got is that there's the transport kind of the transport structure that you'd have in kind of any major city. There's a destination that you want to get to. You start at your point A. You want to get to destination point B. There are many different ways that you can do that. You can take the tube or the metro, the overground railway system, a bus, a bike. Lots of different ways to get there, but the result is the same, that you've got to that destination. I think that analogy works quite well for what we talk about in some of these experiences, at least anyway, because there are many different ways and tactics that you can actually start to integrate integrate different experiences. The biggest thing about push notifications, and this is kind of you probably saw this from Owen's talk, you want to be relevant, timely, and accurate. The three different main areas that you want to focus on. The timely bit is important, right? Because it's not, you want to get in contact with your user, but you don't want to get in contact with the user all the time, basically. It's not your primary mechanism of getting in contact with the user. So you want to think about how you want to use notifications. Notifications normally are kind of most relevant when you have a timely-based kind of action that has to happen. You send a request to the server, the user gets it, and then you want the user to action it pretty much straight away. So there are a number of different... I can't use this. There are a number of different questions that you want to ask, right? Many businesses, if you've already got a business or a site, there are a number of different ways that you're actually starting to think, you're already in kind of contact with your users, right? That's right is one of my words. I say right, great, dead powerful. So every time you hear me saying that, it's me trying to think about what I'm going to say next sometimes. But you have a number of different ways of actually kind of contacting your user. Well, you might already have their email address, and you might already have a regular outbound communication with them. You might already have their phone number, right? So if you have their phone number, if you have to send important and relevant information, you might want to send an SMS system, and an SMS to them. You have other different ways via Twitter and Facebook. I don't think those have ever really taken off in terms of private direct communication. It might change when the messenger ecosystem and messenger bots kind of come out a little bit more. But the important thing that you have to make is push notifications aren't the answer to everything, and it doesn't matter if they're not supported in every single browser. If they're supported, it's great. You can do really cool things with it in terms of hey, timely information, you can send it to them, get them to action it, but at the same time, you can do other nice things as well. So the first one is native notifications. Everyone knows that native notifications drive re-engagement and users back into their experience. And it's normally targeted to a single device at the same time, which is great because especially in emerging markets, most people are focusing on their phones at the time, the current moment. Now, there are a number of different things that you can do where you can have contextual actions. The important thing here for the native is like after your site is, or your application is on the user system, like having notifications is incredibly low friction, and that's why we see huge amounts of re-engagement. So if they already have the native app installed, you might not want to actually send them push notifications. But more importantly, many people have outbound, proactive email communication with their users. And one of the things that we see is that we don't necessarily use email in the way that we think we could use it. So like you have different way, like you know who the user is, like as an example, right? So you're sending an email to an already signed in user who has already been using your system because of some important action that has happened on their site. Like, you know the context of what you've sent to the user so that you can use that context in subsequent web requests. We know that when a user, like email is a massive driver of web traffic, especially on mobile. So when the user clicks on that email, like you can do things like send them into the important kind of area of your site. It's a really nice way of like engaging with your user, where in the past you might have used push notifications to say, hey, this action is really important, go back into your account, use this information, like because we know who you are, to actually then go and complete the action. Like email is still just as valuable and probably more valuable than notifications to some extent. And then things like SMS, and like I don't think social is the right one to focus on at the moment, but things like SMS as well, like you can send push notifications, like they are nearly real-time push notifications that can get through to nearly any device, irrespective of whether, like of kind of complete network connectivity. Now, I think this is really important because you can embed links in there and then you can get the user to go out. So if you're targeting a whole bunch of iOS users who don't have things like push notifications, but you know who they are and you know their phone number, then things like push notifications, SMS are really good ways to keep engaging with your users. And I know people are saying SMS is dying and it kind of is starting to get replaced for a lot of messaging apps, but these type of experiences are great. And then finally, once you get the experience, once you get the ability to do those once you get the ability to make calls, rephrase it. Once you get the ability to send notifications because you know that the device supports the ability to do it, then you need to make a decision at that point about how you treat your users. Like if you're kind of already sending the messages via SMS, do you replace that experience? And you have to be really careful because you don't want to bombard all your users. Now, re-engagement is one bit from push notifications. The other bit is the other area of re-engagement is, and this is one of the really powerful areas about progressive web apps, is that you have the user being able to install your experience on the home screen. And when that experience is on the home screen, they expect a certain number of things to happen from their side of things. They expect it to always be available and instant loading. Like once you're on the user's home screen, you're kind of permanently on their real estate, so you have to provide the best experience. And that's why I'm going to talk about the install phase at the moment. Like this install step is one of those areas where we've had things like add to home screen for a long time, but it's not worked as well as we thought. So like I think in 1997, or maybe it was Safari 3 at the time, iOS brought us the ability to add our experiences to the home screen. And Steve Jobs at the time said, hey, like this is the way that we think you should be building applications and experiences for our phone. Like you should go off and use the web platform to be able to deliver this. We can make it work offline. We can make it installable, like a whole bunch of other things. We know history played out a little bit differently. But fundamentally, we've always had this ability on iOS at least to be able to get an experience onto the user's home screen. And on Android, it was incredibly hard, right? Like Android hated the way it seemed at the time. Trying to get experiences onto the home screen was nearly impossible. We made it a little bit better in Chrome. Like there was only like 7 steps rather than 12 steps to get something on the home screen. But like it was still a bad experience, right? And that was until we started to kind of like change the whole model and like where we are now with progressive web applications and a whole bunch of other stuff. Like that's like, it's everything started to change. But the really interesting thing for me anyway in this space is that everything was controlled by meta tags. There was information inside your page that would allow the browser to say, hey, this is how we think this experience should like look and operate on the user's device. So the good thing was you could get the experience onto the home screen. Like you could say, hey, I want my application to be kind of like a full screen application via one simple meta tag, and then when the user kind of pressed the button, it would go onto the home screen. You could choose whether you wanted it to be a full screen experience like a native application or like a browser experience, right? But the problem was it was not standardized and it was on every single page. You had to kind of litter your whole site up with a whole bunch of meta tags just to get things working. Even worse, it was completely broken, right? Like the whole space around this is like, when you have an application or a site, like an application, you always launch into one specific point into the application, like the entry point into your experience. Add to home screen was bookmark this page and store it in the home screen. So if you weren't already on the home, like the entry point into your application, like you would go into like a Leaf page. Like imagine adding Google Plus. I mean, imagine adding Google Plus to anyone's home screen. But like imagine you're on like one of my pages inside of Google Plus, and you add that to home screen. You don't want to keep going back to my content, although I'd like it, right? Because I write great stuff. I'd like you to be able to kind of go to the entry point of Google Plus. Add to home screen with the meta tags, it would never give you that. You could never get back to the home screen. It was a really hard way to manage things. And then it was even broken even further from that. Like if you did a navigation inside the window, rather than say, hey, I'm going to replace the current page with the new content that is behind this other URL that is part of my application, it would just go, okay, I'm just going to open a new window and a new tab. It'd completely break you out the overall experience. So to kind of recognize that, the other day I actually wrote, it was like, what can I write for this talk? And I wrote a spelling mistake as well. Effixies. Oh my God, that's terrible. Basically, you have the ability to actually fix the way that iOS works. It means that you have to emulate a number of different things and introduce a new meta tag called Microsoft. It's the Microsoft meta tag, MS application start URL. But fundamentally, this polyfill essentially will say, hey, we know that you've got all these meta tags in place, but we want to fix the iOS experience. We want to make it so that it matches like Opera's experience, Android's experience, Chrome's experiences, Firefox experiences of actually getting onto the home screen. So it does a number of things like clickjack, or it does clickjacking so that it says, hey, we know that you're still in the experience, like refresh the page content rather than redirecting you out. One of the interesting things is that it's really hard to manage state on iOS, and this kind of should get around it. But the really great thing is until kind of iOS starts supporting things like manifest, then like this is a nice model, and there are a number of other people starting to think about how you can actually make the iOS add to home screen experience a lot better. And that's if you want compatibility, right? At the moment, you might not actually want to say, you know what, iOS or whatever browser it is doesn't support it. No, that's fine if you don't want to do it. The modern way is to use the manifest, and like Jake talked about the manifest a little bit earlier. The manifest is a way of describing what to launch, how to launch it, and how it should appear on the user's system. And like, when you meet all the criteria, and I'm going to talk briefly about the criteria, you get this pop-up that says, hey, add to home screen, you add to home screen, and you get this nice kind of installed full screen experience if you want it. Now, there are a number of things that we do, and a whole number of different checks that we have to make sure that you don't kind of get the prompt when you don't really, it's not deserve it, but when you're not actually offering a great experience. One of the things that we want to try and do is we want to make sure that if you launch from the home screen, you get an online experience all the time. Like, you never get the offline-osaurus, which is why we enforce the kind of service worker restriction. And we need the manifest because if you're launching again into that non-home screen experience, then you're not giving the users a great kind of like app-like experience, especially when it's launched from the home screen. The big question is, can we bring iOS in line with the manifest and its own use of meta tags? And I think we can. But I will say Maximiliano Fertman, he's done a really great blog post in the past couple of days about all the different things that you have to try and do to actually say, we want to have a compatible experience. There's a number of issues that you have with icons and differences between the two platforms, but there are ways to work around it. But the interesting thing, at least anyway, is that we have all the information that we need. There's a secret meta tag, Apple Mobile Web App Name, which kind of maps to the manifest attributes of name and short name. Obviously, we get all the icons and those type of things, which is really good. It's kind of nice. We can say that we want to launch in standalone mode, right? We want it to launch like a native application. If we don't have Apple Mobile Web App capable, then it launches like a normal browser tab, which is another option in the display manifest. We don't have complete full screen, but we have some good compatibility with the two parts of the platform. And we kind of have some emulation around the theme color, right? You can say, I want to get rid of the top bar by saying black translucent. That's pretty nice. There are other bits which are broken, like the splash screen, it doesn't work anymore, which is a bit unfortunate, but we're still kind of not too far off. Now, I think that's kind of interesting, but the thing that I don't want people to have to do is have to then like work out exactly which meta tags that you need to install. Now, there are a number of different polyfills. This is the one that I've written. There are a number of different ones coming through as well, where if you can basically know that you've got a web app manifest on the page, you drop a small piece of JavaScript in, and then it goes and works out what the exact best tags are to use. And then it'll make sure that you offer the best kind of compatible add to home screen experience. I think it works pretty well. This is just a demo that I've written. There are another good couple of ones out there. And finally, and I know I'm over time at the moment, is the offline section. Luckily, I think Jake has covered most of the offline story that you need to kind of think about. But there was one thing, again, is that when we talk to a lot of developers out there, it's like, well, does servers work on iOS? And right now, the answer is no. And like I said before, it's the wrong question to ask, right? We don't need to build experiences that absolutely rely on service worker. But the thing is, people still want offline as one of their core features. So the first thing that they do and ask is, well, I can use app cache, right? Like, so who's built a site with app cache? 20 people? How was the experience? Was it a good experience? No? OK, cool. I mean, there are a number of different issues with app cache. If you were building an experience today with a new progressive web app, say you went away and go, I'm going to build a progressive web app, and I need to make it work offline, we still need to come up with the exact business case why you should kind of skip the app cache section. But I do think you should bypass app cache. The interesting thing, if you've already got a site that uses app cache, and Matt's going to talk about this later, you can add a service worker in, and then there will be no conflict between the two because the service worker will take over. So there's a nice migration path off app cache. But if you're thinking about building an experience, I would just say bypass app cache completely. There's a number of different problems that it has. It's hard to do good server rendering with it. And then if you update your kind of manifest, and you've been to 100 different URLs, which you've kind of all kind of had cached, then this atomic update system is going to it basically re-requests every single URL. It's a bit of a nightmare to manage. There's a lot of different problems. So I would just bypass it completely. It's a decision that you have to make. But I think you should do it. The one thing I would say is that there are a number of different strategies that you can take. You can build for resilience in the client first. If you're offline and someone has a window open, quite frequently they don't bother to reload it because they know there's an issue. The worst thing that you can do is break the experience, right? So build for resilience inside the client, handle XHR network failures, cache data locally. And if you look at the Firebase platform and a bunch of other ones as well, they do that. They know that they can cache data locally to synchronize when there's some data connection back in, when there's some data connection that comes back. And finally, you can start to then layer in things like service workers and extra enhancement to give you that resilience as you need. So that's my thought, is I just kind of stay away from app cache at least anyway. Now, there are a number of different, one of the pieces of criticism that we've had is that there are a number of different issues in terms of information and knowledge. Sam Thorogood on my team has launched this Always Be Progressive, where we're trying to start to think about, hey, we have all these different pieces of technology. How can we actually get you to think about building systems which are progressive, or at least if you want to kind of polyfill things through as well. So we have this nice little resource. We're going to keep updating it to actually give you the guidance that you need to actually build these experiences if you fundamentally require some of these features, which is quite nice. One of the other things I would say is that we'd have a nice that was my killer slide. I've gone too far with it. Is we have, and we're starting to build out and flesh out our developer portal as well. So on developers.google.com/web, we want to make sure that you have all the tools that you need to build fast, secure, and performant experiences with a great user experience. They're the fundamental core tenets of what we want to try and get from the web at the moment. And then if you kind of start to knit all those things together, we're hoping that a good progressive web application experience that comes out the back of that as well. And that's when you're kind of building in service worker and this extra resilience. Now, the thing that I will say is that I know, and every single business that we speak to, they can't always completely redo their entire site. And I think a lot of this is about being pragmatic. You can integrate all these different components in. If you want push notifications, that's a great thing to add into anyone's individual experience. You don't have to base your entire experience off the back of that, and you can provide value to a large subset of your users rather than have to think about providing the same experience to all of them. But there are a number of different strategies that you can take. And I think that's a really powerful way to think about it, is you start with a good base, get the content out and deliver to the user, and then think about how you can kind of enhance that experience as you go along. And that was me, and I know I've run out of time, so thank you very much. Up next, you know what? I've been telling everyone, you've got to introduce the next speaker. Right? It's the thing that you have to do because we don't have Jake or Paul doing the nice compare thing. And I was about to walk off stage, but I'd like to introduce Matt Scales, who's going to talk about the tools that you can use to build these.
Hey, everyone. Okay, so hi, as Paul was meant to say, I'm Matt Scales on Google's Web Developer Relations team. And I'm here to talk to you about tools and libraries for building progressive web apps. Now, part of what makes progressive web apps possible now is a shift in the way that the platform itself is being developed. So on the old web, we got custom-designed, high-level features for achieving the things that the W3C thought web developers wanted to do. So developers want images, so we'll give them an image tag. Developers want to lay things out in tables, so we'll have a table tag. Now, the new idea is this thing called the extensible web, and it says that rather than building simple APIs for specific things, we should be getting low-level, deep, powerful APIs that enable a much broader range of things. So rather than a tag for images, let's have a tag for arbitrary graphics. Rather than a tag for tables, let's have CSS properties that let us lay things out however we want. And this is great, and it allows us to upgrade our pages into apps, but there's this gap between the level the platform gives us and the level we'd like to work at. And we can fill that gap with libraries. Now, in the extensible web, the community is given the responsibility of providing simple, easy-to-use libraries to handle the specific things that developers actually want to do. And this is great, because it's much easier to iterate on the API of a library than it is to iterate the web platform itself. And this means that even as we speak, someone is out there solving hard problems so that you don't have to. So today I'm going to talk about libraries and tools for service workers. I'm going to talk about the new web app features in Chrome DevTools. I'm also going to try and answer the question of, is the thing that I built actually a progressive web app, and is there anything else I need to do? So obviously, the most important new technology as far as progressive web apps are concerned is service workers. So just a quick recap. A service worker is a background thread for your application that opens up new features like offline, push messaging, and background data sync. And for the offline use case, it acts as a network proxy right in the client. So whenever your page requests a resource, the service worker gets a chance to respond to that request. It gets a chance to get in the way and do whatever it wants. And also, just to remind you, this isn't about working offline, necessarily. It's about, because even being online can be a terrible experience. If you have Wi-Fi, or if you just have a slow connection, maybe you're connecting to hotel Wi-Fi, or maybe you're somewhere where data costs a lot of money. What you really want is network independence. You want the experience of your app to be great, regardless of the network situation. But in order to achieve that, complex apps are going to require pretty complex service workers. There'll be a lot of code, and there's a lot of new APIs to learn. So we're going to help with that with a library we built called Service Worker Toolbox, or SW Toolbox. And this was created by our team at Google to abstract away the common patterns for connectivity independence. So here's a pretty simple example of a service worker written with Service Worker Toolbox. You import the script from wherever it's residing, and that gives you a global object called Toolbox that exposes the API. Here we call toolbox.precache, and we pass in a list of resources. This says that when our service worker is installed, go ahead, fetch all these things, stick them in a cache so that we know that whenever our service worker is running, it has access to these resources. And you use this for your app shell and perhaps any really common small resources throughout your app. And then we use toolbox.router to match different behavior to different parts of our application. So here we're going to set a default. We're going to say that the default behavior for any route will be something called toolbox.fastest, which we'll get to in a moment. And then here you can see just an example of a more specific route. This is based on Express.js routing for anyone who's built a server in Node. Toolbox.router.get, and then there's a URL pattern, /API/ followed by anything. And then the behavior here will be toolbox.network_first. So let's talk about toolbox.fastest, toolbox.network_first. So these methods are what we call strategies. These are, so typically you need to think pretty carefully about exactly what behavior you want for different parts of your application. So you need to choose a different strategy for each route, or potentially. An SW Toolbox comes with 5 built-in strategies: fastest, network first, cache only, and network only. So let's go over what they are. So with the fastest strategy, a request comes in, and we race the network and the cache. Whichever one is going to come back first is going to return to the page. So in this example, the cache is going to come back first, which is probably pretty obvious, though obviously it will go to the network will win if it wasn't in the cache in the first place. if and when the network ever does succeed, it updates the cache so that the next time this happens, even if it goes to the cache, it's a slightly fresher version of the resource. So this is good for stuff that you want to be fast, but is allowed to be maybe a little bit out of date. And just as a note, because this one always uses the network, if your goal is to save your user's data plan, this is obviously not necessarily the best thing to do for all your resources. Network first, request comes in. First of all, we try the network, and we give that time to succeed or fail. And only if it fails do we then go to the cache and return that to the page. Now, if the network request does succeed, that updates the cache, even though we're not coming from the cache this time around. So that the next time we try it when we're offline or whether the network times out, we get a more up-to-date cached version. And so you can imagine, like, fastest and network first are good for slightly different things. So if you imagine a Twitter client, then when you first load your application, your highest priority is getting stuff on screen so the user has your application. So perhaps you use fastest to load the latest tweets, because it's better to show old tweets than to show no tweets. Whereas when the user does a pull to refresh, that's a pretty strong signal they actually want the freshest data. So go to the network and only go from the cache if you can't use the network. There's an important extra option to this one, because it turns out that on mobile devices, that network timeout can be 2 minutes. So if you have Li-Fi and your device is absolutely convinced it has a connection, but it doesn't really, then you can have some sort of action, and it can be 2 minutes before you even decide to try the cache. So we added an option for the network first strategy that lets you say, give a more reasonable timeout. So here we're saying, after 5 seconds, I don't care about what's on the network. I'd rather show something. Cache first, go to the cache only if it's not there. Do we go to the network? Sort of the opposite of network first. Again, the network will update the cache. But one of the important things to realize here is that once that network request has succeeded once, it will be in the cache, and so the cache will be consulted every time, and it will never be updated. So this is still pretty good for some cases. If you have versioned URLs, if you have some resource where the URL will change whenever the content changes, this will work fine for that. And this might be for things that are that you want to be able to cache, the things that don't change but aren't part of your application shell. So the example I've been using is blog posts. You don't want to download 10 years worth of blog posts the very first time someone comes to your blog, but if they have been to your site and downloaded a few posts, it's reasonable to keep them around. Cache only, so this is go to the cache, and if it's not in the cache, fail. This is good for the stuff that you pre-cached because you know it's there. And then network only, go to the network, and if it fails, it fails. This is what you got without Service Worker, and the only real reason to use this is that if you've overridden the default with something like toolbox.fastest, this allows you to go back to the original behavior just for one route. And if those don't do everything you need to do, you can also define your own strategies. So here we have a function I've created called fallback image. Sorry. What this does is it takes a request, and it will try and fetch that request from the network. And if it fails, it will respond from the cache. But it won't try and respond with that, a cache of that specific request. It will always respond with this fallback.jpg. So you can use this, for example, if you have hundreds of profile images on a page somewhere. Perhaps it's not actually that important to have that in your offline experience, and you don't want to fill the user's device with those images. So you have a single image that you use as a fallback instead. And to make this useful, you have to make sure you've pre-cached the fallback image, and then set up a route that actually uses it. So it's just the same as before, except instead of using toolbox.whatever, we've used fallback image. And finally, on Toolbox, you you can get fine control of the cache as well. So by default, when you call pre-cache, or when you use cache only, or fastest, or whatever, the cache that it uses is shared over everything in your whole application. It's a default cache that S2 Toolbox creates for you. And you can, on an ad hoc basis, say, for this route, I want to use a different cache for whatever reason. So here, we've passed in an option called cache, and we've set a name so that it will be a different named cache that it uses. And now we can set options on that cache, so that this cache can only have up to 500 entries, and entries can only be in there for up to 5 days. And S2 Toolbox will go in and clean up periodically. Now, something we've kind of glossed over there with S2 Toolbox is that pre-caching step is actually trickier than it looks there. There are a few problems. One is that in order to get a new install event, you need to change the service worker script. Not something that service worker script imports, but the actual original service worker script. So you have to remember to actually update that every time you every time you do a release that changes some of the resources, even if the service worker itself, the logic doesn't need to change. Another problem is that when the install event happens, S2 Toolbox will take all those resources and just download them all again, even if none of them have actually changed. And then you also have to maintain a list of which resources need to be pre-cached. It would be quite easy to miss something out of that array and then find that in your next release, your offline experience is slightly broken because a file didn't make it into there. So we created a tool to help with this called SW Precache. Now what this does is it takes a few simple options and it writes a service worker for you. It's something you can stick in your build step. You tell it which files you want to cache. It will take a hash of each file along with the file name and write those directly into the service worker. So if any of your resources change, the hash will change, the service worker itself will change, and you'll get a new install. It also means that when that install event fires, the service worker has a list of every resource with its hash. So it can compare it to what it already has and only download things that have changed or are new. Now this can be used as a command line tool, installable via node. And then you call run the S2 precache. And here's the simplest option setup. You say where the root of your application is, and it will just precache everything in that folder. You can also use it as a requirable node module. So you require an S2 precache. You call precache.write. You say which service worker file you want to write, and then you can pass in some options. So here we've said we're going to use this glob pattern to say which static files we actually want to cache. And if you're wondering whether that means that we've now lost the ability to do that dynamic caching that S2 Toolbox gave us, there are actually two ways to bring it back. The first is with this runtime caching option. You pass in an array of objects which specify those routing rules that you had in S2 Toolbox. So you have the URL pattern, and then you have which strategy to use. And you can even pass in options. So we have the network timeout seconds option. And this is great for most simple cases, particularly if you're only using the built-in strategies. And if you want to do something a bit more fancy, if you want a bit more control, you can just say that you want to import a service worker script that you've written yourself. So you could let S2 precache handle all of the static resources for your app shell, and then do the dynamic caching using a service worker toolbox script that you wrote yourself. And it will inline that into your service worker. And this also allows you to add in things like push notifications and background sync into S2 precache's service worker as well. Now, service worker doesn't work everywhere, as Paul said, and app cache does. So just to reiterate, should I use app cache in a new project? No, because it's terrible and doesn't do what you want, and the more you contort your application to try and fit app cache, the more you find that it's still not going to work, and you have to contort even more. And it has security problems and it's generally bad. Can't stress that enough. However, if you've already got an app cache for your application, we have a tool that will help you transition. So SW app cache behavior is this little library we've created. What it does is you import the library into a service worker script. This could be your entire service worker script if you wanted. You create a fetch handler, and you just say in that fetch handler, I want to respond with whatever the legacy app cache behavior would be, essentially. What this will do is it will get your app cache manifest, parse it, work out what the correct thing to do for an app cache would be, and then do that. But it also allows you to get around some of the security issues and some of the things like never getting into a state where the app cache is never updated. Service Worker won't actually allow you to do that. Now, SW app cache behavior is just one of a set of things that we're hoping that we're releasing as part of our SW helpers repo. As an example of something else we're doing, there's offline analytics. So this was written for last year's Google I/O website and was used again this year. And what this does is you set up a route for any analytics requests that uses that the strategy function that's provided by the library. And whenever one of those analytics requests fails, it will stash it away somewhere, queue it up, and then when the user comes back online again, it will replay it and add a parameter so that it correctly attributes the event to the time it actually happened. And we're hoping to add many more things to this repo over the next coming months. So that was Service Worker. What other tools? What other things can we help with? So no talk about developer tools is going to be complete without talking about Chrome's developer tools. And there are some great new progressive web app features coming in the next release. So almost all of this is only available from Chrome 52, which is currently in beta, but it's moving towards stable in a few weeks. So first up, the application panel has been renamed, the resource panel has been renamed to application to better reflect that this is now where you go to look at things to do with a web app. This first panel is, allows you to debug your manifest. So it lists what the browser has detected as the name of the application, what icons to use, what theme color to use, what the start URL is, things like that. And also gives you this Add to Home Screen button that allows you to trigger the on before install prompt so you can test code to do with delaying the install prompt. Service Worker panel has been redesigned to hopefully be a lot clearer. All of the service workers for the current application will be shown in a list, which I should probably have got a screenshot of. But it will be less confusing about which one's active and what you can actually do to each of those service workers. It has all of the same features that it did before, but it has some extra ones too. So at the top here, there are these three checkboxes. Offline is a shortcut to the same thing in the network panel that says that you want the network condition to be offline. So that is great for testing the offline behavior of your application and to make sure that your service worker is working correctly. Update on reload means that whenever the origin is refreshed, it will check for a new service worker and potentially do an install. If it's changed, do the whole service worker install dance, regardless of how long it has been since it last checked. And bypass for network says that the service worker should load, the install and activate events should happen, it should still be called for push and background sync, but the fetch event should never be fired. Whenever any request comes in, it should not try the service worker to resolve it. And this is good if you've got your save and refresh workflow going on for a resource that would be cached for a long time by service worker. It allows you to just to go back to your normal workflow in development. The clear storage panel. So as a consumer of Chrome, you've probably seen the feature of clear private browsing data. It allows you to get rid of cookies and things like that for a period of time. You say, I want to get rid of private browsing data from a day ago, the last week, or forever. Whereas this is a bit more developer-oriented. This is for the current origin only. I would like to clear these things. And the options that it gives you are things like service worker, cache, IndexedDB, and things like that a developer might be more interested in. And I also want to call out a feature that's actually been there a while, but people don't necessarily know about, which is down here is this cache storage viewer that lets you see what things are actually in the cache API cache that you're using with your service worker. So this can help you debug issues with pre-caching or when a request is failing for something you think should be in the cache. So finally, I was going to talk about the question of, is my thing actually a progressive web app? Now, I don't think we can really answer that question because it's a bit of an open question, but we can try and get a bit further there. One of the things that would be cool here is if we had a button we could click that would just tell me, is it a progressive web app? Am I there yet? So the Chrome team built one, and we called it Lighthouse. This is both a Chrome extension and a node-based command line tool, which has a whole bunch of different tests in it that it runs on your site and gives you advice on things that you might be missing. And it also has this very cool professional-looking logo. So as a Chrome extension, you load up your page, you click the button, and then it will reload the page a few times, connect with the remote debugging protocol, gather a whole bunch of metrics, and then spit out this report. It'll give you a score, which will give you a vague idea of what it thinks of your application, and it will tell you anywhere that it thinks that you might have missed something. It also has this best practices section that is things that it's not going to score you on. Maybe you don't actually need to do these things, but if you do, you should check on them. It just gives you a bit of a guide. You can also run it as a command line tool. Just for anyone who's thinking of typing in URLs they see on the screen, airhorner.com makes a noise. I gave this talk at I.O., and about 30 seconds after this slide came up, so it was like, from the audience. So you run it on the command line, and it will output, by default, it'll output pretty printed to the console. But you can also output JSON that you can parse yourself, or the same HTML that the extension gives you. And it's also requirable as a node module. So you can say Lighthouse and then the URL, and then that returns a promise, which resolves with the JSON that you would have got from the command line tool. And obviously, the CLI and node module are both good ways of adding Lighthouse to your regular tests or continuous integration. I'd like to draw attention to the big alpha in the corner here. I just want to be clear that this is early stages. None of the rules are final. I'm sure there's a lot of discussion to be had about what the rules say and whether they're good rules. If you would like to contribute to that discussion, or better yet, contribute pull requests, you can find us on GitHub. And I'd also like to point out that this currently only works in Chrome 52+, which is currently in beta. So to recap, progressive web applications are made possible by the extensible web. They're made practical by libraries and tools. There are a whole bunch of service worker libraries out there from Google and from others, with more coming. Chrome DevTools is awesome, as always. And Lighthouse attempts to tell you when you're done. It's probably a bit too definite in this slide. OK, thank you very much. I hope that was useful. Thank you. And now Jeff is going to come up, show you how to use some of these tools to turn your existing web app into a progressive web app. Okay, thank you.
Hey everybody, just bear with me a second as I switch laptops. And we are switched, and there we are. So thanks, Matt. And hey folks, my name is Jeff Posnick, and I'm a member of the Web Developer Relations team at Google. So, as you've heard, I'm going to go on a journey. So everybody who's watching this, either in person or watching via the live stream, we care about building truly progressive web apps. And the thing is, many of us have put time and effort into our current projects. So building a progressive web app doesn't mean starting from scratch, though. As developers, what we need is advice about areas for improvement and different tactical fixes that we could apply to our existing code base. And in that spirit, let's set sail on a journey together. And what we're going to do is, little by little, we're going to transition an existing single-page web app into a progressive web app. All right, so this is our starting point. We've got this web app, something I put together. It uses the iFixit API to access repair guides. Okay, pretty straightforward. The initial implementation is a single-page web app that uses client-side rendering. Okay, and while this project uses React, the concepts we're going to talk about really apply to any framework or vanilla JavaScript. It just so happens I was using React for this project. So let's take a quick look at the initial experience of running this in, let's say, Firefox. Let me just confirm I have my static dev server running right now. Go up here. Pull it open. OK. See some repair guides. Click around a bit. You know, it's all doing some client-side rendering. It's, you know, maybe not the fastest in the world, but it works. You could view your content. Let's take a look at something else. Let's take a look at what the experience is in Safari, and this happens to be Safari with JavaScript disabled. Some users have JavaScript disabled. Some users are in browsers that don't support JavaScript. Yeah, this is an issue. And this is what they say for a single-page web app. Not great. And you know, again, this is a function of being client-side rendered and relying on JavaScript. So let's see what we could do. Now that we have a feel for what the app does, let's try to figure out how we can improve on the current implementation. And what we're going to do is use that tool that Matt just talked about called Lighthouse to automate a whole suite of diagnostic tests covering areas important for progressive web apps. So what we're doing right now at our starting point is kind of running it to establish a baseline. And it's going to give us an idea of what's working well and areas that we can improve. So we're going to start the test via a Chrome extension in this case. But you know, as mentioned, there's also this command line tool that has the same functionality if you prefer that. And the tests are actually really cool. They use the Chrome debugging protocol, and they simulate a host of different real-world conditions to see how your web app actually responds. So let me pull that up. I'm going to do this in Chrome Canary. I am kind of old school and just like doing everything in incognito windows whenever I'm working with anything. So let's get our current version loaded. We have Lighthouse ready to go over here. And we click Generate Report. And you can actually see it's doing its job. It's using like the DevTools ability to simulate this viewport widths of different things and all sorts of other stuff. And we can get our score. So hopefully this is big enough for folks to read. You know, and we're at 30 out of 100. OK. You know, it's giving us some no's here. And it's giving us some things that might be areas where we can improve. Service workers, not there. Meaningful paint times, not great. You know, we have this missing content when scripts are not available. We have a bunch of other things that we could improve. So, you know, the main thing is that we have a really good starting point. We know what we need to focus on. Before we really dive into the results and interpreting them, I just want to make this point, though. Lighthouse will help us identify areas of improvement, but it's not our end destination. It's not the ultimate source of truth as to whether something is or is not a progressive web app. Ultimately, what matters is the experience that your web app provides to your entire user community. So in addition to running Lighthouse tests, what we're going to do is try web apps across a wide range of browsers, operating systems, and different network conditions. And I recommend that everybody does that as part of their normal testing and release process. Don't just rely on Lighthouse. All right, so we have those results. Here are opportunities for improvement. Our speed scores could be better, and there's no content on our page when JavaScript is disabled. And what we could do for both of those is introduce server-side rendering. Second, it looks like our web app won't respond well offline, so no surprise, we could add in a service worker. And finally, there's missing metadata about our application, as per the Lighthouse report. And that could all be addressed by adding in a web app manifest and also adding in thoughtfully chosen meta tags to accompany that. So we've got 3 concrete steps we could take, and we're going to walk through them each now using Lighthouse and cross-browser testing to measure how effective our work is as we go. All right, so let's first look into server-side rendering, what that's all about. What it's going to mean is that our browser gets a fully populated functional page as part of the initial HTTP response rather than relying on multiple requests to get content on the screen. And equally important, it means that our web app will work in browsers in which JavaScript is unsupported or just switched off entirely. So not every web app is going to be able to run with full fidelity with JavaScript disabled, but in our case, we should be fine. It's fairly straightforward to add in server-side rendering to our React application using universal JavaScript. And that means that we get to share a lot of code between the client and the server, so not too much work. And we're going to use Express, which is a node-based web server, and it plays really nicely with the React router. So while we're talking about React now, again, other frameworks like Angular and Ember have their own solutions for server-rendered JavaScript, so definitely check those out as well if you happen to use those. All right, so let's take a look at the actual changes that we're going to make in order to implement that. So I happen to have a handy GitHub diff open, so it's the real code. Let me make this a little bit bigger so folks could see. And just scrolling up a bit, not too much that it should surprise most folks who have done this sort of thing before. We're adding in a serve task that's going to bring up our server. And scroll down a little bit. This stuff is important, but we can't really focus on it right now. And what I'm going to scroll down to is the part that actually implements our routing and figuring out what to return to the client. And this is very lightly adapted based on kind of the React router canonical example. So what we're going to do is just take our existing routes that we're already using on the client side, and we're going to match against those with the incoming request URL on the server. We have a few things to handle different error conditions. And what we're then going to do is just make the request to the iFixit API from the server. It's going to figure out what data we need, and the servers are going to make those requests and provide it to the client immediately without the client having to get anything else. And we have a little bit of code down here. Once all the data fetching is complete, we just have our initial component that we're going to then kind of render to string using this React DOM server helper method. And we are going to also take all that initial state that we have on the server and turn it into something that's serialized that we can then deserialize on the client and kind of just have a nice experience where the client takes over once that initial payload comes down. And finally, just a pretty straightforward index template that just has placeholders for a state and for the React HTML and that sort of thing. All right, so that is what's changed in this step. And All right, so what we're going to actually now do is run that new code and confirm, make sure that our changes had the effect that we wanted in both in Lighthouse and in actual browsers. All right, so I'm going to just switch back over here. And it's not really live coding, but it's kind of close. So we're going to actually run our build process again, get to see that all go, and our new server is going to start up. And this time, we're going to be on port 8080. Once that's done. All right. So, OK, let me just start this up again. And we'll test again in Firefox. Things look good. You know, it behaves the way we want it to behave. That's great. We didn't break anything, at least. But let's actually go to that Safari that has JavaScript disabled still and see what the experience is like there. And we actually have content this time, so that's great. It's a net win for those users. If we click around a little bit, you can see, you know, it's not the same smooth transitions and other things you get if you did have JavaScript enabled, but you know, we're building an application to view this content, and our users, a subset of our user population, can now view it. So, you know, we should definitely consider that a win. All right, and let's also go and rerun Lighthouse. Should just close this down, start this up again. Generate another report. And, you know, hopefully we'll actually be able to, you know, assign a number and measure some of the impact that that change had and see it in our Lighthouse results. OK, so, you know, we're at 30 out of 100. We're up to 44 out of 100. It's progress. And, you know, most importantly, we see the changes where we kind of expected to. Like, we have our page contains some content when scripts are not available is now a yes. So that's a win. You know, we actually also see an improvement in the performance. It's actually, you know, the page load performance is fast. Test is actually pretty significantly better. You know, we were going from 2.4 seconds down to, you know, 647 milliseconds for the first meaningful paint. So, you know, server-side rendering was a win for that. So we're in the right direction. That all is cool. All right, so next up, let's try adding a service worker to address some of the Lighthouse feedback about speed and offline functionality. So first, important reminder, I've heard a lot today, we need to treat service worker as a progressive enhancement. Not all browsers support service workers yet, and you know, we want to be careful that we don't do anything to degrade the experience on browsers that don't support it. And it's also important to keep in mind, even on browsers that do support service workers, the very first time your users visit your page, the service worker won't be installed yet. So having a good experience, you know, for that case is super important. All right, with that out of the way, what we're going to do is use that app shell plus dynamic content model that's been mentioned a few times. And you know, this is something that happens to work really well with single page applications. We're starting with a single page application. It's kind of natural to adopt it in this particular case. And what it's going to do is take the shell, which is all the local HTML, JavaScript, and CSS that we need to render kind of like the outline of our application, and make sure that it gets loaded directly from the cache whenever possible, completely bypassing the network. And taking the network out of the critical path for getting things on the screen is the surest way to get consistent, fast performance. So that's super important. And what we're next going to do is take a runtime caching strategy to handle the requests for our dynamic content. You know, in our case, this is coming from the iFixit API. So it's going to populate that after the shell is loaded. And under the hood, not surprisingly, we're going to use a tool that Matt just talked about called SW Precache. And it's going to generate our service worker for us, and it's going to implement all the caching strategies too. So, you know, not too much code that we have to write in this particular case. But what we really do have to do is understand what our network traffic is and understand, you know, what we're actually requesting. And you know, this is important because we have to actually set up those routes and can't just put in arbitrary URLs for that. You need to know what's going on. I always turn to the dev tools in Chrome to do this. There are other browsers that have fantastic dev tools as well. But let's just go to Chrome for a second now. And we're going to do this again in a fresh incognito window. And we open up DevTools here. Let me make it a little bit bigger. Go to network. Let's just see what happens. I do this all the time. This is just part of when I'm approaching just a new application, new service worker, you really need to understand what's going on in your network, because you are replacing this, basically. This is crucial. You have to make peace with this. So you can see some of the requests going on. This is basically like our app shell stuff. This is our local CSS. This is our local HTML. And then it starts making requests to, in this case, it's stuff from cloudfront.net, and it's the images that are being displayed on the screen. And lots of images. We load in some JavaScript and things like that. And let's click around a little bit. What ends up happening, not surprisingly, is it makes a request to the iFixit API on the client this time. So the initial iFixit API request was made on the server, but now it's the client's taking over. And it's just making a request to pull in that information about that guide. So that's being pulled in, more images, things like that. OK, kind of have a feel for what's going on now. So let's take a look at how we actually implemented the service worker in this particular case. So all right, I think this is the appropriate diff. All right, so this is what's changed. We're pulling in our SW precache library, and we added a task to our build process. In this particular case, we're using gulp. So we're using the syntax for that, but there are other ways of using SW precache. Folks who really like NPM scripts, you could put this all as a command line and read in the config via JSON. We're pretty agnostic when it comes to that. And there's some boilerplate, but these kind of the interesting bits for what we're doing over here. So first of all, static file globs. This is a bunch of patterns that match all the local static files, and these are the things that kind of get requested as part of our app shell. So we just need to tell SW precache where to look, and if we end up adding in anything, if we make any changes to our JavaScript, if we add in extra images later on, it'll just automatically be picked up as part of the build process, which is great. Less for us to worry about. Next, we have this dynamic URL to dependencies section, and this is unfortunately a mystery to some folks. Definitely could do a better job of explaining it, so here's my attempt to do a better job to explaining it. You could pretty easily figure out when something that's local on disk has changed. If you have an image, if you have a CSS file that's in a local directory, you could just calculate the hash and figure out it's changed. What we're doing is taking these dynamic URLs. These are not things that correspond to actual HTML files on disk. And one example of that in this case is /shell, which is a URL we're using for our app shell. And this is effectively server rendered. It's kind of a composite of a bunch of different things. There's some JavaScript, there's some CSS, there's the actual underlying template for the overall structure. And all of those things go into uniquely determining what the content is for /shell. So in order to make sure that we actually have a cache that's automatically kept up to date for /shell, we need to tell SW precache, take a look at all these local files. If any of them change, consider that the /shell cache content is basically invalidated, and refetch it and make sure that we have the latest. So again, if you're not doing stuff that has server-side rendering, it's not as important. You can get away with not doing it, but it's actually a pretty good solution for this pretty common use case. And very closely related to that is the next section. This kind of implements a brute force service worker routing. It's kind of like isomorphic JavaScript, sort of, because we have the server that has to know about routing, we have the client that has to know about routing, and we also have the service worker in this case that has to know about routing. Because once you navigate to some random URL with your initial navigation, like /guide/12345 or whatever, That's not a real URL that the service worker knows about, and we don't want to just panic and give up and pass on to the server. We want to say, hey, actually, whenever you see something like that, which is a URL that you don't have explicitly in the cache, I would like you to fall back to this cached content of /shell. So it's basically doing real brute force routing. We might improve this in the future and have a little bit more flexibility, but for now, we're just going to route everything to shell. And finally, as mentioned previously, you can use SW toolbox strategies for dynamic caching within your SW pre-cache config. It just kind of saves having to maintain things in two separate places. And we went through the process already of looking in the network panel in DevTools, and we figured out what our dynamic traffic is. We have these iFixit API requests. That's what they look like. And let's use the fastest standard, which is basically stale while revalidate for all those. And for the images, let's do something a little different. We're going to use cache first, because chances are an image with the same URL at this remote server is not going to change. It should be safe, at least for our case. And we have the dedicated cache. We're using that max entries there. This is super important. It's something you can't actually get just with the service worker primitives right now. We had to build on top of those primitives and use like IndexedDB to keep track of all the entries in your service worker cache, and then allow you to expire the ones once you reach that limit. And definitely think about it. Folks don't have to use service worker toolbox. They don't have to use free cache. You could definitely do vanilla service workers if you want, but please keep this in mind. Like if you are building something and you're just caching things as you go, you really do need to think about your user's cache eventually filling up. So, and then we just have this default over here of network first, and we have a little bit more boilerplate. We add in a task, and finally, kind of making sure that we're only attempting to register our service worker if there actually is service worker support. So okay, so that's what's changed. And let's start up modified version. At step 3 now. And as part of this process, you'll actually see that the service worker generation. So SW pre-cache will log a bunch of output telling you what it's caching and what the expected size of the pre-cache initial payload is. So see that extra output over here, and our server is running again. All right, so we're going to just confirm that in Chrome right now. You can remember, see all this. This was the previous version. It's fetching stuff from the network. Let's again kind of close things out. Start fresh. And in this particular case, very first time, everything's still coming from the network. And this is because the service worker is not in place yet. So that's expected. And the next time, though, that I end up reloading the page, for instance, I don't think that DevTools is happy right now. Boo. Try closing this out. All right, I think Chrome Canary crashed, which is one of the joys of demoing things in Chrome Canary. Let's just start that up again. We'll open the network panel. Okay, and we see our initial stuff coming from the network. We're going to reload. And now we see what we expect. So we actually see over here from service worker. So this is how we could confirm just visually in DevTools that things are behaving as they should. Our app shell is coming from the service worker. You could actually see the that fastest strategy in practice over here, where it's pulling in an additional copy from the network in addition to returning it from the cache. So you are making a network request, but most of the stuff is just coming directly from the service worker, which is great. And let's see how Lighthouse feels about that. So unfortunately, kind of lost our previous reports, but I think we were at like 44 out of 100. And hopefully we're a little bit higher now. All right, so we moved up a bit. We're up at 59 out of 100. So we are making progress in the right direction. And again, importantly, the things that we expect to have changed actually did change, confirming that this is not all for naught. We have a registered service worker. It responds when we're offline. And that all is great. Also, let me try just tempting fate with Chrome Canary. I'm just going to do the offline over here. And just, again, do a navigation. So it worked. OK, if you trust that that actually simulates things being offline. So OK, definitely making progress in the right direction. All right, and finally, let's address the missing application metadata. So these are the options that allow you to control how your web app behaves when it's added to a mobile home screen, primarily. That's mainly what they're used for. And we'll add the metadata in both the web app manifest format and whenever possible, whenever it makes sense, use equivalent meta tags with the goal of supporting a wide range of different browsers. Don't just set this metadata indiscriminately, though. Really, give some thought about each of the tags. Don't just copy things that you saw in the example. Some of them have really important meanings, like whether you're going to end up behaving like a standalone application that hides the browser's URL bar. Maybe that's not appropriate for your particular case. That's fine. As a developer, you get to make that decision, and you can do what you think is best for your users. That should be the ultimate goal. All right, so let's take a look at what's different. We have our wonderful icon that's been added in. We have our manifest. I am specifying the icon. This is a little interesting. I'm actually using this UTM source equals home screen parameter as part of my start URL. So if you had Google Analytics running for your web application, you can actually keep track of where it's been launched from. SW Precache actually knows about these parameters and will not cause you to have to cache like a version that has slash and a version that has slash UTM source equals home screen. It'll take care of that for you, which is nice. And in our case, we're using display equals standalone. And here we have some related metadata. We're setting theme color, we're setting Apple Touch icon, and we're setting this Apple mobile web app capable content equals yes tag. And again, not everybody needs to use this exact setting. All right, so let's take a look after making those changes and see what effect they had. We're going to run through the build process one last time. And what I'm actually going to do first is fire up iOS Safari running in like the device emulator. I want to test what that experience is like. Because we've added some metadata that's relevant to mobile Safari. Let's see if it's actually doing what we want. So I think I have it running over here. We have localhost 8080. We have our basic web app. Cool. All right, let's see what happens when you try to add it to your home screen. Add to home screen. All right, it picked up our icon. In this particular case, we're adding to home screen from the main page, so it's going to use the main page as the URL. Paul Kinlan earlier talked about some interesting ways of kind of handling the case where a user might add to home screen while you're on one of the sub pages and redirecting to make sure that it actually always takes them back to the initial page when they do launch that shortcut. But for our particular case, pretty straightforward. And click on add. We go over here, scroll over. We have our web app saved over there. OK, that's what we want. Let's take a look at, again, start a fresh incognito window. And let's take a look this time at that nifty new application panel. This all looks good. We have our metadata. We can see that's parsed. We can see like the actual theme color live. So everything seems pretty good. Let's see if we have made Lighthouse happier with us. go through the report generation process again. And I think we were at something like 60 out of 100 last time, something along those lines. Cool, we're up to 94. So yeah, we went from 59 out of 100, and we had a bunch of no's over here. And we have some yeses now, so that's great. So, I think that this process is definitely useful, as Matt mentioned previously, as part of continuous integration in addition to that process, and making sure that you didn't accidentally have some regression that's causing a really big drop in your Lighthouse score. That's super important just as one additional check. But okay, so we're getting to the end of this talk, but as developers, our journey really is never over. New features like constructible response streams that Jake was talking about earlier, for instance, as they're rolled out more widely, present additional opportunities for enhancement. And I hope you'll be inspired to follow my lead, though, and use Lighthouse to guide you towards the ultimate destination, and that's a progressive web app that delights your users. You need to focus on your users. All right, here's a few links, and I know I'm a little short on time. Definitely check those out. I'm going to just highlight in particular the progressive web app codelabs. You could do them in person here for folks who are watching this via video. You could go to that URL. Definitely walk you through a lot of the stuff that we talked about in this session in a hands-on way. All right, so thanks everybody. Please grab me. Afterwards, ping me on Twitter if you want to chat more about the progressive web app journey. And next up, we have Tal, who's going to talk about building for billions. Cheers. Thank you.
We can. Got some slides swapping there. Hi, everyone. My name is Tal Oppenheimer. I'm a product manager on the Chrome team, and I'm here to talk to you about how you can use all the technologies that we've learned about today to make sure that your experiences can work for billions of users. So when we're talking about billions of users, that's a pretty big number. And that means that we really need to think about how can we reach all of our possible users. And one of the really critical things here is to figure out who your users are and to actually understand how they'll be accessing your experience and what this means. Now, for a lot of us, we spend a lot of time thinking about what problem we're trying to solve and we sort of have this mental image in our head of who our user might be. And for many of us, this can look a lot like us based on just what you're used to and the experiences that you've had. And this can lead to a perception of the world that looks something like this. And now we are in Amsterdam, so a few of us might be thinking a little bit outside of the United States, and you can throw sort of Europe in there as well. But this isn't the whole world by any means, and it's definitely not your user base when you're thinking about all of the internet users. So today, there are roughly 3.3 billion users using the internet around the world. And if we actually drill down and look at where these users are, this is a map of internet users today by country. And you'll see that while there are some users in the United States and some in Europe, we see much more pronounced number of users in a lot of these other areas. So while the US has about 286 million internet users, India has 462 million internet users, and China actually has almost as much as the two of these combined, with around 721 million internet users. But what's really striking here is not just where the internet users are today, but looking at where the growth is coming from. So if you look at a snapshot over the last year, you'll see that in the last year, a lot of internet users came online in one very specific country, and this is India. So we saw over the last year that 108 million users came online in India alone. And for India, this was actually a growth of 30% year over year compared to the number of users that they had before. And this growth was 10 times more than the growth we saw in China in terms of absolute users, and over 100 times more the growth we saw in any other country over the last year. And just to put this in context, this growth in India in a single year was equal to 1/3 of the United States' entire population. And that's just in 1 year. And what's more is actually, if we look at who's not yet online and where we sort of predict that the growth will be coming from, we see this shift away from the United States and Europe to other countries. So in India, you still have 864 million users not yet online. The current user base, there's still 65% of India's entire population not online, or over 20 times the number that's not yet online in the United States or similar areas. And so this sort of question can come up. How do we reach these users if we need to be sure that we're building for all of them and thinking about all of them? And as I mentioned before, what's really critical here is to understand your users and understand who they are. So I know we've been sitting for a little while, but just with a quick show of hands, how many of you remember the first time that you accessed the internet? OK, looks like most of us do. Now, keep your hands up if that was on a mobile device. OK, we've got no hands up at this point. So most of us probably accessed the internet for the first time on a desktop machine or maybe a laptop. But when I was in India last year, we spent a whole lot of time talking to internet users who were maybe newer to the internet or had been using it for a fair amount of time. And I was sitting down with a woman who was sort of in her mid-40s. We were sitting in her living room, and I asked her the same question, if she remembered when she accessed the internet for the first time and what device she used to access it. And her answer was yes. She did remember the first time she used the internet. It had been earlier that year. She borrowed her husband's cell phone and accessed the internet for the very first time. A few months later, she got her own cell phone and was now able to regularly access the internet. And so what this means is that how people are coming to your experience and interacting with it is just fundamentally different. We've heard the mantra mobile first probably a number of times. And for us, this often means thinking about design mobile first, thinking about how our experience would work on a mobile phone. But for a lot of these users, how they're actually accessing with the internet isn't necessarily mobile first. It's actually mobile only. They haven't had an experience on a desktop or a laptop computer. And they may not be using one regularly, and they may not even in the coming years be using one regularly. So in terms of how they'll be interacting with your experience, it is only going to be on that mobile phone. And so this means that you really need to think about what your experience can be like for users who may not have had experience interacting with your product on other platforms, and making sure that you're still designing for that in mind. But beyond just the sort of using mobile first, this means that it's also really important for us to think about what the device that users are using are like. So taking a look at one device, this is a device that some of us might have in our pocket. This is the Nexus 6P, and it was released in 2015, so last year. It's a pretty big device, 5.7 inches, measured diagonally. It has 3 gigabytes of RAM, and then depending on how much you want to buy and how much you feel you need, it can have either 32 to 128 gigabytes of storage. Now, in comparison, when we were in India, we went to a number of stores and actually asked the shopkeepers, what device do you sell? What device do people ask for? What would you recommend for me? And this is just an example of one device. This is a Samsung J1. And this device was also released in 2015. It's 4.3 inches measured diagonally, so a bit smaller. It has 512 megabytes of RAM and 4 gigabytes of storage. So these are two devices that were released in the same year, but have very different specs. We see 1/6 of the RAM, and even in the best case scenario, 1/8 of the storage capacity. And this means that the user is going to be accessing your experience on their mobile phone under a very different context than the phone you might have in your pocket, and the phone that you might be testing on and seeing what your experience looks like. And now the difference in context goes beyond just the physical form factor of the device that they're using. Because they're relying on cell phones, this also means that cellular connection is their primary way of accessing the internet fairly often. Now, many of us are probably used to accessing Wi-Fi. We've connected to Wi-Fi here, probably sometimes complaining about its speed. This isn't necessarily the case for the users. And it's because you're relying on something that's in your pocket. As you move and shift scenarios, so does your connection to the internet. And you need to keep this in mind when you're building experiences. But this phenomenon is happening all over the world. We also see that in the United States, 20% of US households rely only on cellular data when they're making connections to the internet. And what's really interesting is that this number's actually doubled since 2013. So we're seeing this increasing. So the reliance on cellular networks as your primary way of interacting with the internet is increasing across the globe. And this has some consequences when you're thinking about the conditions that someone is trying to access your experience under. Now, we've heard a lot about sort of slower connections and the impact this can have. But we see that globally, about 60% of mobile connections are 2G. And this is just actual 2G connections. It's not necessarily talking about 2G-like speeds, which can actually be even larger. And when we start thinking about the areas where people are coming online for the first time, we see this more pronounced at about 2/3 of the connections. But what's more is that while we're seeing this decreasing, we're not seeing this decreasing at a very fast rate. The predictions, if you sort of estimate it out, is that by 2020, 1/5 of the connections globally will still be 2G. And again, this is still excluding those 2G-like speeds. So the problem of connection speed is going to persist for the foreseeable future. And we've seen some stats about this before, and it's sort of widely accepted that a delay in your experience has a very large impact on how users experience your site. And we've seen that a study found that one single second delay in your page load time can lead to 11% fewer page views, or a 16% decrease in customer satisfaction, if we're talking more qualitatively. And so that 2G connection that might have very slow round trip times, if that impacts what your experience is like for the user, is likely to have a very negative impact on how happy they are with what you've built. But beyond just the connection quality that is introduced by users relying very often on cellular connections, cost also starts to play more of a role here. So looking at India again, and doing an estimate of sort of minimum wage in India is a little bit complex as it depends on your job role, et cetera, and looking at how expensive a data plan is, with some simplifications, we see here that on average, it would require 17 hours of minimum wage work in India to purchase a 500 megabyte data plan. And we've been thinking about the mobile web, so just to put this in context, looking at sort of the average size of a web page today, if a user in India receiving minimum wage were to spend that entire paycheck on just data, just to access the mobile web, 1 hour of minimum wage work would load about 15 web pages. And just take a moment to think about how many web pages you've visited today, or even visited during the last talk or during this talk. And think about how many hours you would have had to spend to be able to afford that. And what this really means is that the cost of data requires a trade-off. If they use one thing, it means that they're not using something else. And they're constantly making these trade-offs to make sure that the data that they have is used in the best way possible. And this results in the frequency of their connectivity really varying. When data costs are so high, you need to make a choice if you're going to use one thing or the other, and sometimes you just want to turn it off altogether. One user that we spoke to actually said that on an average day, they turn airplane mode on and off 12 to 15 times. Because when you're not using your phone and you put it to the side, if data is this expensive, you want to make sure it's not getting used unless you find value out of it. And this means that if you're trying to get a user to interact with your experience, you really need to make it worth it for them, because they need to be willing to pay that amount to just access that experience. And so this might be a little bit daunting, right? These are a lot of different constraints and conditions under which people are accessing the internet that you may not be familiar with firsthand. And so you may be posed with the question, great, people are using mobile-only devices. Connections can be intermittent. They can be slow. And when they do exist, they're really expensive. So what can I sort of do? And what does this mean for how I develop? So some of the methods that we think about might be a little bit hard. Under some of these conditions, installs become really challenging, because what you need to do here is convince a user to pay the time and data costs to install your experience before they've even tried it out. And this can be really hard when the costs are so high and the networks are slow, because it can take sometimes hours to download a single app. And what's more, if the device has limited storage capacity, your APK size starts to be really, really important. You need to try to make sure that it's small so that a user doesn't have to delete photos or videos or other apps on their phone to make space for your experience. And what's more is, even beyond this first step, you're probably working to improve your experience, which probably means you want your user to update their app. And this is, once again, challenging, because they need to take that extra step on that slow connection or expensive connection. But you're all here. You probably all know that there's an app that solves a whole lot of this. The mobile web, as we know, solves a lot of these things just inherently in how users interact with it. Right? With the mobile web, as soon as they navigate to your experience, they see your experience. They don't have to take an extra step before they try it out. They got there, they see it, they can try it out. This also means that storage constraints for that initial interaction are non-existent. Just by virtue of finding it, they can see it and start using it. And it's always up to date. So as you continue to make improvements on your product, your users get them right out of the gate. And they don't have to go take an extra step just to see the latest and greatest that you've built. But as you know, we've been talking a lot about the reach that this introduces. And what we've seen, these are some stats that we talked about last year, is that removing these barriers has a real impact on the reach that your experience can have. We see that on average, users navigate past 25 apps per month. And this is compared to over 100 websites that a user will navigate past on Chrome on Android in a single month. And this not only is a breadth of experiences that users pass by, but has a real impact on the number of users that a single experience has. So looking at the top 1,000 mobile apps and the top 1,000 websites, we see that on average, there is 2.5 times as many users on the mobile web as there is on these top 1,000 mobile apps. And what we're seeing is that mobile web is also growing at 2 times the rate of native apps in terms of numbers of users in these same buckets of top 1,000. So really what this means is that the web inherently provides you a whole lot of reach. And we've been talking a lot about today is how you can use progressive web apps to not only leverage the reach that the web inherently has, but to build experiences that really work well for you and for your users so that they highlight and have all the capabilities that you need to build the best possible experience and for your users to get the best possible experiences. So I'm not going to focus on this too much because you've heard a lot of this today, but progressive web apps overall not only offer a very smooth experience, but they also offer a lot of options for how to support some of these other situations that you really need to think about when you're building for billions of users. So how can you leverage progressive web apps to actually reach and build great experiences for users around the world? So the first is cost. We talked about how cost can be very limiting for users to even try out your experience for the first time. So I'll talk about how you can leverage progressive web apps to really remove that barrier. And second is connectivity. When you do interact with these sort of flaky connections, how can you address that to make sure your experience is still as fast as possible so you're not incurring that 1-second delay that has a huge impact on users' experience? And finally, how can you make sure that you're making the experience as simple as possible and just removing as many extra steps that your users may or may not need to actually take so that things continue to be fast and efficient? So to jump into the first one, cost. Now on Chrome, we've been working on addressing this issue across the board. So we do have a Chrome data saver. This is a proxy for HTTP content that a user can turn on. And with functionally no fidelity change, users can see up to 60% data savings. But we've taken this a step further because we know that cost can be very constraining for some of our users. And we've actually decided that on slow connections for HTTP content, we will automatically replace most images on the pages with placeholders. We maintain things like navigation icons, etc., so users can continue to load the page. But at this point, the user's in control of where their data goes. So they can choose to load all the images on the page. They can long press on a single image to load it if they need it. But we're not using their data without their knowledge and without them needing it. And we've seen that we were able to increase data savings to over 70% in some of these situations. But we also know that this doesn't necessarily work for all experiences. And so there's also a number of client hints that you as a developer can use to make sure that you're optimizing the experience for the users based on the device that they do have. So with DPR width and viewport width, you can make sure that you're only sending the image size that you need to the users, and so that they're not incurring data costs for something they may not be using or may not actually need. What's more is we've also launched a save data header. And in Chrome, this maps directly to whether the user has that data saver feature turned on or not, which means that you as a developer know which users are the most data sensitive and can adapt your experience accordingly, and can do so in the way that works best for your product. So maybe that means only loading, one key image that's critical for it and making the other one sort of on demand for the user, or not auto-playing video, or whatever it might be that makes sure that you aren't removing constraints for the users who need it most, while still making sure that your experience works for them. But we also know that this can be challenging, and there's a lot of optimizations to go on. So we also have the page speed module, which is a server-side component that you can actually drop into your web server that will do a lot of these optimizations for you. And if you drop this in, this can do the optimizations on both HTTP and HTTPS content with functionally no fidelity change. So it's similar to that data saver feature that we have on Chrome overall, but you can do it on all types of content. And what we've also done is we've actually gone a step further, so that for the users who have data saver on, we do a few extra optimizations to make sure that we're really doing as much as possible to help those users who are feeling sort of most constrained or who have expressed interest in us saving them even more data. So just to give an example of this, this is an example of a mock storefront that we built. On the left, you'll see a screenshot of the store with no page speed. And on the right, you'll see it with page speed. Now, these look really familiar and very similar. If anyone can point out any differences, let me know afterwards. But they look functionally identical. But there are actually differences when you dig into this. So if you look at the one on the left here, this is 350 kilobyte paid, so it's relatively lightweight compared to sort of the average website across the board. But simulating a 2G connection, this page can take over a minute to load. And as we know, waiting is bad. It causes a bad user experience. It causes your metrics to hurt. And you really want to reduce that as much as possible. Now, by just having the optimize for bandwidth in page speed module, what we see is that we are able to actually shrink this to 165 kilobytes, or about 50% fewer bytes. But for users who have data saver on, and we go even further, we're actually able to shrink this to 120 kilobytes. And what's more is on the same simulated 2G connection, we actually drop the load time to under 30 seconds. And this is functionally with no fidelity change to the user. The user is seeing the same thing, but you are saving them data and saving them time just by dropping this one line of code in. And what we're seeing is, this is just one example, but we've seen that on average, even for users who do not have data saver on, we see about 37% data saving with no fidelity change at all. But beyond just removing cost and decreasing cost that comes with data usage on mobile, connectivity is really important, and you need to make sure that things load as quickly as possible. So just to give a sense of how these things can vary based on connection types. So round trip time, or the time between making a request and actually getting a response, varies pretty drastically between all these connection types. At one extreme, you often see sort of 50 milliseconds round trip times on Wi-Fi. I know conferences can be different. But at the other extreme, you have sort of 50 times slower on an average 2G network, with 2,500 milliseconds round trip times. And so this can be a little bit daunting. What can you actually do about this? So the first thing you can do is downlink max actually offers you a way to know which connection type in the first place your user is actually on when they're accessing your experience. And you can subscribe to updates. So if a user switches connection types, you as a developer know and can make sure that you're giving them the best possible experience and not incurring any of those delays that might otherwise happen. But what can you actually do about it when you do know, OK, my user is now on a 2G connection? So we've heard a lot about Service Worker today. Right? We know it's a client-side proxy and written in JavaScript, and you can use it to support offline and all these things. But you can also use it to make sure that your experience is as fast as possible. So Jake this morning talked about Li-Fi, or the experience where your phone thinks it's connected, but you as a user are not actually getting anything, and this can be incredibly frustrating. And this isn't only those sort of really flaky intermittent connections, but this can also be the case when you're on a really, really slow connection, and the round trip times are just so large. And so what you can do here is with Service Worker, you can actually implement request timeouts to address these flaky connections, so that if a user is on that really slow connection, they're still getting something very, very quickly, and they're not waiting for it to load. But we do know that sometimes there's no connection. Right? We've seen this offline dyno a lot today when we've been talking about Service Worker, and we're really trying to make sure that you all have all the tools you need to kill the offline dyno and make sure that when a user goes to your experience, they're never going to see this offline dinosaur. But there's been a lot of interesting ways that we've seen people who have been leveraging progressive web apps address the offline situation in a way that addresses the flows that are most critical to them. So just as one example, this is Conga. Conga is one of the top e-commerce sites in Africa, and they will actually be talking a lot more detail about their progressive web app tomorrow. And what they've done is they've built a checkout flow that can work completely offline. So if a user's online and adds some things to their cart, and then loses connectivity or goes offline or turns on airplane mode for whatever reason it might be, they've actually adjusted their flow so that instead of having an online checkout flow, it has sort of a call to order flow, so that the user can still complete the transaction or the flow that's most critical for their product in a way that works regardless of their connectivity type. So they've really taken their time to think through what is the critical use case for our users, and how can we actually let them complete that use case even if they have no connection. And what's more is they've actually found that for that critical flow, this has shown a lot of improvement. So compared to their previous mobile website, this used 84% less data. And so addressing a lot of these speed connection issues also has a benefit of addressing some of those cost issues that we talked about earlier. What's even more is that compared to their native app, this new flow actually used 82% less data. So this has been a drastic improvement not only to their previous mobile website, but also to their native app experience. And again, they'll be talking a lot more about their overall work tomorrow morning, so feel free to come to that. But beyond just trying to address connectivity and cost, removing complexity is always a good thing. Making things easier is always just going to be better for your users. And when we're talking about users that are sort of coming online for the first time, every step you're asking your user to take is time and money. Because on those 2G connections, every page load is just going to be sometimes minutes of waiting. So if you're giving them a page load, you need to make sure that that page load provides value. And if it doesn't, get rid of that step. And there's a few ways that we can make that happen. So we've talked a lot about add to home screen and how you can use this as an easy way for users to get back to your experience. This can also be used as an easy way to cut out steps for your user, so that users who are more engaged and have expressed interest in your site can, with one tap, get right into your site. They don't have to take extra navigations, wait those 5-10 minutes, spend that data on those page loads, just to get to your experience. They can tap on it straight from their home screen. But beyond that, with the notifications, you can also make sure to deep link them to specifically the part of your experience at the most critical times, so that they're not taking extra steps even within your product experience to get to the part that might be most relevant to them. So this means that regardless of what their connection is or their cost is, you've just removed steps, and they don't have to wait that extra time unless it provides value to them. But one of the things we talked about is that it can be really hard to try this out and make sure you understand what it's like. And so there are a few tools you can use to actually test this experience directly and make sure you're testing it with a global perspective and under all of these different situations that maybe aren't what you have in your pocket or what you use on a daily basis. So we do have a mini mobile device lab, and it's up on GitHub. And so this will let you simulate a bunch of different devices. So you don't have to go out and buy, 1.5 million devices, but you can make sure you're simulating your experience on all of these different devices to see what users who use devices that are very different for yours are actually experiencing. But what's more is you can actually use dev tools to understand the cost of your experience. So just to walk you through one thing here. So we've talked a lot about dev tools, but I want to call your attention to the network piece specifically. And so you'll see a button at the bottom here that actually lets you know what the payload of your load was. And so right now at the start, it's sort of pretty light, 785. If we look a little bit more into this, we notice a lot of things came from cache, so probably why it was pretty light. But you can actually just go ahead and hit refresh here. And now you'll see that sort of on a fresh load, this was actually quite a bit heavier. And so it was over 200 kilobytes. And so this is just one example, but you can use this as you're navigating through your experience to get a sense of like, okay, how many megabytes is a user using if they're actually actively using my experience? But going beyond this, you can also use this to understand the time and how much time users are spending on just waiting for your page to load. So you'll see the time down here, right next to the megabytes. But what's more is you'll also notice that up here you can throttle it and change the simulated network speed so that you're not relying just on your Wi-Fi to see how the page load actually happens. So if you'll see that if we change this to 2G, this actually starts going from 600 milliseconds that we saw before to roughly 11 seconds for just this page to load. And what you can do is, as you adapt your experience, as you use Service Worker and all these other technologies that we've talked about, you can see how this changes and make sure that you're really optimizing for experiences and that you're building an experience that you would be happy to use if you were actually facing sort of some of these other conditions that you might not have firsthand experience with. So the main idea here is that by keeping sort of 3 principles in mind, you can make sure that the experience you're building not only leverages the reach of the web, but also takes advantage of progressive web app technologies to build the best possible experience for your users across the board. And we have a lot of different technologies and details about how you can apply these, not only for progressive web apps, but specifically to address the needs of billions of users online. So feel free to go there for more details. But the big takeaway here is that just by keeping in mind the fact that not all users who are using your experience look like you and are accessing the experience under similar constraints, you can do a whole lot to make your experience much more accessible and as a result have a much larger reach and have the potential to reach billions of users. And so with all of this, you can really build an experience that is built to work well for everyone. And with that, I'm going to hand it over to Chris Wilson to wrap it up for the day. Thank you very much.
Good evening. Let's skip the slides ahead here. OK. So good evening. I'm Chris Wilson. I'm a developer advocate on the web platform at Google. And I've worked on the web platform for a super long time. I actually just had my 23rd anniversary of working on the web platform. And I have to say, this is one of the most exciting times in that history, because progressive web apps are an amazing breakthrough in user experience. Like, this lets you build stuff that really just works for users. And this is the first time I can actually say that and not kind of grimace a little bit inside when I say that. So I hope that we filled your heads with a ton of really interesting stuff today. I hope that we've given you a lot of grounding of what you can build and how you can go about getting started. I hope we've impressed you with the opportunities, both in market opportunities and, as Tal just talked about, in addressing emerging markets, which I think is a really great opportunity for the web as well. So in this talk, I want to discuss a few areas that are still kind of under construction. This isn't stuff you necessarily want to be putting into production today. A couple things in here are, but most of it is sort of to spark what's going to come next in the future. So this is kind of the next level of user experience. And if you saw my Google I/O talk pretty recently, what's next for the web, you might think this is just a replay of that, and it totally is not. This is not a whirlwind deluge eye chart of new features. I actually just want to focus on 3 important challenges that are relative to progressive web apps. First and foremost, knowing who the user is, aka authentication and sign-on, and enabling the user to pay for things on the web, which would be kind of nice. And finally, connecting with hardware, which is kind of near and dear to my heart personally. But I'm going to talk through some developments in each one of these, and starting with knowing who the user is, sign-in in particular. Now, let's take a look at an average sign-in screen today. Like, this is what users land on most of the time. And they often have a lot of problems with this. I know I do, because every time I go back to a service, I can't remember, did I sign up with this with my Google Plus account? Did I use Facebook? Which email address did I use? Because I have multiple email addresses. All I want to do is get to the application. And of course, my favorite button on this entire page is Forgot Password. Is there anybody here who's never used a Forgot Password button? Oh, you're my hero, right there. Okay. Or you're lying, which is actually, I'm not calling you a liar. But anyhow, on top of that, mobile devices, which of course a lot of browsing has been moving to mobile, it's really, really hard to type, particularly things that are not, words in your preferred language. And especially when you're using different characters like you do in a password. I know, for example, I have optimized at least one of my passwords to have characters that are more easily accessible on a mobile device screen. So I don't use tildes in my passwords anymore because it's 2 extra taps away on an Android on-screen keyboard. And I'm sure you can understand this leads to a problem. I'm sure some of you know what this is already, so just call it out. What do you think this number is? Most commonly used password. That's right. This was the most popular password in 2015. It edged out the previously most common password, password. And of course, this isn't even getting into how many of us share passwords across different services. I mean, how many of you share passwords across services? Because I would never do that. The point, though, is the complexity of remembering passwords leads users to use weak passwords or to share them, and that, of course, is a significant security risk. So Chrome, and pretty much every browser out there, try to encourage stronger passwords by using a bunch of heuristics to automatically detect when you've signed in successfully, and prompting the user to save it, and then autofilling it when the user returns to the site. You don't need to remember, you don't need to type anything. Hopefully this will just work. And Chrome actually also has, and several other browsers have features that will synchronize that across different devices as long as you're signed into Chrome. And in Chrome for Android, this also applies to Android native apps. So Android native apps get the same password data. But even just Chrome's password manager alone assists 8 billion sign-ins a month. Like 8 billion times during a single month is how many times that saves somebody from typing in a username and password. Now, to a large extent, this should just work. Like, you shouldn't have to do anything. I should have stopped talking about this like 3 minutes ago. But since this is auto-detection, this is guessing, it's best to give password managers hints so that they can guarantee that their password forms are being treated properly. The best thing is, of course, that these hints actually work across all modern browsers. This isn't Chrome guidance that I'm giving you. This just kind of works. So despite this talk being mostly about what's next, go do this right now. Since password managers are heuristic-based, sometimes extracting that semantic information is difficult. just give us a hint. Like here, we can't really tell what the username is. Is it display name, phone, email? So you can solve this simply by putting in autocomplete attributes, username and password. And if you're marking up passwords, use current password, because when you have account creation or changing password forms, you can use new password for where the new password is going. And this has two effects. I'm only mentioning this because there's one really interesting one. The first boring one is simply, this prevents password managers from plugging a password you already used into a new password field. But when you mark up your forms with new password, the browser can also tell that you're trying to generate a new password, and you can do it for them. Like we can go ahead and just auto-generate a password for you. So instead of a password like this, you will get this. Well, not exactly this. I mean, don't write this down or anything. Something like this. Like we've been experimenting with auto-generating passwords in Chrome for a while. It's actually in Chrome Canary dev and beta channels. Hope to deploy it to stable soon. But if you properly mark up your fields with new password, it will make this possible. We'll be able to do this, and other browsers will too. But setting aside that stuff, what's really next generation for sign-in is using something called the Credential Management API. Now, we've just shipped this in Chrome. It's still kind of early days, certainly not implemented across all browsers yet. But the Credential Management API gets you away from using form fields with wacky autocomplete properties attached to it, and lets you integrate more deeply into the sign-in process of the browser. So you can also, by the way, use this to sign into federated services, which is kind of hard to do in a form. So AliExpress, which I think we talked about earlier, is actually a really great example of a user flow, because it's a shopping app. It's really important for users to be signed in right away to ensure that if they have items in their cart, they're still there. If they have preferences or stuff that they've been looking at or wish lists, it's already there. But at the same time, you really don't want to force the user to log in as the first step. Like, you don't want to take that active step of saying, OK, give me your username and password before I show you anything. Because if they're a new user, of course, they may just want to browse. Or I may just be searching for something new. I don't want another step in my way. So with AliExpress, when a user launches from the home screen, it loads up this app shell. And during the startup, the app asks the browser for the user's credentials, if it can get them without bothering the user. And then they can sign the user in. You can see this at the bottom here. And they don't need to ask the user in this case. Now, they do this in the Credential Manager API, and the code for this flow is really pretty straightforward. There's just a navigator.credentials object, and you have a get method. You can ask it, you pass it in some options, you say this is a password-based credential, and most importantly here, I want this to be unmediated. I don't want to prompt the user from this call. So this code is actually safe to put on every page in your app to try to trigger sign-in, because it won't ever interrupt the user's flow. It won't ever pop up a dialog. It will just fail if it can't do it automatically. Now, auto sign-in is kind of new for the web. We're starting out pretty conservative. So the browser will only hand over these credentials if the user has turned on automatic sign-in, and if this user only has one credential for the site. If they have multiple credentials, we don't want to pick for them. We want to make sure that they get to choose. And of course, this would be an interesting security place. So we need to make sure it's kept secure. So Credential Manager API is restricted to secure contexts, like many new features. And passwords are never actually directly exposed. Like when you do get, what you get back as an object that has the password, which you can then hand to fetch to post to a same-site endpoint. And it has to be a same-site endpoint. You can't be pushing this off to other sites, of course. So once you get these credentials, when you actually want to sign in, you call fetch and pass it in a post. Now, when automatic sign-in isn't possible, Credential Manager API can still offer a one-tap login. It can still say, I want to sign in, and then trigger a chooser dialog. So the user can enter new credentials, or they can pick between multiple credentials that they have. So Chrome will present an account chooser, like this one. This one only has one available. But if you need to do this, you use almost exactly the code that you saw a minute ago. The only difference is there's no unmediated in this. So you can use this flow when the user clearly has an intent to sign in. Like if they click the login button, then obviously you can run this. So this is all great. You actually do need to forcibly store credentials. And this is where our heuristics often fail. But the Credential Manager API actually lets developers have the ability to choose when the save your password prompt is triggered. So Chrome isn't going to miss out on when the right time to trigger this is. So if the user has just entered their credentials into a form, you just create a new password credential and tell it to store. That constructor will deal with parsing your form, pulling all the fields out, that kind of stuff. And you can use this, as I mentioned before, for doing federated login. Google+, Facebook, any other federated login. You just have to create that credential using whatever that particular federated credential wants to use as an ID and a provider, so an identifier. And then the browser kind of just deals with the rest of the process for you. And finally, of course, we can forcibly sign you out. We can say, hey, don't ever automatically sign me back in, always prompt the next time that you call the Credential Manager API to do an automatic sign-in. So a number of companies are already using Credential Manager API or started working on it, in some cases deploying this in bits and pieces. You can play around with these today in Chrome because we shipped this in Chrome 51, so it's actually turned on already. But now I want to move on and talk about paying for things. Now, obviously, we've been able to pay for things on the web for quite a while, and it's no surprise that given the rise of mobile computing, a majority of commercial traffic is coming from mobile devices, like this one. What is surprising, though, is that 66% of purchases are actually happening from the web on mobile devices. So by and large, users are using the web to purchase things more than they're using native apps to purchase things. So I guess the web isn't dead after all. But unfortunately, there's a lot lower conversion rate, too. And conversion rate is a weird concept, so I want to make sure that I sort of capture this. 66% fewer conversions equates to if on average you make 3 euros per visitor to your site. Now on a mobile device, you're going to make 1 euro per visitor on your site, on average. Like, this is pretty bad, right? This means mobile users are not paying you as much, or they're not spending as much on your site. Now, if you wonder why, I think the answer is actually pretty simple. Because checking out, particularly on a mobile device, is still a pretty messy project. So checkout forms have improved since the beginning of web commerce, of course, but fundamentally, it's still kind of the same thing. I still have to manually input my credit card info, my billing address, my shipping address. This has gotten so bad for me personally, by the way. I get really, really excited when I go to a form and they have put the zip code first and they automatically fill out my city and state for me. Like, I'm so excited that they do this, when if you back up for a second, I shouldn't have to enter any of that. Like, it should just know what that information is. And of course, this is worse on mobile devices too, because if you thought typing your email address was bad, try typing a 16-digit credit card, especially when they forget to label the field properly and it gives you the QWERTY keyboard. Yeah, it's a mess. So just like with sign-in, our first step to solving this problem is autofill. Now, autofill works on existing forms. You don't have to modify your site, although it does actually do the same kind of autocomplete types, but stores the user's address and credit card info. You can manually save this in settings yourself. You can let it auto-detect it. Chrome will synchronize it, just like with user sign-ins. So autofill's great. I mean, it does actually improve the problem. It raises our conversion rates about 25%. On an existing site with no changes. But although autofill gets rid of the manual nature of data entry, it does make it simpler for the user, but it's fundamentally the same kind of existing checkout flow. You're still handing the user the same form. It's just they have a stamp for parts of it, and they just have to make sure they end up in the right places. So the web checkout process really needs to be kind of reinvented overall. Now, like I said before, the current checkout process is really pretty form-heavy. For users, though, the ideal experience would really be the server just works it out with the browser. Like the browser is your user agent. Like that's why we call it a user agent. It works on your behalf. So sites should be able to focus on creating an amazing and engaging shopping experience and not so much on that last set of pages that you have to navigate through that has a long checkout form. So this is where web payments comes in, with the payment request API. So payment request is a simple JavaScript API. It allows the browser to handle that heavy lifting of payment collection and give the user a one-tap checkout, but still make sure that the site is going to get the right set of information, not the wrong set of information, and the user has explicitly said, yes, I want to pay them this much money. So this is an openly developed standard API. No matter what browser, or platform, or payment method you choose, everyone should be able to pay without a checkout form. In the end, we're still working on this, but obviously we'll come back to that. This is under development in the W3C Web Payments Working Group. That group's goal is to create a universal, so cross-browser standard for any website to accept any form of payment. So this isn't a Chrome-only API. We want this to be supported across all browsers. In fact, I really want to give a shout out to Microsoft because they've done a ton of work in the Web Payments group as well. Some love, all right. And although we're targeting mobile first with Chrome's implementation, because that's where it's most impactful, payment request is explicitly designed to not be tied to a given platform. The goal really here is to create an open ecosystem where any website can accept any form of payment with minimal code changes and without any proprietary one-off payment APIs. So with autofill, we can eliminate that manual and tedious bit. Our implementation actually uses the same data from autofill too, so you won't have to enter your credit card details one more time if you've already done this. And since the browser is taking care of the steps of collecting the right set of information, we go from having multiple taps, multiple forms, to just one. You just have to approve it. So the flow here is really the site initiates a payment request. The website passes to the browser what it needs for that. So it says how much are you charging, what set of items do you need. Then the browser determines the intersection of what types of payments the site supports and what payments the user actually has, what payment methods. And then presents a selection UI to the user to choose which kind of payment app. This can be anything from a simple credit card to an installed payment app like Android Pay. And then the browser gets a response back on this and returns it to the merchant. And the merchant's website, now has everything they need to process the payment. So credit card info or the right set of tokens. So looking at this in code, I know this ends up being kind of small because it has a lot of information on it. But this is, by the way, based on the first published working draft. This may change. So like if you go back at this slide in a year, it's probably not going to be totally right on, but we'll see. When you create a payment request, which is the first line of this, all that you do is the first parameter is an array of what supported payment methods the merchant supports. So here they'll take Visa, MasterCard, Amex, Discover, but that's all, not any other credit cards or other payment apps or anything like that. Now, the default here is this, right? It is using credit cards to pay for things, because that's kind of still where we go. But they also pass in the line items, the set of things you're paying for, whether they want shipping options. So the website can actually support those shipping options and negotiate them later, and then update the total price. Now, I did talk about payment applications. I wanted to describe this in a little bit more detail. So Google launched Android Pay early last year. And we've seen phenomenal growth in people using it to pay for things on Android devices and with merchants, physical merchants. But what makes this even better than using your credit card directly, I should say, is that it uses a tokenized version of your card when it passes it to the merchant. So they can't reuse your card information. And of course, it uses device authentication to protect your transaction. It knows it's using your phone. It's not just a number, a credit card number. So let's take a look at Android Pay. All that you really do is you have the same payment request creation, but you give it a different supported type, a different supported payment method. And here, of course, Android Pay has some app-specific parameters. So it tells you what gateway it's going to use, what key it wants you to use, what version of the API. And of course, that would be different for different types, different payment apps. So you can get started with this today. It actually is supported, but it's in dev and beta builds of Chrome for Android. It's behind a flag until we launch late this year. And then we plan to add more platforms, including desktop, and the ability for third-party payment, so other payment applications to register with Chrome in 2017. So we've been working with a large set of partners on this. They've been testing this, kind of improving it. I explicitly put this up because I wanted to prompt people, if you're interested in this, it would be great to share feedback on it, for you to play with it, talk to us, talk to the W3C's working group, because I think that we really want to get to a great place with this API. Okay, so now you've got users who are logged in. They can pay for things. The final area that I really feel unlocks the potential for progressive web apps, for the web as a platform, is connecting to hardware. Now, the web, of course, already has access to a lot of hardware devices, accelerometers on my phone, game controllers, camera, audio input, audio output, MIDI devices, lots of other stuff. But I want to focus on one area that we've been working on lately, which is Bluetooth. Now, when I say Bluetooth, I'm not talking about headsets. I'm not talking about mice. Those are Bluetooth devices. But I'm talking about things like heart rate sensors. And the latest major version of Bluetooth, version 4, which is actually like 6 years old by now, I guess, introduces this thing called Bluetooth Low Energy. Now, I'm sure you've probably heard Bluetooth Low Energy, but you probably don't know why it's really exciting. But the interesting thing is that it's also really weird, because unlike other tech, like Wi-Fi or Ethernet, which consistently increase their bandwidth version over version, if you look at Bluetooth on the right-hand side here, version 4 seems to have fallen off a cliff. Like, why did they go from a transfer rate of 54 megabit to one of 0.3 megabit? Well, the answer is actually pretty straightforward. It's power and cost. The Bluetooth creators wanted to evolve Bluetooth into a technology that could be integrated into thousands of devices, like dozens of devices that you would use on a daily basis. And when you do that, you have to make sure that it's trivial to pay for, trivial cost up front, and it's trivial to maintain, and it's trivial to fund the battery, to continue to keep it powered. So when you look at this end to end, it comes down to batteries. And batteries are frequently something like this. It's a CR2032 battery. This is what actually powers the clicker that I usually use. It doesn't provide a ton of power. This won't power my laptop for very long at all. And this explains why the transfer rates are so low, because it needs to consume less power, so if it runs at a slower rate and runs the transfer at a slower rate, it'll save a lot of power. Now, you don't have to worry too much, because most of the scenarios where you're going to use Bluetooth, you're not trying to push 4K video through this, right? You're pushing control instructions for racing cars, or you're pushing data for a Bluetooth LE printer, or you're controlling BB-8, because this is actually a Bluetooth remote control robot. There are also devices like this. I actually have one of these up here. This is a Dottie LED notification display, which you can have this display anything you want. You can put custom patterns on it, but you can also set it up so that it flashes red when something bad is happening or whatever. And I usually have this sitting on my desktop and doing weird stuff. Now, I want to take a look at how this works in practice. I'm going to start with a little demo here. I have a Bluetooth LED device here called a play bulb candle. This is a mood setting LED candle, so we're going to bring the mood in here. You can buy these for about 20 bucks online. You can actually buy them a lot cheaper if you buy them in bulk. But the cool thing about this, and you can tell already, is that it changes color. It's a full color LED. And let's switch over to the remote here. Let's pull out my phone. All right. Sorry, I have to leave the light off on this because the color actually shows up then. So I'm going to open up my demo page, connect to the device, and it asks me what I want to pair with, so I'll tell it the candle. And now, from a web page with JavaScript, I can directly control this candle. Kind of cool. The candle actually, it has a few other things in here too, like I can set modes in it so it flickers a little like a real candle, it flashes or pulses, or does the rainbow effect, which personally I tend to think of as the seizure effect. But let's turn that off. Now, the really cool thing though, we actually just put this up a few days ago, is this has a sensor in it. There's a tiny little hole. You can't see it from there. Can't even see it really in the camera. But it's a sensor for when you blow the candle out. So I'm going to blow the candle out and watch the screen instead. Oddly, you can blow it back on too, which is kind of strange, but okay. All right, let's go back to the slide deck. Okay, so before I dive into the code, I need to give a few basic terms from Bluetooth. There's two roles in Bluetooth. They're the central device, my phone, a peripheral device, the candle, and this weird thing called GAT. And GAT is how these things communicate. It's a generic attribute profile. The peripheral device has what's called a GAT server, and that basically lets you ask it questions about what kind of services do you provide, what characteristics do those services have, and lets you read and write those values. So, yeah, that's pretty much what I said here. So basically, each service contains one or several characteristics, can have multiple values. Some of these are standardized, like battery service to tell the battery level is a common thing. You can query any device that supports the battery service, what level is your battery at, and it will tell you in a consistent way. Now, I want to run through some JavaScript code super fast on how to do this. We actually have a code lab on how to do this. We have a number of the devices here that you can play with tomorrow if you want. But in general, you just call navigator Bluetooth request device. You pass it some options that let you filter what devices there are, because there's tons of Bluetooth devices around in most common scenarios today. And actually, this filter list is not optional. You have to filter it down somewhat. You have to say, well, I'm looking for something that's named Playbulb, or I'm looking for something that supports battery service, or something like that. So that's what this example actually does. It looks for anything that supports battery service. Once you've selected a device, once we've popped up that dialog, the user's chosen to pair it, you have access to a Bluetooth device object, which you can connect to the GAT server, and you can ask it what it supports, or you can ask it for a specific service. Two things that I should note here. One, when you request the device to begin with, it has to be inside a user interaction, like a click on a button. And secondly, of course, like all powerful features in the web platform now, you have to do this from secure HTTPS pages. Works fine on localhost too, of course. So then you can get services and characteristics. So here you get the battery service, you get the battery level, read value, tells you what the battery percentage is. Pretty straightforward. Writing to services is actually just as easy. This is the code to write the color to the Playbulb candle. So you start out, you request the device, you connect to it, you connect to the candle service, you connect to the candle color characteristic, and then you write it, like you write a value to it. So this is pretty straightforward, although you're probably asking, wait a second, there are these magic candle service UUID values and candle color UUID. So it's possible your Bluetooth device comes with a programmer's guide. Some of them do. You can actually get one for the Dottie. But if not, you can also install whatever their control software is. Like there's a Playbulb candle app for Android. And then enable the developer option in Android settings that lets you snoop on the packets, and you can tell what characteristics and everything they're using. Now, to be notified when a characteristic changes, like when I blew out the candle, all you have to do is add an event listener on when that characteristic changes. Whenever the characteristic's value changes, the event handler gets called. I did, by the way, want to briefly connect Web Bluetooth with another project, the physical web. So physical web is about beacons, low-cost Bluetooth devices like this that just broadcast a URL. Like Bluetooth devices broadcast their presence anyways. These broadcast specifically a URL. So people in the first few rows, you may actually be picking this one up. But the goal of them is to make interacting with smart devices as simple and fast as possible. So as long as physical web is enabled on your phone, you will actually see physical web pages are nearby, and they get filtered by a web service, so this won't be too spammy. And the train that you're on can actually broadcast the link to their schedule. A parking meter can broadcast the payment app. A dog collar can broadcast its owner's contact information. Now, in the future, though, this is the cool part. This is why I'm connecting these, because this isn't a physical web talk. In the future, we're going to integrate the physical web with Web Bluetooth with a feature called referring device. So if you navigate to a physical web beacon's URL, this actually gets exposed when we load the page, that it came from a specific Bluetooth device. And when you know that, this exposes the GATT server, the Bluetooth device, directly. So if you walk up to a parking meter, you don't have to figure out then which actual parking meter am I at, because it just went to a URL. You can actually make sure of that because you're connecting directly to the device. So Web Bluetooth requires you to flip on an experimental flag in Chrome today. It also works on Chrome OS, Chrome for Android, Marshmallow, Chrome for Linux. We're diligently working on the OS 10 and Windows implementations. If you're on Lollipop, you can still use it, but you have to use a Chromium build. And it's also implemented in Opera. So to get started, if you're interested, by the way, just Google Web Bluetooth samples. It's really the easiest thing. Like I said, we've got a code lab that we're running tomorrow, and a bunch of devices to play around with. We also have a pile of physical web beacons that you can keep. We don't have enough for everyone, I don't think, so we'll figure out how to throw them at people was my idea, but they said no. With that, I hope this gives you an idea of some of the exciting areas that are going to make progressive web apps even more exciting in the future. I hope you've learned a lot today. Please come back tomorrow. We've got lots more talks from other browser vendors, partners, and you have a chance to talk with us in office hours and experiment in the code labs. So thank you very much, and I think Paul Kinlan's going to come back up and close things out.